Hello! I'm super excited to start this course with you, but before we do, we need to see where we're starting and where we're ending up so we have a clear path to success. Now, this course has over 200 HD videos and tons of exercises and projects, but they're all broken down into sections to help us learn better. The course is going to start off with Python basics. In here, if this is your first time learning a programming language, it's going to be super helpful. Even for those that know a programming language already, but don't know anything about Python, this section is going to get you caught up to speed with the basics so that you feel comfortable programming. This is a big section, so we actually have two parts. And along the way, you're going to watch me code, but also code yourself and practice coding so that you get comfortable with what Python has to offer. Next, we talk about a professional Python developer environment. We teach you how to use the terminal and the command line, about using code editors like Sublime Text and Visual Studio Code. We talk about using PyCharm, a fully integrated IDE for Python developers, and also how to use Jupyter notebooks, because we're going to use these notebooks later on in the course to do something really exciting. Hint, hint, it's machine learning. And once we have a fully professional developer environment, we then get into some advanced Python topics. Now, this section, we're not going to shy away from any tough topics, but I'm going to help you understand them and make sense of it all. We're going to talk about classes, object-oriented programming, about decorators, generators, error handling, functional programming, as well as best practices when it comes to how to write clean code. And we'll also learn about popular Python packages, how to work with files, how to test our code, how to use regular expressions, and so much more. Your head might hurt by the end of this section, but trust me, it's going to be fun. Now, most courses will be done by then. You've learned Python and you should be all set, right? Well, not really. Because once we've learned this new language, this new syntax, we have our computers set up to work with Python. We need to talk about how we can apply our newfound knowledge. This is the fun part of the course. We start talking about the careers and the career options you have in Python. Then, we get into different fields that we can use Python in. We're going to learn about scripting in Python, where we use Python to send automated emails. We use Python to process images, work with PDF files. We use Python to send ourselves text messages. We build a Twitter bot. And my favorite project in this section is we build a password checker to actually see if the passwords that you use have ever been hacked. It's a really fun one. We also talk about data scraping. A very common use case with Python is to scrape data from online and use it for something productive. In our case, we're going to learn about data scraping and how we can scrape a really popular website for programmers to only select the articles that are important for you to stay up to date with the industry. Again, it's going to be a really fun project. I know I'm saying all projects are fun, but okay, I'm biased. Give me a break here. We're also going to learn about automation, and we're going to use something called Selenium to actually control through our machines a web browser and get the machine to do different tasks as if it's a user. And there's some really fun applications when it comes to automation that we'll talk about. And then I know, everybody's two favorite topics, web development and data science and machine learning. These two sections are going to be a ton of fun, and I think are going to probably be the most popular sections. In the web development section, we're going to learn how to use HTML, CSS, and JavaScript, as well as Python, to build our own server, build our own portfolio website, put the website online, in production, and have future employers and customers message you through your website. And yes, you're going to get to customize it and do whatever you want to this portfolio website so you have something to show for it at the end of the course. And then the machine learning data science part. We're going to use something called Jupyter Notebooks and Kaggle to access some really interesting data sets. We're going to use libraries like Pandas and scikit-learn to predict which soccer players are going to be the most valuable or are underpaid. We're going to build our own machine learning model using the Iris dataset. And then we're also going to do some image detection where we can feed the machine learning model an image and it's going to predict what the image is of. And you're actually going to see how this magic of machine learning works underneath the hood. As you can see, we have a ton to cover in this course. And by the end of it all, this is all going to fit in together and make sense from the very beginning of Python basics to the very end with machine learning. We're going to take you from zero to mastery. But you know what? The best part of this course is our online community. We have thousands of developers chatting every day, helping each other out, solving problems together, and just talking about the latest and greatest in programming. Now, this is an optional resource for you to use so you can have back and forth conversations with other students and myself, so you feel like you're part of a classroom and you're not doing this all alone. But you know what? Enough talk. I know you're getting excited. I am too. So let's get started. Let's start learning and see why Python has become the most popular language in the world. What is a programming language? If someone asked you this question, can you answer it? Programming is simply a way for us to give instructions to computers. We give it an instruction manual, and the computer follows. Without code, computer programs wouldn't do anything. You wouldn't be able to move the mouse around on your screen. You wouldn't be able to Google things. You wouldn't be able to play Pokemon on your phone, right? I can't just tell my computer what to do. You see, computers don't understand English or any other human language for that matter. So what language do computers speak? Well, they speak in ones and zeros. All electronics speak that language of on or off, 0 or 1. But writing ones and zeros would be gibberish for us. It's hard for us to communicate like that, right? So humans have developed programming languages that are in between human language and machine language. That is, zeros and 1. Some programming languages are lower level than others. That is, they're closer to machine language. And other programming languages are higher level than others. That is, they're closer to English or a human language. And there are lots of programming languages. You have languages like assembly that is really, really close to machine code. You have languages like Python and JavaScript that are really, really close to English. Okay, that's great. We have these pieces, but what are we missing here? I mean, if I want to find flights to Hawaii, how do we go from here to, well, having, let's say, a website show us a display of all our flights, telling the computer to show those flight information on our screen? What are we missing here? Well, we have these programming languages that we usually write on a file, such as Python, JavaScript, maybe even Java. And then we somehow need to get these files that we write into ones and zero so that our machines can understand. Well, we need a translator, right? We take our code that we write, what we call a source code, written in a programming languages, and we give that to a translator that can understand that language, but also understands machine language. And this translator just translates these files for us. So what is this translator? It's not really a person, right? I'm not giving my code to somebody and somebody's going to just start shouting at the computer. That would be quite silly. What is this translator? Ready to have your mind blown? Well, it's another program written by a human. It can either be an interpreter or a compiler. Now, Python usually uses an interpreter, usually. And an interpreter, just like a translator, goes line by line through our code and executes our code on our machine. Compilers are a little bit different. They take your code all at once, reads the entire file all at once, and then translates that to machine code. So again, interpreter goes line by line, and each line executes an instruction. A compiler takes the entire file and turns it into machine code. Now, the differences between these two are a little complicated and beyond the scope of the course. And don't worry, we're going to come back to this topic. But I want you to just have this general picture that when we write code, whether it's Python, JavaScript, Java, C or C++, what we're doing is we're typing it in a language that is human readable. We're giving it to one of these translators, like an interpreter or a compiler, and these spit out code that are able to run on our machines. So to review, interpreters translate line by line and execute the line before going to the next line. Compilers translate all lines of a program to a file, usually called a binary, and execute the whole file at once. Now, in the next video, we're going to talk about this process a little bit more in detail, especially on how it works with Python. But why did I start with this? I mean, this is a complex topic. Most developers, especially if they're starting out, don't even know of this process. They just know that they write code and then it runs. So why did I teach this here? Because in order for us to be able to write Python code, well, I can't just write it anywhere, right? If you went right now to your computer, and let's say you opened up a text file like this one, and you started typing Python code, but for now we don't know Python. So let's just say I want to go search for Pokemon. Well, this might be code. We don't know if it is, but I can't just use this, right? I mean, this isn't really Python code, but how would my computer know what I'm talking about? In order for us to start writing Python, we need to download this translation service. And in the next video, I'm going to show you how to do that. I'll see you in that one. Bye-bye. Welcome back. We just learned what a programming language is. It's just a set of instructions that we give to a translator. And this translator can be an interpreter or a compiler. And we give these files that we create, our own code, our source code, to these translators. And they allow us to give instructions to machines, to computers, to phones. So we learned that we need these machines in order for us to write Python, right? How can we get these? Well, we download them. And here we download Python from the Python Software Foundation, from python.org. Now, before we download Python, we're going to wait a little bit. Because in this course, I want you to understand why we're doing things. Not just follow my tutorials, follow my videos, and, well, not understand the meaning and the fundamentals behind why we're doing things. You should be able to teach what you're going to learn. So let's take a pause here for a second. If this is the first time that you're learning a programming language, I have some good news for you. At the end of the day, all programming languages do the same thing. They tell the machine what to do. However, different languages have different ways of doing it. The beauty is that most languages have very similar principles. If this is your first programming language, well, this is going to be the hardest part, learning the first one. Afterwards, every new language you learn becomes easier and easier, in the sense that it's not the same as, let's say, learning English and Japanese, two very distinct languages. In programming, things become a lot easier as you learn that first foundational language. Now, if this is not your first language, and let's say you've written code in C, C++, or JavaScript, and you just want to learn Python, well, you're going to find these first couple of videos quite easy. But bear with me. Trust me. We're going to get into some advanced topics here. And we're going to make you a full-fledged developer by the end of this. But let's go back to this topic at hand, this idea of downloading this translator. The thing is, when people refer to Python, the language, they're most likely talking about the implementation. That is, they're talking not about the language itself, because Python, the language, is just a specification. You can think of it as a document that somebody wrote that says, hey, when I write the words DEF, that means something in Python. And when I write something like print, that means something in Python. But the translation machines, well, we can have tons of them, different interpreters, different compilers. For example, python.org, when you click download here, you're actually downloading this, the C Python, because it's written in the C programming language. This is what you're downloading. It's a program written in C to read your Python file and, well, run it on a machine. But there's other implementations. For example, there's the Jython project. And this is a translator that is written in the Java language. There's PyPy, which is actually written in Python. So it's a interpreter, it's a translation machine written in Python. And then there's also things like Iron Python, which is written for the .NET framework. So here's a little trick question. When you download from Python, the official language is actually CPython. You're downloading this interpreter that follows the Python specification. But at the end of the day, it's a machine built by somebody. But these machines can, well, come in many forms. So when most people talk about Python, they're talking about this one, CPython, that, well, does our translation for us. It interprets our Python code and runs it on a machine. So we're downloading this. And if you want to really get into details as to what we're downloading, well, we're downloading a machine that takes our Python code, which, don't worry, we're going to write, and it goes through the interpreter, which we download using CPython. And this CPython is going to create something called a bytecode. For example, this bytecode prints hello world on our screen. Now, this might look like gibberish to you. And even for me, I don't know bytecode. This looks pretty, well, confusing, just for printing hello world to the screen. Well, the interpreter does that automatically for us. We don't see it. It's behind the scene. Now, once it creates a bytecode that is closer to machine code, it then uses the CPython virtual machine. Again, just something that runs this code, and then this code gets run on our machine. Now, you're never ever going to be asked this question in an interview. I mean, maybe. And most developers don't know this. But I want you to use this as a reference. That when we write Python code throughout the rest of this course, this is what's happening. We're writing Python. It gets interpreted line by line and formed into what we call bytecode. And this bytecode gets run on the CPython virtual machine, which runs on our computers, our phones, our laptops. And when we're downloading from python.org, we're downloading these two pieces so that once we have them downloaded, we can run Python. All right, that was a tough one. And I mean, we just got started. I hope your brain isn't exploding. Again, this is something for you to use as a reference. But you know what? I think it's time for us to learn how to actually run Python code. And don't worry, we are getting there. We are going to write our first Python program very soon. I'll see you in the next one. Bye-bye. All right. Oh, man, we've been talking for a long time. How can we finally run Python code? I want to start coding, right? Let's download this translation service, right? Well, I'm sorry. Actually, this is something we're going to do later on in the course. And I know what you're thinking. WTF, Andre? But what is this? Kindergarten? I mean, come on. I came here to learn Python. Start teaching me Python. And I know. And don't worry, in this course, we're going to get you to have a professional setup with Python so that when you go into the workforce, you are doing what you're supposed to be doing. We're going to learn how to have all of these set up. First, we're going to have our terminal or command line where we can run Python from right in what we call a REPL. And then we're also going to use code editors like Sublime Text and Visual Studio Code. We're also going to use IDEs or integrated developer environments like PyCharm and Spider. And we're also going to use Jupyter notebooks. And I'm going to show you how to set up all of these on your computer, what the pros and cons of using each are, and how some of them might be used for machine learning while others might be used for writing quick scripts. And I know this is a lot, but it's good to have these skills depending on what type of job you want. And if you're a professional Python developer, well, you should be using most of these. But there's a problem if I start introducing this in the course right away. You see, these tools, you have to install differently based on what computer you have. So if you're using a Mac, a Windows, a Linux, maybe you're using a mobile phone. Because we want to get started right away and write some code instead of worrying about installations and making sure that your computer is all set up, I want to make sure that all of us can get started right away, no matter what device you're on. Now, if you're really keen, head on over to the section where I show you how to install all these on all of your devices so that you have it set up. And you can come back to this section. But I warn you, it's easy to run into problems and get confused when installing these tools. So I recommend sticking with what I'm about to show you, and I promise we will get you this professional setup. No other course is going to teach you all these things. But before I dive into these, we need to learn, well, we need to be able to just have fun and write some code. So what is this trick that I keep mentioning where we don't have to install any of these and still run Python? It's called REPL. You see, instead of us having to download this, we can go to repl.it. And when you go here, you'll get a login screen. Now, I recommend creating an account on here because trust me, it's going to be very useful. It's one of my favorite tools. And it allows you to save Python files just online. For example, once you log in and create an account, you can just create a new REPL, choose the language that you want to use. In our case, we want to choose Python. We can name our REPL. So we can just call it hey, and we can just create our REPL and check it out. Right away, we have, without ever downloading this Python translation service, we can actually start writing Python right here in our browsers. And this is going to work for anybody that has an internet connection and a browser because this interpreter just runs automatically here. And the beauty with REPL is that, well, you can save these files, you can have different folders. So as we work through the course, you can actually have a folder for all your Python work and just have a really nice organized file structure that you can access anywhere you have internet connection. Now, if you don't want to sign up for repl.it, it's completely free. You can also use this open source glot.io, which again, you go to Python and you're able to run Python online. So take your time, sign up for repl.it, and let's get started with our first Python program. I'm finally getting there. In the next video, we're going to write our first piece of code. No more waiting. It's coding time. So I'll see you in the next video. Bye-bye. Hey, you're still sticking around. That's good. I didn't bore you with all my talking, but yes, in this video, finally, we're going to write some Python code. Holy moly, thank God, I thought that was going to last forever. All right, so what is our first program going to do? Well, let's create a very simple function. And probably the first thing any programmer learns to do, to print our own name. So in here, once you have your repl.it set up, or remember, you can also use glot.io Python.io, we're simply going to write print. And then you see over here that it gives us some information, but all we want to do is write brackets, a quote. So you can do double quotes here or a single quote, and just type your name. And if we click run, on the right side, we've just written our very first Python program. Very exciting. But what's happening here? Well, let's look at everything. First of all, if you're confused why my thing is dark and yours might be light, it's because if I go to settings, I've set my theme to light or to dark. I prefer the dark version. But you can change some of your settings. You can change the font size if you want. Based on when you watch the video, this website, the look might be different, but most of the settings should be the same. We see that we have a main.py, which is the Python extension. Any file that has a .py or py is a Python file. So what we've just written here on line 1 is a program that prints, in this case, Andre Nagoye, or in your case, your own name, and we've written it to this file. Now, REPL.it takes this file, already has this interpreter for us. It runs this piece of code, gives this source code of main.py to the interpreter, and runs it right here on our right side. If you look over here, we're using Python version 3.6.1. And down below, we see that, we have Andre Nagoye printed. That's awesome. So this is our code running. Remember this diagram. All we've done is we have our main.py, where we wrote print Andre Nagoye. We gave it to the interpreter that the REPL already provides for us. That interpreter takes our code, converts it into bytecode, and here it'll say Andre Nagoye, and then it runs it in the CPython VM, which was on the right side that we saw. And it finally prints our name because it tells the machine, hey, we want that text printed. So that's what we're seeing here. This is the CPython virtual machine essentially running this code and telling this machine, hey, I want you to print this. All right, but this isn't very exciting. I mean, let's make this program a little bit more dynamic. For our first program, we want to do something more impressive than just print name. So I'm going to teach you another thing we can do in Python, and it's called input. Now in here, I can say input, and you see that REPL actually gives me some information saying that, oh, I have this. You can just click here. And this input over here, well, what can we do? This input is going to prompt a user, and if I hover over it, you can see how it's giving me some information. But input simply gives us a way to capture information. So let's say, what is your name? And if I run this code, we see that we have our Python code running, and it's asking me, what is my name with this cursor here? So I can actually type something here. I can say, Andre. And if I hit enter, well, there you go. I've just typed in my own name. Nothing that exciting, right? But this is where code becomes interesting because we can store this information on our computer. So again, these are things that we're going to go over in detail in our basics Python section. But just to write our first code, let's assign this to memory. That is, let's say that name equals whatever is the input of what is your name. And then finally, we can just print the name. So remember, the interpreter is going to take this first line. It's going to ask, what is your name? I'm going to type something. That typed information is going to get assigned to name. And then finally, we print name. Remember, an interpreter takes line by line, converts code to bytecode, and then finally runs it. So let's give this a try. I'm going to click run. All right, what's your name? My name is Andre. Did you see that? I typed in my name, hit enter, and then it printed out Andre. So for the final feat, let's greet. So we're going to say print hello, and then plus name. Now, don't worry about the syntax. We're going to go over it. But all we're doing is saying hello and then adding our name to the end of this. So let's see what happens. If I run this and say, what is your name? My name is Andre. And I hit enter. I get hello, Andre, but no spaces. So let's add a little space. Hit run again. For the fourth time, my name's Andre. And it says, hello, Andre. There it is, our first Python program. Now, it's not very exciting because it is our first program. We're just learning the steps here. But I hope, because we've covered some of these topics ahead of time, that this isn't just pure magic, right? You understand that this is source code. This is main.py that we give to an interpreter that runs our code line by line and then executes our program. In this case, our what is your name program. How cool is that? This is just the beginning. We're going to get more and more advanced here. See if you can play around with this. We don't know that much about Python yet, but I hope this gets you excited because, well, there's a lot more coding coming along. I'll see you in the next one. Bye-bye. Hey there, this is Andre from the future. Exactly right after I recorded the videos in the REPL, REPL.it decided to upgrade their Python interpreter to the version right here. Now, you might be asking yourself, hold on, if I go to python.org, the version of Python is higher than this. As you can see, the latest version of Python is right here. But again, REPL just takes a bit of time, so we are fine as long as the version is 3 or higher. Now, I want you to keep in mind that REPL usually implements the Python interpreter a little bit later because they have to work out some kinks, make sure that it's integrated properly onto their website. So this number might be a little bit lower than what you see on python.org, but don't worry, everything that we do in this course, you're going to be able to follow. As long as we're using Python version 3, we're all set. Now, depending on when you watch this video, this number might be even higher, but again, everything we're going to learn, you're going to be able to follow. Just keep in mind what I said before. That is that these versions are constantly going to upgrade and constantly going to evolve. In this course, we're using the latest version of Python, but because REPL now has a higher version, it allows us to do some neat things that perhaps we weren't able to do in older versions of Python. For example, later on in the course, we're going to talk about something called the walrus operator. And this is a new feature that is new to Python 3.8. And because of that, we're going to be able to use it inside of this REPL. But we're getting ahead of ourselves. You'll see that when we talk about the walrus operator. Anyway, just a quick note. Let's get back into it. Welcome back. Whenever you start to learn Python, it's unavoidable that you'll encounter this topic of Python 2 versus Python 3. So what is this all about? And it's a very important topic. Now, first of all, Python is created by a human, right? As a matter of fact, it was created by this person right here. His name is Guido. Now, a programming language is always evolving. It's not like somebody creates a programming language, it's perfect, and that's it. No, all programming languages are constantly being updated. Just like on your phone, you constantly get software updates. Well, a programming language is constantly evolving to make it better and better because nobody gets it right the first time. And by the way, this is a great video that I'm going to link to. You can check it out in the resources. Now, Python was created in 1991 by this gentleman, and it was actually created with the name from Monty Python, which was a British comedy group. But like I said before, the language is always evolving. And in 2008, Guido decided that, well, Python version 2, which has been used for a very long time, had some things that he and the community wanted to change. So in 2008, they decided to create Python 3, a new version of the language. Here was the tricky part. You see, when you update software, let's say on your phone or even on your laptop, you expect things to keep working, right? Updates are usually good, they're improvements. But some of the features that Python 2 had, they didn't like, or they wanted to change completely. So Python 3 introduced what we call breaking changes. That is, if you updated to Python 3, remember the Python interpreter, the C Python translator that we've been talking about? Well, as soon as you updated that, your Python 2 code wasn't really going to work. It's like updating your phone and then all of a sudden all your apps stop working. That doesn't sound very good, does it? That's pretty much what happened in 2008. Most companies that wrote their code in Python version 2 just kept Python version 2 because, well, for them to upgrade meant that they had to go through their code line by line and make some changes. Now, these changes weren't that significant. For example, I'll link to some resources, but don't worry, these are topics that we're going to cover throughout the course. But different things wouldn't work. For example, the print function, which we've learned about, in Python 2, it didn't have the brackets. It looked like this. And Python 3 used the brackets. So all the code that had print like this would break. Now, the differences themselves aren't that big. I mean, you can read through them and we'll talk about this in the course, but overall, you can learn them in a day. That's why when we learn Python, most of the time we're learning Python 3, but you can use the same knowledge with the older version of Python. Now, you may see some Python version 2 code out there for companies that haven't upgraded, but it's now what we call legacy. That is, come 2020, it's going to stop receiving security updates. So the community, Python community as a whole, is saying, hey, everybody start using Python 3 because we're going to stop maintaining Python 2. So we're going to learn the most up-to-date version 3 in this course, but we're also going to touch on some older topics that Python 2 covers, just in case you encounter them when you work for a company that perhaps still supports legacy code. But as I mentioned, the whole community as a whole is moving towards Python 3. This website, for example, shows you how many big packages, popular Python packages, which we'll talk about, support Python 3. In our case, there's only 4 popular packages that don't support Python 3. So what I'm saying is Python 3 is the way to go. It's the way of the future. That's what we're going to learn in the course, but I want you to be aware of the historical context. And one thing to be careful of when in this course you're searching for answers, or maybe I have some exercises that require you to Google things. For example, if we go to the Python documentation, which is the reference of how, well, what the programming language does, you'll see that you can choose the versions here. And you always want to go with the latest, but you might find some answers online that still use Python version 2. So you want to make sure that when you're searching for answers, that you don't encounter any legacy code. Like I said, 95% of the time, it's mostly the same, but you usually want to keep current with the language. It has the most community support, most up-to-date, most secure language. So, just a quick note about Python 3 versus Python 2. When you hear the word Python, people are generally just talking about both Python 3 and Python 2. And if you remember, in our REPL, when we created our first program, you see that you're using Python version 3.6. This is the default standard version that REPL comes with. So right away, we know that we're using Python 3. Awesome. It's up to date. It's new. The whole community is behind it. Well, most of the community is behind it. So we're all good to go. I'll see you in the next video. Bye-bye. Welcome back. I wanted to answer this question that I get a lot of, even from professional developers that have been in the field for years. So I want to tackle this question really quickly right now. Why are there so many programming languages? Why can't we just have one language that does everything and everybody's happy and we don't have to worry about learning so many programming languages? And here's the thing. In your career, you don't need to know 5, 10, 8 languages. No, you can be a really successful developer, programmer, with just one language, just finding that speciality of yours. And programming languages like Python, Java, and JavaScript offer a lot of opportunities where you don't need to learn another language. But why are there so many languages? If we go to Wikipedia, these are the list of programming languages. And if you're looking through here, you should be intimidated because there's no way in your lifetime you're going to learn all of these. And, well, you won't. Most likely, you're going to learn 1, 2, maybe 3 languages in your entire lifespan or career as a programmer. And different programming languages are good for different things. Just like we have different tools to, let's say, build a house. You can't just build a house with a hammer. You need different tools that are good at different things to assemble what you want. So it's impossible to build one ultimate language when we have so many applications, so many mobile phones, so many computers, so many devices like cameras. So you have low-level languages that we've talked about, like assembly code or C. And then we have higher-level languages like Python and JavaScript. Now, here's the thing. Python is usually slower than languages like C++ or C# or even Java. And we don't need to get into technical details here, but I do want to tell you about a trade-off. You see, you don't really want to write Python code for low-level systems and hardware interactions. If you're taking this course, well, you're probably not even interested in that field. You see, Python, although slower than some languages, is good at one thing and does this really, really well. That is developer productivity. Because Python is so easy to learn, or at least is very similar to the English language, it's become really, really popular for developers to be productive and write code really, really fast and less lines than something like C. So a print hello world, for example, in Python would take, well, just one line. But all languages have their different strength. For example, if you want to build an app on Android or an iOS device, well, you're not really going to use Python. But if you want to do machine learning, maybe you want to build a web server, maybe you want to do data visualizations, build scripts that process thousands of Excel files. Well, in that case, you're going to use Python. And we're going to cover what different things you can do with Python and what Python is really, really good at in this course as we explore different projects later on. But keep that in mind. The reason there's so many programming languages is that every programming language excels at some things and, well, doesn't do so well at others. It's all about trade-off. There is no ultimate language. And if a programmer tells you, hey, my language is the best language, they're probably junior developers that don't know what they're talking about. Everything is a pro and con. Everything has a trade-off. And as programmers, what really good senior programmers do is being able to detect what these pros and cons are and what tool to use for a specific problem. Something that throughout this course, I'm going to try and teach. I'll see you in the next one. Bye-bye. Welcome back. Let's do our first exercise. And this exercise is going to be really easy for you to skip, but I do recommend that you actually do it. I know it's not coding, but it's important because you'll learn that teaching somebody a topic actually helps you learn. So this is the exercise. Based on the videos that you've watched, how does Python work? But don't think about it in your head. I want you to talk to somebody. I want you to teach somebody how Python works. So the first thing you're going to do is go to our community, our Discord community. We have lots of people here. We have about 1,500 people online right now, plus some alumni, plus some star mentors. Well, there's a lot of people. What I want you to do is go to the Programming Buddies channel, if you haven't already, and find a buddy. And with that buddy, whether that person is taking a Python course or taking a JavaScript course, it doesn't matter. Just say, hey, can I spend maybe 5 minutes teaching you how Python works? And see if you can explain it to them, how it works just like you've learned. And then, after you've done that, I want you to go find a friend or a family member that has never done programming before and see if you can explain in simple terms how Python works. That is, how Python gets written as source code. We use this translation service called an interpreter to run this code and then, spit out some instruction for our machines. I kind of gave away the answer, but you know what I mean. I want you to practice teaching somebody this because by understanding these fundamentals, it's going to help you learn more and more and understand how things work underneath the hood as we get more and more advanced. All right. First little exercise. It shouldn't be too hard. I'll see you in the next video. Bye-bye. Now let's get started, shall we? In order for any programmer to learn a language, there are 4 key things that you need to really master for any sort of language, including Python. First are the terms of that language. Sometimes a programming language has different words and different definitions for these words that you're going to have to memorize. Things like statements, variables, instantiation. Really complicated sounding words, but you need to understand what they mean so that you can talk to other programmers. You also need to learn about a language's data type. That is, what sort of data can a program hold? You can think of it as values. Just like in real life, we have different ways to represent values, like numbers, letters, and symbols. In programming, we have these data types to store information. And each programming language has different sort of data types. Next, we need to learn about actions. At the end of the day, all programming is a way for us to tell our machines, hey, store this data and then retrieve this data and perform some action on it. That's all it is, just using memory and performing some actions. So we're going to learn how to perform those actions. And then finally, we have to learn the best practices of each language. There's good ways of writing Python code, and then there's bad ways. So that when we build our applications, our programs, we don't have a leaning tower like this, but we have a solid structure and a solid program. So throughout the course, we're going to learn about these things. But keep this in mind. These 4 things are what you need to become a good programmer. And I want to start the basic Python section with the data types. So let's get started. Let's learn about the Python data types, all the options we have in Python. Now we're back to our REPL.it so we can write some Python code. We see over here that we're using Python version 3.6. That's great. Let's minimize this and start writing our first Python code. Now we're going to talk about data types. And Python has several available to us. Now I'm going to list them out for you and then we're going to talk about each one individually. First, we have something called int. And you see right away when I type, I have the REPL already give me hint, and it's highlighting it. If I hover over it, it shows me that int stands for integer. We also have something called float. We have bool, which stands for boolean. We have str, which stands for string. List, tuple, set, and dict. Now, what are these? These are data types, right? A data type is a value in Python. So you can think of it as exactly that, values. So int would represent all numbers, for example. String will represent all letters, for example. And a program is simply instructions that tell a computer what to do. And what does that mean? It's all about storing information, or a data type, and modifying that information. We're taking actions on these data types. So the two crucial steps when learning a programming language is that, well, we have these data types that we need to understand that exist in a language, and then we need to learn how we can manipulate the data, create, store, read, change, remove this data from the machine. Now, these data types are called the fundamental data types in Python. They are the core to the language. Now, after the fundamental data types, we also have something called classes. So beyond these data types, we can actually create our own using something called classes. So these will be custom types. Again, something that we'll learn about. So I can create a class that I can name whatever I want. For example, supercar. Now that doesn't exist, but I can create it, and we'll explore how to do that in the course. Now, besides the fundamental data types, the classes, which will be our own custom types, we also have something called specialized data types. And these specialized data types, they're not built into Python, but they're special packages and modules that we can use from libraries. Now, again, this is a topic that we'll cover later, but these are, you can think of it as extra boosts. Whenever we don't have a data type that we want in the standard Python package, and maybe we don't want to create our own custom types, there are specialized data types that we can use from what we call modules. So you can think of it as extensions that we can add to the language. Again, something that we'll talk about later on in the course. And then finally, there's another type that is a little special called none. And none, as you can see, it's being highlighted, which means it means something in the language. None, as the name suggests, means nothing. It's kind of like the idea of zero in math. It's the absence of value. It's simply nothing. And you'll see why this is important in programming later on. So these are our data types that we're going to talk and we're going to use in our language. Now we're going to start with the fundamental data types, which are nice and simple for us to get through. So let's start one by one. And you know what? Let's start with these two for now. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about our first data type. And you know what? Let's do two at the same time. We have int and floats. Int stands for integer, as you can see here, and float stands for a floating point number. Let's explore that. First, let's start off with integer. An integer is, well, a number. 3 or 4 or 5, these are all integers. In a programming language, you can use integers to do mathematical operations. For example, 2 plus 4. If I run this, well, nothing gets printed because, again, we have to perform some action on these data types. And one action that we've learned so far is this idea of printing. And we print something by calling the print keyword with the brackets. So the brackets is almost like saying, hey, perform this action on these data types. And if we run this, we get 6 right here. Awesome. So not only are we using print, but we're also using the plus sign to perform an action to add the two data types together. And as you can imagine, we can do most mathematical operations, the basic ones. We can do negative. We can do, let's say, 2 times 4. And then we can also do 2 divided by 4. And if I click run here, all right, it looks like everything is working. We've added, we've subtracted, we've multiplied, and then we've also divided. Now here's the interesting part. Up until now, we've used what we call integers. That is, these are whole numbers. There's no decimal places, they're just, well, integers. And a neat trick that I can do here is I can actually say, hey, what's the type of 2 plus 4? If I click run here, all right, let's decipher what just happened. I've taught you another action that we can perform, which is something called type, which tells us, hey, what data type is this? And just like in math, we go bracket by bracket. So the first part, Python says, hey, what's 2 plus 4? Well, that's going to be 6. And it's going to say, hey, what's the type of 6? Well, the type of 6, that's an integer. So it's going to say class int. We don't have to worry about the class keyword for now. That's something that we'll talk about later. But we see here that we're using int for integer. And then finally, after this gets evaluated by Python, we print out whatever this does, which is class int. Now, check this out. Let's do the same for all these ones as well. So we're going to say type here, and then type here. And if this syntax is intimidating, don't worry. This is something that you get used to. If this is your first programming language, it is not going to be easy because, well, if it was easy, then everybody would be doing it. So hang in there. Trust me, as you practice more, this is going to start making more and more sense. Now, before I click run, what do you think the output of each one of these lines are? Ready? Give it a guess, and let's click run. All right, we got int for 6. We have -2 here, which is also an integer. We have 8 here, which again is also an integer. But then we have float. Because 2 divided by 4 is 0.5. What is that? Well, remember, we are talking about two data types here. We're talking about int and float. And float is what we call a floating point number. A floating point number is simply a number with a decimal point. In our case, this is 0.5. So it's a floating point number. So if we write a number, let's say we'll do print type, and then I'll say 0.00001. What do you think we'll get? Well, we would get a float. If I do 5.0001, again, we'll get a float. What about the number 0? If I click run, I get an int because, well, there's no decimal points. Why do we need to make this distinction in programming, and specifically in Python? Well, it's because a float takes up actually a lot more space in memory than an integer, right? Because remember, this number the number 6, this needs to get stored in memory on our machine. And remember that machines don't really understand this. They understand zeros and 1. And they store this number in something called a binary, or binary numbers, which is zeros and 1s. Now, the problem is when you have decimal places, like 0. Or let's do 10.56, it's hard to represent that in a binary number, zeros and 1s, because of this point. So a floating point number essentially stores these numbers in 2 different locations, one for the 10 and one for 56. Now, we don't need to get technical here, but that's the idea. The idea is that we need more memory to store a number like this than a number like this. Now, the topic of floating point numbers is really, really interesting, and I'll link to a resource. But the best way to learn more about floating points, again, it's not super important that you know the technical details. But if you go to floating point number Python, again, you want to make sure that you go to the documentation for version 3. And you can actually learn about floating point arithmetic. And these official documentation by Python are always a good tool for you to use whenever you get confused about something or you want to get a little bit more extra detail. But let's get back to the topic at hand. Both int and float are used for, well, numbers, right? And Python is going to automatically format the type to whatever, well, makes sense. For example, if in here I do 20 plus 1.1, one is a integer, the other one is a floating point number. But when I click run here, automatically Python is going to convert it to float. Let's remove these here so that we don't get confused by them. So if I run this, we see that this whole expression is converted into, well, a float. Now, if I do, let's say, 9.9 here, which will equal to 11, and I click run, these 2 floats add up to, well, still a floating point number. Because if I remove the type from here, and I click run, it gives me the result 11.0. It keeps the floating point numbers. All right, but at the end of the day, what we care about is that Python works the way we expect it to. That is, we can do mathematical operations. As a matter of fact, we can do a few other things as well. There's also this idea of the double multiply. So this means to the power of. So 2 to the power of 2, well, that's going to equal 4. 2 to the power of 3 is going to equal 8. We also have the double divide. That is, we can do 2 divided by 4. But then we use 2 slashes here. If I click run here, I get 0. This actually returns an integer, rounded down. If I do 3 divided by 4, I get 0. But if I do 5 divided by 4, I get 1. This gets rounded down to an integer. Finally, the last operator that we're going to learn about is called modulo. And it looks something like this. If I do 5 modulo, which is the percent sign, divided by 4, or modulo 4, if I run this, I get 1. Modulo is used to represent what's the remainder of this division. So if I divide 5 by 4, the remainder of this division will be 1. If I do 6 divided by 4 with modulo, and I run, I get 2. 2 is the remainder of 4. All right, let's take a break and learn a little bit more about these numbers in the next video. Bye-bye. Welcome back. Let's continue our understanding of int and float. We talked about the idea of these two data types and how we can use operations on them that we're familiar with from math class, plus a few ones that maybe we haven't seen before, such as modulo or the double slash, or the double multiply for the power of. Now, this is really cool because we can get our computers to do, well, math for us, like a calculator, right? But a programming language also provides for us different actions that we can perform. Now, besides these ones, we also learned that there's a type action that we can take, there's a print action that we can take, but there's also specific math type functions that int and float are able to use that are built into Python. Now, these are called, well, math functions. And functions, something we'll talk about later on, are these actions that we've been talking about. Remember our diagram here? We're starting to learn about the data types and the actions that we can perform on them. Now, in most programming languages, these actions are called functions. And we have a whole section on them. But for now, there's some functions that we can use. So this is a print function, this is a type function. But there's specific math functions, such as round. And you see right away when I type, REPL is a tool like an IDE that hints and tells us what we can add. So it says round and give me a number and maybe an digit. But let's just worry about the first one for now. So round, if I do 3.1 and I round here, I get 2. Well, that's not right? That's actually the result from up here because we need to also tell it to perform with a function of print. Hey, print to the screen whatever the result of this is. And just to make things easier to see, I'm going to comment this out. So I'm just selecting everything and then pressing Command/, or if you're on Windows, Control/. If I click Run, I get 3 because I'm rounding down the number. So let's say if it was 3.9, I click and I get 4. Again, I'm rounding the number. Another math function that's built into Python is something called ABS. And you see right away that I get ABS here. And ABS returns the absolute value of the argument. And again, for those that aren't too familiar with math, an absolute value simply means, well, no negative numbers. So an absolute value of negative 20 is 20. And now, because we know about math functions, I can start Googling, right? I can say, hey, I'm a Python programmer and I want to learn about math functions. Well, I can go Python 3 math functions. And look at that. Right away, Google tells me that there's a ton that we can use. You don't have to memorize all of these. As a matter of fact, some of these I've never ever used in my programming career. But it's good to know that they have these tools available to you. And as a programmer, this is something that you'll have to get used to. The idea that you won't actually memorize every single action that we can take for each data type. Because some of these are very rarely used. Some of them you'll never use in your career. The key is to understand how to Google them and how to find them. And throughout this course, I will show you the important ones that you're going to see over and over and over. But as a way for you to develop as a programmer, at least you know that this is how you look for answers and find out that, hey, there's different math functions that we can use with numbers. All right, let's take a break and continue in the next video. Bye-bye. All right, this is a big video. Now, these videos are going to be sprinkled throughout the course. They're developer fundamentals video. These are the topics that are going to be super, super short, but important because as a beginner, it's hard to learn these things because you don't know what you don't know. So what I'm going to try and do in these developer fundamentals is tell you, well, how to avoid the mistakes that I made when I got started and what a lot of people do when they get started. That is, they don't have a clear path and don't understand what the most efficient way to do things is. So with developer fundamentals, we're going to talk about key things to make you, first of all, efficient in learning Python, but also make you a programmer that is really, really good and that companies want. So what is this first developer fundamental? It's don't read the dictionary. What does that mean? Well, when you're learning a language, such as Python, you're going to have a tendency, especially when you're starting out, to try and learn every single thing, every single function, every single syntax, every single trick. It's almost like you're trying to learn a language by reading a dictionary from page 1 all the way to page, 1,200. But that's not how things work. As a matter of fact, when I work with different programming languages, I don't know all the syntaxes. I don't know all the methods and functions. And what a lot of developers do is not necessarily memorize everything, just like you would every single word in a dictionary. Instead, you understand what exists and what you can use, but you can always Google things. And most of the time, developers are Googling things, no matter how experienced they are. For example, if we go to the Python documentation here, we can go through everything, right? I can go through the language reference and read through everything. And this is really, really useful information. But you're not going to memorize every single thing about the language because there's a lot. This is the Python language, and then there's also the libraries, the standard libraries that we can use. And if you sit through here and just read everything in here, well, you're not going to memorize anything. In order for you to actually learn Python, you have to use the language. And you'll notice that some things are used a lot more than others. Just like in human languages, like when you learn English, there's really difficult words that don't get used that often. And there's words like and, the, or apple that get used very often. So we're going to learn the language in a way that makes sense, in a way that's efficient, where we focus on the 20% that gets used 80% of the time. And all these smaller, more complicated things we're going to cover, but we're not going to cover one by one from start to finish. We're going to jump around. The idea being that when you learn a programming language, you're just using these concepts and slowly you're learning what's out there so that when you have a problem, you can identify it and remember, oh, I think Python has a pathlib library that I can use. Or perhaps remember that, oh, I can use tuples in Python. So your first developer fundamental is this. Don't learn a language as if you're trying to get 100% on a test. We're going to learn a language by actually using it, focusing on the things that actually matter. All right, that's enough talking for me. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about an important term when it comes to programming, and that is operator precedence. Now, what does that mean? Again, we're using our knowledge from math class. It's the idea that if I do 20 plus 3 times 4, it means that different operators have precedence over different ones. That is, we multiply this first, equals to 12, and then 20 gets added to 12. Because the Python interpreter is going to follow a basic set of rules. For example, if I do 20 minus 3 here, and let's print this out, click run, I get 8. Because 3 times 4 gets evaluated first, which equals to 12, and then subtracted from 20. It's not that this goes first and then we multiply 17 by 4. And this operator precedence shouldn't be new, right? If you've taken any sort of math class, you understand that this is how, well, math works. And this works the same in all programming languages. So the order is this. First, we follow the brackets. So whatever is wrapped in a bracket, we do first. The second is we do the power of. So whatever is done in the power of will be after parentheses. For example, if I do parentheses here, and then to the power of, let's say, 2, or let's do plus 2 to the power of 2, well, the first operation that will happen is 20 minus 3, because that's the first precedence. And then we do 2 to the power of 2, because that's the next precedence. And then only after we do that, we add these two together. If I click run, I get 21, which again makes sense. 17 plus 4. After the power of, we have the multiplication and division. And then finally, the last precedence is addition and subtraction. Now, this isn't going to be a math class. Some people really love math. Some people really don't. But I want to just give you this basic understanding of operator precedence when you see it. We'll do some exercises here to get accustomed to it, but trust me, this is as mathy as we're going to get in this course. The math part of the course is, well, just here. It's going to get a lot more interesting as we learn about different data types. I'll see you in the next one. Bye-bye. Welcome back. This is a quick optional video that, well, with something that you probably won't use, but I want you to just know that it's out there. And that is, there's actually an extra data type that I didn't talk about, and it's called complex. And as the name suggests, it's pretty complex. However, a complex number, again, is a number that is a third type. Instead of int and float, we also have this type for numbers. Now, the reason I'm not really teaching complex is that you only use this if you're doing something really, really complex math. Most of the time, you'll never use it. I personally have never used it, but it is good to know that it exists. It's the equivalent to a real number, and you can read about complex numbers if you want. But again, that's something that you don't need to worry 99.9% of the time. Another thing I want to talk to you about is this idea that these integers and floats get stored, such as 5, in memory as binary. That is, as binary numbers, ones and zeros. And there's actually an action or function that we can use in Python called bin for binary. And you can see that a bin returns the binary representation of an integer. So it's going to return whatever the binary version of 5 is. If I click run here, well, I have to print, remember. So let's print and click run, and I get the binary representation. Now, instead of all zeros and ones, there's also this idea of b. And that is what Python uses underneath the hood to say, hey, when I see this number with 0b, that's a binary number. But if I Google binary number 5, I see that the binary number for 5 is 101, which, again, that's what we see here. So that's really cool, really interesting just to know that it exists. By the way, just for fun, let's say that we want to return this into a decimal. Let's say we're the computer and we just retrieve this binary number. I can do int and then wrap this like this in single or double quotes. And then with the int, I can also say, hey, I want this return to a number that is base 10, which is what us humans use. So if I actually do print here and click run, well, actually we have to do base 2 here, right? Because what we're saying is, hey, this number is base 2 and convert it to integer. And base 2 number is, well, 0s and 1. It's a binary number. So if I click run here, look at that. I get 5. So in your head, you can think of it this way. When we store a number like 5, an integer like 5, when a computer retrieves that number, let's say we're doing some addition, well, it's going to grab this from memory. It's going to say, well, this is a binary number, and I'm going to convert it into integer. Very, very cool. Now, the reason I taught this here, you won't see this a lot in beginner courses, and especially so early in the course, but I think it's an important principle. Although you might not get tested on this ever, for you to just understand how things are working underneath the hood, I believe is an important thing for you to do in order to become a great developer. So hopefully this doesn't confuse you too much. I'll see you in the next video. Bye-bye. Welcome back. So we've just learned about the first 2, well, kind of 3, because we also mentioned that there is such a thing as a complex number in Python. But we talked about the main ones, the int and float, and there are still a few data types remaining. But before we get to these, we are missing an important concept. And this is going to be our first important term in Python, and as a matter of fact, in all programming languages. It's called variables. Yep, that's a term. Now, if this is your first time learning a programming language, you might not know what this means. If this isn't your first time, well, this is very simple because all languages have variables. But what are they exactly? Well, variables store information that can be used in our programs. So we can hold perhaps user inputs like values. Maybe when you log into Facebook, you need to hold some information such as your profile picture, or maybe your date of birth in a variable. Variables are ways for us to store information on our computer. So let's have a look at this. If we remove this, and let's say I'm creating a quiz program, and this quiz program maybe measures your IQ. And let's say you just took the quiz and you found out that your IQ is 190. Quite high, good job. But we need to store that information somewhere. Well, we can do that with variables. So that in Python, all we need to do is name it whatever we want. In our case, it'll be IQ. And we're going to say IQ equals 190. And this IQ here is a variable. It is something that I just completely made up. I could name it whatever I want. That's a variable too. The idea is that once we assign to a variable, that is, we're saying 190 is going to be assigned to IQ, I can now use it in my program whenever I want. For example, I can later on print, or make sure it's not cap, let's do print IQ. And if I do that and click run, you see that I can use IQ. So we can pretend here that a user takes a quiz, finds out their IQ is 190. We can store that information in this variable, and later on, when they come perhaps online or try to use the program again, they don't have to take the quiz all over because, well, we store that information in IQ. And remember what I said at the beginning. Programs are simply data that's being stored, that's being changed, that's being removed, and that's all programs are. And variables are important concepts in Python and all languages. Now, variables can also sometimes be called names. So this could be a name, for example. And assigning a value is also known as binding. That is, we're binding the value 190 to this variable so that when we request this variable later on in our program, our computer knows how to look for this information. It's going to say, hey, I know what IQ is. I stored it somewhere in memory. And it's going to go look for that. And because it's being bound to a value, it points to this value 190. And remember, this number in memory gets stored as a binary representation in zeros and ones, right? But it doesn't matter to us because however our machine stores it, we don't care. We just want to be able to retrieve it, and then when we print it to do, well, get 190. Now, we're going to be using variables all over the course. But on top of just naming variables however we want, there's some best practices around variables of how you should write good variables. And as a matter of fact, these are specific rules that the Python community as a whole has that you'll just have to remember. So let's have a look at this. Variables, and remember, this is the symbol for best practices, are what we call snake case. Snake case means it's all lowercase and then spaces, well, they don't exist. We use underscores. Variables must start with a lowercase or an underscore. Variables can be anything with letters, numbers, and underscores. But remember, they have to start with lowercase and underscore. That means we can't start a variable with a number. They're also case sensitive. That means if I create a variable, but let's say this snake case, this variable has a capital E instead of a lowercase e, that'll be a different variable. And then finally, you can't overwrite keywords. Let's go through these with some examples. First, a variable has to be in the form of a snake case. That is, if I want to call this user IQ, I should technically have an underscore here instead of a space, just to make sure that a programmer, maybe I'm working on a team, can read this variable. So that's snake case. You also have to start your variables with either a letter or an underscore. So I can technically do this. And I click run. Well, that's going to give me an error because I've changed the variable. So now in order to access that variable, you have to go like this. Now, underscore in Python signifies a private variable, something that we'll go over later on in the course. But usually you're starting your variables with a letter. And afterwards, yeah, you can add numbers if you want in here. That's no problem. This is still going to work. This is a valid variable. Finally, a variable is case sensitive. So if I do user IQ here, and I do capital letters, I can't access this like this because, well, it doesn't exist. Again, it's case sensitive. We have to make sure that we match. And finally, we don't want to overwrite keywords. What does that mean? Keywords in Python, well, they already mean something in Python. For example, this print is a keyword. You can see it highlighted in blue. So that if I create a variable saying print equals 190, and then I do print, let's see what happens. We get an error because I can't really assign to this variable because print already means something. Now I know what you're wondering. What are these keywords in Python? That's a simple Google search away. And we'll learn these throughout our course. If we go to Python keywords by WE3 Schools, you'll see that we have these keywords that each mean something in Python. Again, we'll go through these and we'll learn them throughout our course. And if you look, it's not that intimidating. There's not that many. So as we practice, you'll start to get familiar with them. But the easiest way to tell whether it's keyword or an important word in Python, well, you see that it's highlighted in blue. As soon as you create a variable that is unique, it's highlighted in white. And this will be the case with whatever environment that you're typing code into, as long as it's set up for Python. Now, beyond the Python keywords, there are different things like, for example, the int for integer that we've learned. So these we're going to get familiar with. So a good rule of thumb for variables is to make them really descriptive. Really say what your intention is. And a good programmer is somebody that's able to name things really well with their variables. So if a new developer comes and looks at your code, it's easily understood. Finally, variables can also be reassigned. For example, let's say we have IQ here of 190, And then I decide to perhaps have another variable, call it user age. And for some reason, I want to assign user age to perhaps have IQ divided by 4. Is that going to work? It should, right? I'm saying user age is going to equal 47.5. I'm using IQ, which is 190, dividing it by 4, and then assigning it to user age. I can maybe assign this to another variable called user age or called A. And once again, I run this and it's printing the same thing. So you can use variables to store that information and use it whenever you want. You can use it in operations, you can use it to reassign it, whatever your program needs. Now, later on in the course, we're going to learn about classes, and classes actually have a different convention than this, but we'll get to that later on. For now though, I want to mention 2 small gotchas with variables that you should be careful with. For example, there's an idea of constants, and constants are those things that never change in a program. For example, if we wanted to create a constant, such as the value of pi, let's say for now it's 3.14, we can have it all in capitals. And that's going to tell other programmers that, hey, this is a constant. This number is not meant to change. I mean, we could change it if we want. There you go. I just made pi equal to 0. So it was stored as 3.14 in memory, but then we overrode it and reassigned it the value of 0. You can still do that, but a good convention is that if you see this, that means this number or this value should never be changed. Another type of variable that you're going to see, and this is something we'll see later on in the course, are it doesn't look like I just did double underscores here, but it's 2 underscores, and we call these dunder. And as you can see here, we have some dunder variables that Python has. Now, we'll learn more about these later on, but the idea here is that these are meant to be left alone. You should not touch them. You shouldn't create a variable with 2 underscores like this and call it hi and assign it a value. I mean, you still can, however, this is generally not good practice. So you want to be careful with that. But the one thing that I really want you to take away from this is that variables are really important concepts in programming. Naming variables is one of the most important skills you have as a programmer. I know it sounds silly, but there's so many times that I read code that is so hard to understand simply because a programmer is not descriptive enough. So throughout the course, we're going to learn how to name things well so that our code reads like English. And that's the whole point of writing good code. The point of writing good code is that it's readable and understandable by other programmers. By the way, to finish off, I just want to show you one quick trick. There's also a way that you might see in some code bases that uses something like this. Equals 1, 2, 3. And this simply is a way for us to rapidly assign values to variables multiple times. So for example, if I do print A, then print B, then print C, and I run this, you see that I get 1, 2, 3. We assign value of 1 to A, value of 2 to B, and value of 3 to C. Just a quick shorthand way that you might encounter. All right, let's take a break, and I'll see you in the next one. Let's learn another important key term. Well, 2 for that matter. One is expressions, and the other one is statements. You're going to hear this a lot when talking to programmers. So what do they mean? Let's have a look. If we create a piece of code here, let's just say IQ is 100. IQ has lowered. And then let's say user age is going to equal IQ divided by 5. An expression is this part of the code. It's a piece of code that produces a value. In our case, this produces a value, right? Because 100 divided by 5 is going to equal 20. So this is an expression. A statement, on the other hand, is an entire line of code. Not this entire thing, but an entire line of code that performs some sort of action. In this case, what action are we performing? Well, the action is that we're calculating 100 divided by 5 and then assigning that value to the variable user age. So this is an expression. This is a statement. And also this is another statement. So if you hear me mentioning these terms throughout the course, hopefully now you know what they mean. I'll see you in the next one. Bye-bye. Welcome back. I want to quickly talk about something called augmented assignment operator. So we've learned that we can create variables like some value, and we can assign it a data type. In our case, let's just assign it 5. There's something called augmented assignment operator that allows us to do something quite neat. Let's have a look. So if this value, I want to increase it, let's say 5 plus 2, so add 2 to it, I could do that. Or I could even use some value which is already 5 by the time it gets to line 3 and do something like this. If I print some value and I click run, I'll get 7 because 5 plus 2 equals to 7. So in memory, some value points to 7. But there's a neater way of doing this called augmented assignment operator. Instead of doing something like this, I could just simply add a plus to the equals. So we're going to say some value plus equals 2 is still going to equal 7. So it's the same thing as before. And this is called augmented assignment operator. It's a shorthand of us doing something like this. We can also change this to something like minus, which once again is like subtracting 2 from whatever the previous value of some value was. Now, if I was to do this at the beginning here, so let's just do here and then comment this out. And if I click run, I'll get an error because some value is not defined. We haven't really created anything. So in order for this to work, we need to make sure that this variable has some previous value. So we've learned about the plus, the minus, and then finally we have the multiply. Once again, if I run this, we get 10. Remember, this is just the same as us saying some value times 2. It's just a shorthand form. All right, this was a quick video in case you see something like this in the wild. Now, you shouldn't be afraid. Remember that the operator comes to the left of the equal sign. I'll see you in the next one. Bye-bye. All right, we're almost kind of flying through this. I know we're going slow here, but trust me, once you get these data types, things become a lot easier. So we're just climbing that mountain so that we can start looking at a higher level at the language of Python. To keep going, let's talk about this data type, str, which stands for strings. Let's see what they are. A string is simply, well, a piece of text. For example, a string can be written with quotation marks. And I can say, hi, hello there. And that is a string. You see that the color changed here in my editor. I can also make strings with double quotes. So once again, this is also a valid string. And I can put anything I want in here. I can do numbers if I wanted to, exclamation marks. It's just a piece of text. You can think of it as a sentence for now. And if I do the type function here, remember, these brackets denote that we want to perform some sort of action, which is we're using the type action that Python gives us. And if I click run, you see that, oh, and remember we have to print it out as well. So let's do print so that we can see the display. And I click run, you see that it's str. It's a type of string. Now we can use this in important ways. For example, imagine you're creating a login form and we want to collect somebody's username and password. Well, we can have username variable that we assign, let's say, some sort of username. Let's call it supercoder. And then password can be super secret. And now we have these variables, usernames and passwords that we can use throughout our program, such as to check if a password exists. And remember, I can use single quotes or double quotes. But there's a third way that we can write strings in Python. And this, well, is used for long strings. So let's just create a variable long string. And what we can do here is 3 single quotes in a row, like this. And then here, I can just say, wow, maybe a pair of eyes of somebody that's really impressed, and let's go with a mouth. That actually kind of looks like hair. All right, and then I finish it off with 3 single quotes again. So now if I print the long string and I click run, look at that. My little weird emoji face is printed. So the 3 single quotes is for long strings that I can keep going on multiple lines. For example, I can't do this with the single quote. You see that the orange color is now gone because Python is going to say this is a new line and this is another line. And it's going to give me an error because, well, a cret with a quote doesn't mean anything. But if we use 3 single quotes, you can see that we can do multi-line strings. And this is really useful if you want to have maybe long sentences and paragraphs. Now, with a string, we can do some cool things that we saw in the numbers videos. What if I had something like this? Let's say I wanted to grab the first name of a user. Just give my own name here, and then last name. And again, my super hard to pronounce last name. Could we do something like this where we have full name equals to first name plus last name? And then if we print here the full name like this, should this work? Well, let's have a look. Let me remove this part over here just so we have nice and clean looking code. And if I click run, there you go. My name is printed, but you see that there's no spaces here because we're going to use the addition sign to attach Andre to Nagoye, but you can see that there's no spaces here. So I can add a space if I wanted to, or I can just simply create another string inside of here, just like this, and then add a space in between. So we're just using the plus sign, which we've seen in the numbers videos, but instead to add strings together. And now if I click run, you see that I got the space because I'm adding a space in here, in between the names. Very, very cool. But there's a few more neat things that we can do with strings. So let's take a break, and I'll see you in the next video. Welcome back. I want to quickly touch on the subject of what we call string concatenation. Yes, programmers love creating really complex names when concepts may not be as complex. So what does string concatenation mean? Well, it simply means adding strings together. So I can do hello plus Andre, and I've concatenated the string. I've added 2 strings together. So if I print this, I get hello Andre. So if you ever hear people talk about string concatenation, that's what they mean. We're concatenating strings. By the way, what do you think will happen if I do hello plus 5? If I click run, that's not good, is it? I get type error. Must be string, not int. So it looks like string concatenation only works with strings. We'll explore that a little bit more in the next video. Welcome back. Remember in Python that string is written as str, and this is a special word. Actually, it's a built-in, what we call function, or a built-in action that we can take. Now, let me ask you this. What happens if I do string 100? 100 is clearly a number, an integer. But what if we run the string function on this? Let's find out. Let's do print here, and then run this. If I click run, I get 100. All right, but is this an int or a string? To find that out, once again, let's wrap this, so the answer of whatever this value is, into type, like so. I know this is a lot of brackets, but remember, we're evaluating this piece of code. So we're turning 100 into a string, or running the string action. And then we're going to check the type of this entire thing. And then we're going to print it out. If I click run, I see that it's a string type. So we've converted 100 into string using this. Now, just to confuse you a little bit more, what if we do something like int? Like this. All right, even more brackets. What happens now? Can you guess? Well, we convert 100 into a string, then convert it back into an integer, and then we check the type of it, which is a class int, and then we print that. So remember, this was the same as me saying a equals str 100, and then b is going to equal int of a, because we're evaluating this part. And then I'm saying c is going to equal the type of whatever b is. And then finally, we're printing c. So that piece of code was the same as doing this. Very, very cool. Now, this is the idea of type conversion. Again, if I were to write that down, it's called type conversion. We're converting the type of our data types. And you can do that throughout programming. And we'll talk a lot about this throughout the course. But it's the main reason we have things like str, int, we have things like float, and many other data types that we're going to talk about. I'll see you in the next video. Bye-bye. Welcome back. Let's talk about something called escape sequence in Python. Let's comment this out. And let me ask you a question. What if we wanted to have a string that tells me, let's say, the weather? And here we want to write, it's sunny. You see how the highlighting changed here? Because I want to say it's with an apostrophe s. But Python is reading this and saying, okay, this is the start of the string and this is the end of the string. And then I have no idea what this is, and then we're starting a string again. How can we fix this? Well, we can add a double quote string instead, and this now works. But what if, for some reason, we also wanted to add it's kind of sunny in quotation marks? Well, now we have another issue. So how can we solve this? Because in human language, we have double quotes and apostrophes. Well, we can use escape sequences here. And this is a little hard to understand at first, but it's simply adding a slash like this. So the one right above your enter on the keyboard. So this slash, when Python goes through it, is going to say, all right, whatever comes after this, I recognize this symbol. Whatever comes after this, I'm going to assume it's a string. So now if I do backslash here, and then backslash here, it's going to say, hey, Python, I'm letting you know whatever comes after this is a string. I'm letting you know whatever comes after this is a string. And then I'm letting you know what comes after this is a string. So that when we print the weather, everything is printed nicely. Awesome. Now, this escape sequence can be used in multiple ways. For example, if I want to have an actual backslash, well, I can go like this. And because it's saying whatever comes after this is a string, it's going to assume that this is a string now. So if I run this, you see that we get this backslash. And there's a few other neat tricks that you can do with it. For example, one of it is the backslash T. What does that mean? Well, let's remove this for now. There you go. The backslash T, remember, well, let's add a space in here so we can distinguish it, is going to say, hey, whatever comes after this, I want you to add a tab. This is a special meaning here. So if I click on run, you see that it's added a tab spacing to my string. Another one is using n, or a new line. So let's leave T here and then add a backslash n and then say, hope you have a good day. What do you think will happen here? If I click run, I have a tab from the backslash T, and then I have a new line after kind of sunny because I do the backslash n, which denotes a new line, so that this shows up on a new line. Now, these escape sequences are hard to see at first, but they're pretty much available in all programming languages that use strings. So if you come from another language, this shouldn't be that strange to you. If it's your first time seeing this, you just need to get used to this syntax, and every once in a while, go to the Python documentation and just type in escape sequences, and you'll see all the ones that we have. These are the main ones that you need to know. All right, more to learn in the next video. Welcome back. Let's talk about the topic of formatted strings. Up until now, we've just written simple strings. But we want a program that's dynamic, that's static. Let's say we have a Amazon page, and we're working at Amazon actually. And when a user logs into their profile, well, we want to display their name or what they have in the cart. In that case, we don't want to just hard code and write every single user's name, like Andre, or another user, Joe, and write every single name in the world. No, ideally, what we can do is have something dynamic, where let's say it's a profile page and we simply use the name variable and we display that on the page. Now, this name variable should equal whatever the user's name is. And this is something that we can grab from the database, again, something that we'll talk later on in the course. But let's assume that in here, when we do equals, we're going to grab some user information, which will be the name. And this name, for now, will be John. Or let's go Johnny. And this Johnny, we want to display on the profile page. And we can do that with formatted strings. We can simply do something like print and then say name. But we also want to greet that person, right? So let's do hi and then plus name. And remember to add a space. If I click run, I get hi Johnny. But as we get more and more information, let's say we have age and Johnny is 55. if I wanted to extend this sentence and I want to say you are, and then add another plus, make sure we add a space in here, and then add year old. Run here. All right, we get a type error. Must be string, not int. Oh boy. All right, so we have to convert this into a string. So remember, we can do that like this. And then if I click run, hi Johnny, you are 55-year-old or years old. All right, that was a little cumbersome, but we're making our Amazon page dynamic. We can grab different information from the database and we'll have in a string something according to the user. But there's a better way of doing this. And with formatted strings, all we need to do is add an F at the beginning. And this F at the beginning is going to tell Python, hey, this is going to be a formatted string. And instead of doing all this plus and name and all this stuff and doing the str to convert the type, we can simply do something like this. Let's remove this and simply do brackets and say name. And then again, remove all of this and say age. So I'm going to say hi, name, you are age years old. And if I click run here, you see that it still works. This is a new feature of Python 3. By adding F to the beginning, it's saying, hey, this is going to be a formatted string. And I want you to just make these variables available as strings inside of, well, this string. How much cleaner is that? Now, although this is nice and clean, and this is my preferred way of writing strings, before Python 3, you didn't really have this. So in Python 2, and mind you, this works in Python 3 as well, as you can see, we had something different to accomplish this. What we had was this idea of a dot format. And dot format, so let's remove the F here, is going to do the same thing for us. We do a bracket here, and then we say, hey, we want Johnny and age of 55. And we can just remove these variable names. If I click run here, I get an error. And you have to be careful here. Dot format works on strings, but you can see over here that we did it outside of the brackets. And what it's doing is saying, hey, run the format action on this print. But print is not really a string, right? So you have to make sure that we move the brackets to the outside so that we evaluate this piece of code first. So the string is going to get formatted, and then we're going to print. If I run this, hi Johnny, you are 55 years old. So that works the same way. But what if we wanted to use variables? Because right now we're just doing this by order. So whatever comes first gets filled in first in the brackets. Well, we can do something like name and age. Let's see, can we do that? Let's run. There you go. That works the same way. What if we had a specific order? Maybe we want this to be age and here to be name. Well, we can mix those around. We can say 1 here and 0 here. Because in computer science, we always start counting from 0. So this is 0 and this is 1. If we had something else in here, let's say a third variable, then this will be 2. So if I click run here, all right, everything is upside down. Finally, I can just create my own variables if I wanted to. So let's say hi, let's say new name equals Sally. And then age of Sally is going to equal, let's say 100. Sally is very old. Now, if I do 0, let's say I'm 1 here, if I click run, so now we'll actually get an error. Tuple index out of range. Now, we haven't really learned about tuples and ranges, and this is a little confusing, but a bit of a trick here. We want to make sure that we add now, because we've given the actual variable a value, we need to actually say new name here. And here will be age. So that if I click run, there you go. Hi, Sally. You are 100 years old. As you can see, with dot format, things are a little bit more complicated. You'll still see this, and all Python 2 code still uses the dot format. And you'll see a lot of Python 3 code bases that still use dot format because some people prefer it. But I would argue that the F at the beginning of a formatted string is the way to go because, well, it just makes things so much easier, right? Nice and clean, nice and easy. So I do recommend that you use the formatted string with the F in front. And for short, we usually call this an F string. All right, I'll see you in the next one. Bye-bye. Now, up to this point, we've learned that str is an ordered sequence of characters, right? It's essentially a piece of text where we can write our names, passwords, paragraphs, and sentences. And strings underneath the hood are stored in memory, as I said, as an ordered sequence of characters. So for example, if I had the string me, then this will be stored in our computer's memory in an order. So M will be stored in a place in memory, and after that place in memory, E will be stored, then the space will be stored, and then M, then E, then space, then M, then E. So if you think of a bookshelf, each one of these is ordered in a different part of the bookshelf, but one after another. And the way we can think about this is like this. The M is stored in location 0, and then E is stored in location 1, and then space is stored in location 2, and so on and so forth. And each shelf now corresponds to a value. So that when we ask the computer, hey, I want you to grab this string, we know that, hey, we're going to look in the shelf 0 to 7. Now, why is this important? Because one of the most useful things you can do with strings is to access different part of a string using its what we call an index. So for example, when you have a string, and let's call this variable or this piece of string selfish. And selfish has me. And I'm going to comment this out just like this. Make sure it's aligned, okay? And what I'm going to do here is I'm going to say selfish and then square brackets right here, and then type in 0. Now, if I print this and I click run, check that out. I get the letter M. Why is that? Well, using the square brackets, I'm telling the computer, hey, grab the variable selfish, and then from that variable selfish, grab whatever is an index of 0. And what's on that bookshelf of index of 0? Well, the letter M. What if I do 7? What do you think will happen? If I click run, I get E, because on the bookshelf of number 7, that's E. And when I'm getting just selfish, I get the entire string. It's going to say, all right, I'm going to grab from the bookshelf index of 0 all the way to 7. Very, very cool. And this concept we're going to explore throughout the course, and you're going to see why it's important very soon. But using this knowledge, we can do a lot of string manipulation. And Python has this unique feature that we're going to talk about right now that allows us to grab different pieces of text. So let's have a look here. The rule here is when we use square brackets in Python, the first item that we put between the square brackets is what we call the start. The start is, hey, where do you want me to look? In our case, we said we want to look at 0, so we got M. We wanted to look at 7, we got E. But then there's an extra thing that we can do. If we do a colon here, we also have the option to say, hey, where to stop. What does that mean? Well, if I do something, and you know what, let's change this to 0, 1, 2, 3, 4, 5, 6, 7, just so it's easier to understand. If I do, let's say, 0, colon, 2, and I click run, I get start at 0, end at 2. So I get to grab 0 to 1. Because remember, I'm saying start here, but then stop as soon as you get to bookshelf 2. We don't want that. So if I do 0 to 7, what do you think will happen? Well, I click run, and I get all the way to 6. So in order for us to grab the full string, we have to do 0 to 8. Because there's actually 8 characters here, right? Because we start from 0. If I click run, there you go. Now there's a third thing that we can add here. And this is called the step over. And the step over says, hey, start here, end here, and then step over a few things. So the default is 1 because we're going 1 by 1 through our bookshelf. You see that we get the entire string. But if I add 2 here, it steps over by 2. So I grab 0, then I step over 1, 2, grab 2, then step over 1, 2, grab 4, step over, and so on and so forth. So let me ask you a couple of tricky questions here. What happens if I do this? Is this valid? If I click run, what will happen? Ready to guess? I get 1, 2, 3, 4, 5, 6, 7. This says, hey, start at 1, so that is right here. But then afterwards, stop, well, there's nothing there. So the default is going to say, go all the way to the end. I know this is confusing, but hang in there. Practice this often enough, and this will become second nature. Okay, what if I do something like this, where I don't fill the start and do 5 here? What happens now? Ready? I get 0, 1, 2, 3, 4, all the way until 5. So it starts as default 0 and goes to 5. Okay, what if I do something like this? 2 semicolons and then 1. If I click run, all right, I get the default behavior. Because it's starting at 0 when there's nothing. It ends at whenever the string ends, when there's nothing, and then we're stepping over through it once. All right, but what if we do something like this? What if I do -1 here? This is a tricky one. What will happen? Let's find out. I get 7. In Python, the negative index means, hey, start at the end of the string. So that if I do -2, I get 6. If I do -3, I get 5 because I'm going backwards. And a neat trick that you can do here is if we do semicolon, semicolon, -1, and this is actually quite a common operation, so you just have to memorize this even though it looks weird. It means start, stop, there's no limit here, but I want to step over from the back. So what do you think will happen here? If I click run, do you see that? we get the reverse of the string. So this is a very useful notation if you want to, let's say, reverse an order. And if we want to, let's say, skip by 2, I click run, and you see that we're skipping by 2 now. Now, hopefully your head doesn't hurt with all this notation. You just have to get used to it. It's something quite unique to Python, but it's very, very useful. So up until now, we learned that strings can be accessed quite easily. And using the square brackets, we can access different parts of the string. And this idea of a start, a stop, and a step over is what we call slicing or string slicing, because we can slice the string however we like. But we also need to learn another important term that's going to come up again and again throughout this course. And as a matter of fact, it's an important concept that as you get more advanced into programming, you really need to understand. What is this concept? Well, it's this idea of immutability. It's an important term in programming. What does immutability mean? Well, strings in Python are immutable. That means they cannot be changed. What do I mean by that? Now that we've assigned selfish this value, this string, well, I can reassign it, right? I can say selfish is 100 now. And if I print selfish and I click run, that works. But if I instead do something like the first index of selfish is going to equal 8, and I click run, I get an error. I get a type error saying string object does not support item assignment. Why is that? Because strings are immutable. That is, I cannot change the value of this once it's created. I can't just immediately change it to 8, 1, 2, 3, 4, 5, 6, 7. No, it has to stay the same. The only way that I can remove this or change this is to completely reassign the value. So that in memory, Python removes all of this from our bookshelf of memory and instead just assigns 8 into the 0 bookshelf and removes everything else because we don't use it anymore. Now, this idea of immutability is something we'll explore more and more, especially when we start talking about lists. But for now, just remember that you can't reassign part of a string. Once created, it exists like that in that form. The only way we can change it is to create something new. We can do selfish plus 8, and we can create it that way. But now this selfish is a whole new string. This no longer exists, and a whole new shelf space was created for us to use this whole new string. Again, if this doesn't make sense to you or why it's important just yet, don't worry. We'll get there. For now, though, I'll see you in the next video. Bye-bye. Welcome back. So far, we've learned a few built-in functions that Python has. Few built-in actions, right? Actions that we can take on data. And we learned about str, we learned about int, we learned about float, and the type conversion that we can do. We also learned about type. We also learned about print. And these built-in functions in Python, well, there's a few of them. And I'll link to this resource, but there's not too many. As a matter of fact, we've also seen ones like ABS or round in our numbers video. So numbers had some functions that we can use, some built-in functions. Well, strings also has a very useful one called len, which stands for length. So as you guessed it, if I type in something like this and I print this out and I click run, I get 9 because it's calculating the length of the string. In our case, 1, 2, 3, 4, 5, 6, 7, 8, 9. The length of the string is 9. Now you have to be careful here because the length itself doesn't start at 0 as we've seen with indexes. Instead, it counts like humans do from 1. So a neat thing to do here is I can do something like this. Let's say that we have a variable greet that equals hello. Well, I can grab the greet variable, which is a string, and use string slicing to grab, well, the first and then go all the way until the end. Now, the default already does this. If I leave it like this, it's going to grab hello. Oh, and make sure I add a bracket here. Let's click run. I get hello. Now, if I do 0 to length of greet, what does that mean? Well, if I click run, I still get hello because the length of greet is 9. Like so. Now, this length function is quite useful and we're going to use it a lot in this course. But I want to introduce to you the concept of built-in functions, as well as what we call built-in methods. What does that mean? A built-in function had this syntax of the word that was highlighted in blue, and then we used curly brackets to perform some action on a data type. However, Python also has this idea of methods. And methods are similar to functions, but they are owned by something. So for example, in Python, we have string methods. So these are methods or actions that only strings can perform. And don't worry, this is something that we'll talk more about when we talk about classes and functions. But for now, Python, for example, has string methods. So these are methods that we can use specifically for strings. And methods have a special syntax, where instead of just the word with the curly brackets, it usually has a dot in front of it. So dot, and then some sort of word, and we've actually seen one, format, right? Dot format curly brackets or brackets is a method. And if I go to Python string methods and I scroll down or scroll up, we see that format specific values in a string, is a method. Now, why do we care? Well, with this, Python gives us automatic tools that we can use on strings. So let's explore some of these string methods. Let's create a quote here. And the quote is going to be or not to be. Now, in here, with this quote, we can use some methods on this string. Now, I'm not going to go through everything because, well, 60% of these you're most likely never going to use in your career. I'm going to go over the important ones that you'll see over and over again, but I'll also link to this so that you can see this for yourself as a reference. Remember, as a programmer, your job is not to memorize this and read a language like you read a dictionary. Instead, is to know that this resource exists and it's for you to explore and learn as a specific problem occurs. But let's get back to the task at hand. One thing that we can do is to use the upper method. We use a dot and then type in upper and then the curly brackets. And luckily for us, our editor shows us that this actually exists because of the drop-down menu. So what happens now? If I print this and I click run, look at that. Everything gets capitalized. To be or not to be. There is also another one we can use called capitalize. What's the difference between the two? Well, if I run, you see that it capitalizes the beginning of the sentence. And by the way, your editor, or in our case, our REPL, if you hover over this, it'll actually tell you what it does. It returns a capitalized version of S. So whatever is to the left of the dot. And a good editor will actually show you all the things available to you. So as soon as you press a dot, look at that. I see all these purple boxes, which are methods that are available to me for a string. And you see there's a lot of them. Now, don't worry about these double underscores, these dunder methods, because this is something that we'll talk about when we talk about classes. But you can see that you have different things that you can use. For example, you have lower. Instead of upper, it lowercases everything. What if I want to use find, for example? And find simply says, hey, does B exist in the code to be or not to be? And if I click run, well, it tells me that yes, quote.find has B and it starts at index of 3. So if I go to 0, 1, 2, and then look at that, 3. So we have find, which finds us the first occurrence of a piece of text. You also have things like replace, where I can replace whatever I give it as the first thing, and then separate it to the second thing. So you can see over here, it tells me old, and then comma, new. And I can replace this with me. If I click run, I get to me or not to me. So this replaces all the occurrences of B. Now, the final thing I want to point out to you is that if I print here, quote, what do you think is going to happen? I've printed here and I replaced to me, to be or not to be with to me or not to me. Quite a selfish quote. But if I print this again on the 5th line, what do you think will happen? Let's find out. Whoa. Is this what you expected? Think about why this might happen based on what we've learned. Here's the thing. Remember, strings are immutable. That is, they cannot be changed. We can overwrite them if we want, but we don't change them. We either create them or destroy them. In our case, when we do quote.replace to me or not to me, it's creating a new string. Now, we're not assigning this string to anything. So eventually after we print it, we remove it from memory. But if I do something like this, where I have quote 2 equals quote.replace, and I print quote 2, well, in our case, we're creating a whole new string. We're creating a string, but we never modify the original string because it's immutable. So that quote always stays the way it is. Until we destroy it, until we remove it, our program ends, this is going to exist. All right. Hope you're having fun. Hang in there. More to learn in the next video. All right. So up until now, we've spent forever talking about numbers and strings, and you're thinking, oh God, we have so many more to go through and my head hurts already. Well, you know what? I think you're gonna really like this one because this one's really short. And they're called booleans. And booleans in Python is bool. And bool, well, there's only 2 options. A bool can either be true or false. That's it. How awesome is that? You just learned booleans. So a boolean I can assign to, let's say, my Facebook profile. I can say Andre, or I can say name equals Andre. And make sure that we form this into a string. And then I can say, well, let's say we're creating an even better social network than Facebook. We're creating our own. And this social network also has the is cool option on your user profile. And let's say for now it's false. You see over here that's being highlighted. Now is cool is set to false. But all of a sudden I'm thinking, my profile doesn't look good if is cool is set to false. So I'm going to change that. I'm going to say is cool is now equal to true. Now my profile has been changed to is cool is true. Hooray. And that's it. Booleans represent this idea of true and false, which in programming is kind of like saying 0 and 1. They're logical values, right? There's some logic that we can use, and we'll see when we talk about conditionals in upcoming videos, where Booleans become really, really useful, because we can use Booleans to control the flow of our program, to do something if something is true, to do another thing if something is false. It's a cornerstone of computer science. And by the way, a topic we're going to explore more and more is this idea of using Booleans to denote logic. So for example, what do you think a bool of 1, converting 1 to Boolean would do? If I print this and I click run, I get true. In Boolean, 1 means true. A 0, well, that equals false. And remember, we're just simply converting this integer into a Boolean value. And a Boolean, well, is just either false or true. Nothing else. That's it. And I can also convert a string that says true into a Boolean true. Again, this is something we're going to explore a little bit more when we talk about conditional logic. But I wanted to make this video nice and short to let you know that, hey, not all these data types are as complex as, well, numbers and strings. All right, nice and short. I'll see you in the next one. Bye-bye. Welcome back. So up until now, we've learned about integers, floats, strings, and Boolean values. So let's try and tie some of those things together. Let's imagine you were Facebook. How do you think Facebook works underneath the hood when it comes to your profile? Well, they would have, let's say, a variable called name, and this will have your name. And then they'll probably have a variable with your age, let's say 50. I'm not actually 50, but I'm pretending to be for this case, just so I sound wiser. And then let's say relationship status. So again, we also have relationship status on Facebook. And for now, let's say single. So that's my Facebook profile right there. Now, if we wanted to perhaps change that, let's say my relationship status all of a sudden goes from single to it's complicated. Well, that's an easy fix. We would just do relationship status equals to it's complicated. And remember, because of the single quote, we'll have to do backslash it's complicated. And now if I print my relationship status, you'll see that it's been updated to it's complicated. I am no longer single. Hooray! But this is pretty simple. Let's do something more complicated. And this is going to be a fun exercise. Let's create a program that guesses your age. Let's use the input method that we've seen before. Remember, the input method allows us to type something in here and receive it as input. So we can assign that to a variable. So let's say this variable is going to be birth year, and that's going to equal the input that's going to ask when or what year were you born. Now from here, I want you to pause the video and try to solve this yourself. How can you make it so that at the end of this program, you're going to get asked, what year were you born? You're going to type in your year, and then it's going to print out your age is whatever the age is. So pause the video, try and solve this on your own. mind you, there is a bit of a trick in here. So if you get stuck, try to Google around and figure out what the issue may be. Again, part of being a programmer is trying to solve these problems that you don't know the answers to. All right, let me show you my solution. We have our birth year here that we're going to store in a variable. And now we're going to calculate the age. I'm going to say age equals, well, it's going to equal the current year, let's say 2019. And then 2019 here is going to get subtracted from whatever the birth year that you entered. So let's enter that. And then we're simply going to say print your age is, and we want to use an F string here. So I'm going to add an F here. And then simply say age. If I run this, I get what year were you born? I was born in 1986. We get an error. And if you try this yourself, you may have encountered this error. We get something called a type error. And there's lots of errors that you can get in Python. Again, we have a section on errors, so don't stress too much about it. But if you read here, it says unsupported operand type S for minus int and string. Let's try and debug this. It looks like we're using minus on an integer and a string. So let me print out here the type of birth year. If I run this and let's enter 1986, I get class string. And this is a little gotcha because what input does is it asks you for an input. But that input that I wrote, 1986, well, that actually gets converted to a string and assigned to birth year. So what that means is that we're trying to subtract a number or a string from a number. So how do we solve this issue? Well, you'd have to turn this into an integer. And this is something that we saw previously. What we need to do is to convert this into an integer with using the int function. So let's try that. If I remove this and click run, I'll say 1986. And look at that. Your age is 33. We've created a program that was able to tell your age based on the year that you were born. Now, this may have been tricky to you, but it teaches an important concept in programming. That is, sometimes you're storing data into different data types. And sometimes you need those different data types to interact together. So you'll see a lot of problems where you have to convert a data type. And this is a very common one where you take an input that's a string and then you convert it to something like an integer. So you can perform a mathematical operation. And that's why, if you remember, we gave you a list of all our data types in Python, the fundamental data types, and all of them were blue because, well, each one of these are actions, are functions that we can use. For example, I converted the birth year into integer, but I could have also converted this to a float, for example. And if I run this, it would still work because Python knows that, well, we can use integers and floats in mathematical operation, but you can see here that it's converted into a float now. If we convert this into a Boolean, and I click run, your age is 2018. That's really confusing, right? Well, that's because this gets turned into true, and underneath the hood, Python does something weird, where a true value is converted to 1. Because Boolean, remember, it's 1 or 0, true or false. All right, hopefully this didn't confuse you too much. It's something that we'll encounter throughout the course, so don't worry, we'll get more and more practice. However, I hope you get to practice this a little bit to really understand what's going on, because although this is a couple of lines of code, the principles that we use here, we're going to use throughout bigger and bigger code bases. So I guess I'll see you in the next one. Bye-bye. Let's talk about another developer fundamental. And this one is commenting your code. Up until now, you may have seen me add comments to our scripts. For example, right here, I added a comment of booleans. And this tells the Python interpreter, hey, this is a comment, don't run this, it's just for me, you can just ignore it and skip over to line 2. And you saw that I simply did that in Python with the pound sign. As soon as Python sees a pound sign, it adds a comment. And you can do that after a line as well. I can say, this assigns to a variable. And although this may look like 2 lines, it's actually just the word wrapping that's happening. And you can see that the interpreter just completely ignores these comments. Now, commenting sounds very, very simple, but it's an important concept. And if you want to be a good programmer, in all languages, we have commenting. But there's good ways and bad ways of commenting. And this is something that comes with practice. But here are some key guidelines. When you're commenting your code, the idea is that you're adding valuable comments. That is, if I add a comment here that says, hey, this is assign name variable a value of Andre string. A comment like this is not really good. Why is that? Well, because your code should be self-explanatory, right? The idea is for us to write code that is easy to read, easy to understand. It's not trying to be clever. Instead, it should read like English. And any Python programmer would know that here we're just simply adding Andre as a value of name. We're assigning a variable. And adding a comment like this that's self-explanatory just adds clutter to your code. So there's a trade-off here. It's good to comment your code for, let's say, if you're working on teams and other developers come and they want to understand your code. But you have to remember this principle of code being easy to read. The only time you want to add comments to your code is, well, when something really, really important is happening, where it might be a little complex. You first decide, hey, is this code written in a way that makes sense? For example, if this was variable A and this was variable B, well, this might be really hard for somebody to understand. So you might say that this is cool flag. But before you add that comment, you want to say to yourself, maybe my code is hard to read. Maybe I should just change the variable to is cool to make it more understandable. Now, this is something that you improve upon more and more. And you do want to use comments as an extra tool to make your code understandable. Maybe you write code that 6 months from now, you want to go back to understand what you did. But remember, more comments doesn't necessarily mean better code. You want to be concise and keeping things simple, while adding comments only when necessary to help others understand your code, not trying to make your unreadable code more readable. We'll explore this topic and give you advice on it throughout the course. But remember this key developer fundamental, because you're going to need it throughout your career. By the way, this article over here has some really important points that I think you'll really benefit from, especially in the commenting best practices. You can read some of the do's and don'ts and what some of the top programmers do when commenting. I know it sounds silly, but it is an important concept that most courses overlook. So I highly recommend you read over this. I'll link to it in the resources, and I'll see you in the next video. Welcome back. Let's try and do an exercise to tie everything that we've learned up until now together. We're going to create a password checker. Now, what we want to do is to create some sort of an input that we're going to ask. So we're going to use the input function. And here we're going to ask for a username. Then we're going to ask for another input. It's going to be the password. And then at the end, with the input, we want to print something the lines of password, and then we'll have maybe the actual password in here, and it will say is another variable here, long. So what we want to do is the password, and then maybe the password length, so that, let's say we printed our username, JJ, and then we give it a password of secret. Well, we should print the password secret is 1, 2, 3, 4, 5, 6 letters long. Now, obviously, we don't want to show or display the password, maybe for security reasons. So we want to convert the secret to 1, 2, 3, 4, 5, 6, 2 stars. So your task is to convert these two inputs. And you know what? Let's also do a greeting where we say the username here. So we're going to say, hey, JJ, your password, which will be marked in a star, is 6 letters long. Now, one neat trick here that you haven't learned yet and you might want to use here is this that you can do with strings. I can go star times, make sure that the star is a string, multiply it by 10, and if I print this out, I get 10 stars. So you may want to use this functionality when we're doing this. All right, pause the video, give it a go if you can. Remember, the goal is to print the username and have the password blocked with how many characters the password is. All right, pause the video. If not, I'm going to get going with the answer. So the first thing we're going to try and do is I'm going to create two inputs. So the first one, I'm going to get the username. I'm going to assign it to the variable username. And it's going to say, what is your username? Then the second one will be the password. And the password, well, we'll say, what is your password? And although this is a simple example, this is something that you will see with other big websites like Instagram or maybe Netflix when you're logging in. So now that I've stored this information into a variable, I can use it, right? I can print, and we'll do an F string to make our lives easier. So I've added the F here. And what we'll do is this. We'll say username, your password, and we'll add the password here, is, and then we'll add another variable here, which is the password length. So how are we going to calculate that? Well, let's try something here. Let's see if I can use the length function and in here do password. Let's see what happens here. What is my username? Let's go with Andre. What is my password? Let's just type in secret here. And I get, Andre, your password? Well, I can't speak English properly. My password, secret, is 6, well, 6 what? Let's write 6 letters long. Awesome. So this is working because with an F string, I can create or add a Python expression in here using the length password. But there's an issue here, right? We don't want to actually print out secret. We want to print it out in the star form. And this is a good discussion topic on readability of your code. Now, this is a simple example, but we can make this code a little bit cleaner. For example, we can break things down so that we'll have password length will be length password. So we're calculating the length. So this is going to store 6 or whatever the input of our password is. And it's nice and descriptive. It's easy for other developers to understand. And then in here, I can also have hidden password. And this hidden password will be the password length. And we're going to use that star string and multiply it by the password length. Let's make this a little bit bigger. So that now our code can be understood, well, in an easier fashion. So we have the password length. So we're going to say username, your password, but we want to make sure that it's the hidden password. So we'll copy this over here. So username, your password, we're going to print out hidden password is, and then we're going to copy password length. Now, I argue that this reads better because each line is doing something simple, and then finally, we're printing the output. And although this is a small, simple example, this idea of readability and making and writing code that makes sense is an important concept. So let's see if this works. I'm going to click run. My username, Andre. This time around, my password is going to be super secret. And look at that. Andre, your password is 11 letters long. Good job getting this far. Hopefully you got that. I'll see you in the next video. Welcome back. Let's talk about our next data type. And it's a big one, a very, very useful one. It's called list. And list is an ordered sequence of objects that can be of any type. So you can think of them as strings, right? We had strings previously that we learned about, except that each sequence of this string, well, was a string, was a letter or a number wrapped in quotation marks. Lists, on the other hand, looks something like this. Let's say we create a variable, li, and lists we denote with square brackets. And inside of these square brackets, we can have different objects. So for example, we can have 1, 2, 3, 4, 5. We can also have, let's say, li2, and this is going to have a B, C, and it can have any collection of items that we want. We can even mix and match and say that we have 1, 2, then A, then maybe even the Boolean value true. So all of these are lists. Now, lists are extremely important. And in other programming languages, you might have heard the word arrays. So in Python, lists are a form of array. And later on, when we get into the modules section of the course, we will talk about the difference between lists and arrays. But if you are coming from a different programming background, then lists are like arrays in your language, a collection of items. Now, the neat thing about lists is that it's the first data structure that we're learning. Now, what is a data structure? Data structure is a very important concept in programming languages. It's a way for us to organize information and data into, let's say, a folder or a cupboard or a box, so that These data structures can be used with different pros and cons. For example, you have a fridge where you store your food. And fridges are really, really good at putting your food inside, keeping it cold, and then taking it out. Or you might have a backpack. A backpack is really, really good to stuff everything in there, but when you're looking for things in a backpack, it's really, really hard. So you can think of data structures similar to that. A container around your data that has different pros and cons of accessing that data, removing that data, writing data. But that's something we'll get into a little bit later. The key here is that these square brackets allow us to contain information and data like strings, integers, floats if we want to, booleans, into a contained fashion. So let's think of a good example here. What if we had a shopping cart? Let's say we're Amazon here. And then Amazon has the Amazon shopping cart. And in here, we can collect different things that we want. Maybe we collect some, I don't know, notebooks. And you know what? Let's get some gadgets. Let's get some, maybe some sunglasses. We can add different items here, different strings, different data into this cart. And now, just like we saw in strings, we can access the Amazon cart in different ways. For example, I can access it, again, with square brackets, and simply say I want item 0. So if I print here and do Amazon cart, look at that, I get notebooks. The second item, I get sunglasses. What about the third item? Nope, list index out of range. But this should make sense now. This is a list where we're accessing the index of, but it only contains 2 items. So if we're going 0, 1, 2, the third item, nothing exists. So our program says, that doesn't work. You're doing something wrong. And just like strings, these list items are in memory, in their separate bookshelf, right? But one right next to each other. So we can go 0, 1, 2, 3, 4, 5, so on and so forth until the list ends. All right, let's learn about lists a lot more in the next video. Bye-bye. Welcome back. Let's continue with lists. Now, so far, these square brackets, we've seen them before, right? We saw them when working with strings. And just like strings, lists are quite similar in that we can use list slicing. If you remember, with string slicing, we had things like hello, and we were able to assign it to a string, let's say a variable string, and we could do string and then slice. So do something like this, where we had the start, the stop, and then the step through. So that we start at index of 0 and end at index of 2, and then go one by one. So list slicing is also available to us. So let's make this cart a little bit bigger. And you can actually just make things cleaner by formatting it this way. All right, so what should we add to our cart? We'll also add some toys. And then, you know what? Amazon does groceries now, so let's add some delicious grapes. Awesome. Now, let's say I wanted to get every single item in the cart. Well, we just simply do this, and we have our entire list. But let's use some list slicing. Let's say I wanted to grab from the first item to the second item. If I click run, I get notebooks and sunglasses. Maybe I want to go all the way till the end, but skip every second one. I get notebooks and toys. We start at 0, we step over to toys, and we step over and we're done. Awesome. And this is something that we've already seen when talking with strings. Okay, but here is where it gets interesting. Remember how I said that strings are immutable? That means we can't change them, right? And we talked about this when we had a string like hello. I couldn't do greet 0 equals to, let's say, Z. I'd get an error here. I get str object does not support item assignment. It's immutable. But the interesting thing with lists is that they are mutable. So that if I change my Amazon cart and say that, you know what, I don't really want notebooks. So I'm going to grab the first item, which is notebooks. And instead of notebooks, what do we want? We'll say we want a new laptop. It's a big upgrade. When I print this Amazon cart, look at that. I'm able to change this list. And it didn't give me an error. In that sense, lists are mutable. We simply replace on the memory bookshelf of our computer notebooks, and I say, hey, change it to laptop. And they let us do that. Okay, so that's awesome. But let's try something here. What if I create another print here? And in the Amazon cart, I'll use list slicing. So let's say I want item from index of 1 all the way until index of 3. Let's run this and see what happens. Try and guess. Is that what you expected? Let's go through this code. When we get to line 10, we grab the Amazon cart, which has been updated with laptop, and I grab item 1 to 3. So that is sunglasses to toys. So 0, 1, 2, and then we stop at 3. Just to make this easier to understand, let's start off with 0 here, so that we see that laptop has been changed. And then here, in the second one, on line 11, we print the Amazon cart. But hold on a second. This list did not change. And that is because with list slicing, we're creating a new list, a new copy of this list. So here we're creating an entirely new list so that I could actually assign it to a variable. New cart is going to be Amazon cart. And let's just do the same thing here. And new cart is an entirely new list on its own. I could change new cart, let's say 0 into, let's say, gum. And if I print this, you see that I have 2 new separate lists. But a list is mutable because I can change whatever is at the index anytime I want. And every time we do list slicing, we create a new copy of that list. But I have a tricky question for you here. What happens if I just do this? If I run this? Did you see that? Instead of slicing my list, I simply said that new cart is going to equal the Amazon cart. And I changed the new cart, index of 0, to equal to gum. But now my Amazon cart got modified as well. Why is that? And this is a bit of a tricky question that you might encounter in an interview. The reason is that right now, the way that I did equals means that, hey, new cart is going to equal Amazon cart. And what does Amazon cart equal to? Well, Amazon cart points somewhere in memory in our machines that says, hey, this is what Amazon cart is. So because here we're not copying the list, instead we're just saying, hey, the value of new cart is whatever is in the memory of Amazon cart. We now, when we modify new cart, are simply changing the Amazon cart all the way back from here. So this is an important concept. If you want to, let's say, copy a list, then you do something like this, where you copy the entire list, and this is something that you'll see a lot in code bases. But this line is saying, hey, I want to create a copy, use list slicing to copy this Amazon cart, and it's going to equal new cart. So that now, if I run this, you'll see that the original Amazon cart stays the same, but the new cart is now something different. This is a quick gotcha that you just have to get used to, but it's an important concept. This idea of copying versus modifying the list. And it's something we'll explore a little bit more in the next couple of videos. For now, take a break, and I'll see you in the next one. Bye-bye. Welcome back. I want to talk to you quickly about something called matrix. And a matrix is a way to describe 2D lists or multi-dimensional lists. What do I mean? Well, I can create a matrix, and this is a name that I just made, so I can call it whatever I want. But usually these are called matrix in programming. And it looks something like this. It's an array with another array inside of it. So let's say, for example, I have 1, 2, 3 here, and then another array, 1, or let's do 2, 4, 6, and then another array, 7, 8, 9. What's happening here? Well, it's a two-dimensional array. We have the main array, and then we have sub-arrays. 3 arrays to be exact. Now, why is this useful? And by the way, this is two-dimensional, but we can have multiple ones. For example, we can have another array inside of this array. But why is this important? These type of matrices come up a lot in topics like machine learning or image processing. For example, a computer doesn't really know what a photo of a dog is. The only thing it understands is zeros and ones. So a lot of photos, for example, let's say we had a very simple photograph of a giant X, maybe this letter X. Well, a computer can understand an image based on pixels on the screen. So maybe we can have 0, 1, 0, 1, 0, 1 here, 0 here, and then 1. And right now, a computer can look at this. And if this represented, let's say, a tiny little pixel here, or maybe a pixel here on my screen, the computer is going to say, oh, there's a 1 here, so that means I should make this green in this corner, then dark here, then green, then dark, green, dark, green, dark, green. And a computer is able to draw, let's say, an X. And this is a simple example. And using matrices, we can do a lot of these heavy calculations. And that's how computers work underneath the hood when, let's say, for example, it's trying to display something. But the reason I wanted to talk about this here is when you want to access a multi-dimensional list, well, you would do something like this. Let's say matrix, access the first item in the matrix, which in this case will be this first array because it's the first item. And then let's say we want to access the 0 in here, or let's change this to 5. Well, I'll do square brackets again and just do 0, 1. So if I go 1 here, and let's print that out. And I click run, I get 5. So it's accessing the first item in the array. So it's going to look at the first outer array, grab the first item, which is right here, and then grab the second item in that array. So 0, 1, which is 5. And you can keep doing this. If you had multi-dimensional arrays, you can keep adding, keep adding, keep adding to access that information from an array or list. But remember, in Python, we want to use the term list. I'll see you in the next one. Bye-bye. All right, let's learn about some actions that we can take on lists. And this is very exciting because you can perform a lot of actions on lists. Now, we've learned about built-in functions, right? Functions that come with Python. And we've actually seen this one before when we talked about strings. which is the length function. And here we can have it calculate the length of a list. So for example, if we had a basket here that had 1, 2, 3, 4, 5. Well, this basket, if I calculate the length of the basket, let's do print here so we can see the result. And I click run, I get 5. The length of the basket is 5 because, well, there's 5 items. Remember, a length is the actual length. It doesn't start counting from 0. It's going to do human length, which is 5. But lists get really powerful when it comes to methods. So instead of a built-in function, remember, a method is an action that's owned by something, and it's specific, let's say, to a data type. So if we go to list methods, you'll see that Python has a few list methods that we can use. And the way we use these methods is, remember, we just add a dot after a list. So let's have a look at some of them. First, I'm going to start off with the adding ones. So let's say in this basket, we want to add something to it, to the end of the list. Well, we can use the append, and remember, with a method, as soon as you write the dot, it'll tell you what we can use, which is very, very useful when you have an editor. So the first one is append. And if I hover over this, well, it just tells me appends an object to end. And in Python, an object is, well, everything in Python is an object. A number is an object, a list is an object. So just think of it as an item for now. So if I want to append, let's say 100 to the end of the list, and you know what? Let's add a new list here, and this new list will do the append for us. If I print the new list and I click run, I get none. That's weird. What if I print basket here? If I click run, all right. So it looks like the basket was appended to, we added 100, but a new list, when we assigned it the basket.append, that new list is completely none. And that is because append changes the list in place. What does in place mean? It means that it doesn't produce a value. All it does is saying, hey, I'm just going to append 100 to this basket that you gave me. But I don't really care. I'm not producing a result. I'm just changing this for you. I know it's a little confusing. So in order for our new list to have that 100 at the end, we have to do something like this. If I click run, there we go. After we've appended to the basket, then we can assign, so that new list points to basket, which points to this list that was modified. All right, what else is there? Well, there's also something called insert. And you see over here that insert gives an index and an object. So we can insert something, not at the end of the list. I mean, we could, but we can also insert it anywhere we want in an index. So for example, in this case, if I do insert 100 at 0, 1, 2, 3, 4, so let's do index of 4, and I click run, I've added 100 to the index of 4. If I do index of 5 and I click run, I've added 100 at the end of the list. Now let's try and copy this and see if we can just add it into here. If I click run, again, same thing. Insert modifies the list in place. It doesn't create a new copy of the list. All right, and if we add this like this, well, once again, insert modifies the list in place. That is, it doesn't really output a new list, it just modifies whatever is existing in memory. Finally, there is another method called extend. And extend, instead of an actual item or object, takes what we call an iterable, which we're going to get into later on. But it's something that you can loop over, you can iterate over, which is a list. So we just give it another list, like let's say 100 or 101. So if I run this, once again, it doesn't output a new list. It just modifies the list in place and adds on or extends our list. And we can also just give it one item. All right, let's keep going with the removing methods. Now, with the removing, we once again have a few fun things that we can do. So let's continue with this basket that we've been using that now has 100 included into it. And the way we can remove things is, well, there's a few ways. First one is basket.pop. And basket.pop, if I go like this, and let's print this basket, I'm going to comment out the new list for now, since we're not using it. And then we're going to say basket.pop and then print basket. Let's run this. And pop pops off whatever is at the end of the list. In our case, at the end of the list, because we've extended the basket to 100, that 100 gets removed. If I do basket.pop again, not here, down here, and I run, you see that both 100 and 5 get removed. What if I do pop 0? If I click run here, it removes the item in the index. So here, pop 0 is going to remove whatever is at index of 0, which is 1. Now, there's also .remove. Remove, again, is we give it a value that we want to remove. So in our case, let's say we want to remove number 4. Well, if we run this, it's going to remove 4 for us. So remove, we give it the value that we want to remove. With pop, we give it the index that we want to remove. And just to see if this is working, let's add a new list here. And we'll say new list equals basket.remove. Add a new list here. See if that gets modified. Nope, it does not get modified. That means remove is working in place. It doesn't return a value. It just simply changes whatever list you give it. What if we do pop? If I run this, I get 5. Why is that? And this is something that you just have to get used to. Different methods do different things. For example, pop, the way it works is that pop returns whatever you have just removed. In our case, when we did 4, that is index of 0, 1, 2, 3, 4, it returned the number 5 for me. Even though it removed it from the basket, it still returned something. And the reason for others is that we got none. That is when a method doesn't return anything. It returns none, a topic we're going to cover shortly. So you have to be careful and understand what each method returns. If I go over extend, I see here that this little arrow shows me that none is returned. That means it's not going to produce anything with this method. It's only going to change or extend a list that it was given. Don't worry if this is confusing. That's something that you're going to get used to as we get more and more practice. Now, the last removing method I want to show you is clear. And clear, as you might guess, if I click run here, well, this is none. But if I go to basket, and I click run, the basket is empty. Clear removes whatever's in the list, completely clears it. just as the name suggests. All right, that was a lot, but there's still a few more. So let's take a break and I'll see you in the next video. Bye-bye. Welcome back. Let's keep going with some more string methods. Now we've learned about adding and removing ones. We learned about append, insert, and extend. And then in removing, we learned about pop, remove, and clear. There's a few other important ones. Let's go with the index. So instead of clearing here, let's clean this up. And we'll do basket dot index. And index, as you can see, we give it a value, a start, and a stop. What does that mean? Well, we want to say, hey, what index is number 2? If we do index of 2 and I click run, it's going to give me 1. I know this is a little confusing, but it's asking for the index. Where is number 2? Number 2 is at index of 1. Let's change these into letters just so it's more clear. So we have A, B, C, D, and then finally E. And again, if I do D here and I click run, I get an index of 3 because 0, 1, 2, 3. It's on shelf 3 in our memory. And you can also do a optional parameter here, which is where should we start looking? So I want you to start looking at index of 0 and then finish looking at index of 2. If I do run here, I get an error. It says, hey, D is not in list because, well, we started at index of 0 and stopped at index of 2. If I do 3 and I click run, no, it stops right before 3. So if I do 4 and I click run, there you go. I get 3. Now, errors are not good in our programs. Ideally, we don't want to get errors. So how can we avoid this? What if we're looking for something and we're not sure if it's in the list or not? There's another nifty way of looking for things in a list. And this involves what we call a Python keyword. A keyword is something that you use in Python that, well, already has some meaning. For example, a keyword here, if I go to Python keywords, are all these words that already mean something. Now we're going to go through them, and we haven't seen a lot of them yet. But we might have seen true, right? In Boolean values, true means something. So in Python, we can't really use the word true because, well, it already means something. There's a word called in that, as you can see, as soon as we type, means something, is a keyword in Python. And this is quite nice. We can say, hey, is D in basket? And if I run this, I get true. Okay, is X in basket? I get false because, well, it doesn't exist. And this is actually quite useful, and we can even do it for strings. For example, if I'm looking for, let's say, the letter I in a word, and let's say it's I in hi, my name is Ian. If I click run, I get true because the letter I does exist in this string. All right, let's learn another one. Another one is basket.count. And we can count how many times an item occurs. So for example, if I do D and I click run, I get 1 because D only exists once in the list. But if I add another D in here and I click run, we get 2. It counts how many times this value occurs in our list. Very, very useful. All right, a few more still to go. Let's do some exercises and I'll see you in the next one. All right, it feels like it's never going to end. We have so many methods with lists, but like I said, lists have a lot of methods because you can do a lot with them. It seems like a lot right now, but trust me, these are going to become second nature. So hang in there. I have a few more to show you. The next one is called sort. Guess what sort is going to do? If I click run, I get none. But remember, sort sorts the list, as you can imagine, in place. That means it modifies the list. So if I remove this up to here and then do sort or do basket, and I click run, look at that. I get a sorted list where D was moved in front of E. If I add, let's say, X at the beginning here, and I click run, it's going to move the X all the way to the end. It's going to sort the list in place for me. Again, if I hover over, it sees that it's going to not return anything, which is why our print initially didn't work. We had to print our basket, not whatever this produces, which it doesn't produce anything. But what about this one? If we go to built-in functions, I have something called sorted. And if I do sorted, and because it's a function, not a method, I can do sorted dot or basket. So around the brackets, just like print. If I run this, all right, nothing has changed, but what if I remove this and put it in here? If I click run, I get A, B, C, D, D, E, X. What if I comment this out? So that we're not sorting it anymore. We just have the basket and then we run this sorted function. If I run, did you see that? Sorted, I know it's confusing. Why do they even have two? But sorted produces a new array. So if I do print basket here and I click run, the basket hasn't been modified. The basket still remains the same. It's this one over here that's not sorted. Sorted, on the other hand, doesn't modify the basket in place. Instead, it creates a new copy of the basket and sorts it. It's almost as if we're doing this. We're saying new basket equals basket, and then we're going to copy that basket. Remember, list slicing. And then we're performing new basket dot sort on this new list. So that if I do new basket and I click run, we get the same thing. So you have to be careful of certain actions that perform an action in place or create a completely new list to begin with. By the way, there's also, instead of this, a dot copy method that we can use. And if I run this, again, we get the same thing. Copy, just as the name suggests, copy the list for us and returns for us a new list. All right, one last one, and that is basket dot reverse. What do you think this does based on the name? Well, if I check out the basket here and click run, is that what you expected? It reverses the basket in place. But notice that it's not like sort. It's not sorting. It's simply switching all the indexes into opposite sides. So D is now index of 0, E is now index of 1, index of 2, 3, so on and so forth. So you can see here that it doesn't actually sort it. Instead, what we might want to do is sort first, then reverse, and if we click run, we have a sorted, reversed basket. This is a little tricky one that some interviewers might ask. All right, good job getting this far. We're almost done with lists. So I'll see you in the next video. Bye-bye. Welcome back. Let's talk about some useful tricks with lists that you'll see a lot in Python code. Well, one we have already seen. It's this idea of length. You're going to be using this a lot. That is to figure out the length of a list, which in our case is now 7. Another really useful trick is to reverse a list. Now, I've already showed you how to reverse a list, but sometimes you can do that with list slicing. Again, something that we've seen in string slicing. So I can actually do basket and then semicolon, semicolon, -1. If I click run here, is that what you expected? Let's go through this line by line. I've sorted the basket so that it's from A all the way to Z. And then I've reversed this so it's in Z all the way to A. And then I've reversed the basket again so that instead of being in reverse, it's now in order. A, B, C, D, E, X. And this list slicing creates a new list, right? If I print basket here, you'll see that the basket is the reversed version, the last action that we've taken on it, versus list slicing that creates a new version. So this notation you'll see a lot with lists when you need to reverse a list, or maybe you need to make a copy of the list like this, or maybe you need a portion of the list. Another useful thing that you'll see a lot of is something called range. Let's comment this out for now. If I wanted to generate a list really quickly, let's say from 1 to 100, I can do something like this. I can say range and then start and then stop. So let's do 100. And if I print this and I run, I get a range 1 to 100. But if I wrap this in a list, which is going to create a new list for us, and I click run, look at that. I get a range from 1 all the way to 99. Remember, it's the start and then whatever to stop at. So before it hits 100, it's going to stop. Now, if I remove this and just do one single thing, I get a list starting from 0 all the way to 99. If I want a list that has 101 items because it starts at 0, I would just do 101. And range is something we'll talk about a lot more, especially when we talk about loops in programming. But this is a great way of you to generate a list really, really quickly, especially a numbered list. Finally, the last common thing that you'll see a lot is this idea of dot join. What is dot join? Join is actually something that works on strings. It's a string method, but it's often used this way. We have an empty string, and this empty string, let's say sentence. And then we can do sentence dot join, and join takes what we call an iterable, which is a list for now. And in here, we can have a sentence like, hi, my name is Jojo. And now if I print sentence and I click run here, I don't get anything. Let's figure out why. What if I type in an exclamation mark here and I click run? All right, it's printing out sentence, but it looks like .join creates a new item for us. So let's just assign that to new sentence. Now, if I do new sentence and print that out, we see that I get, hi, my name is Jojo. So this is a little funky. Right, we have these exclamation marks between our items. And join joins these little iterable items, these lists, by whatever is in front of it. So if we actually change this to an empty string, click run, we now get this. If I add a space in between and click run, we get, hi, my name is Jojo. And sometimes you'll notice this pattern a lot, especially if you want to join and create a new string out of a list of items. Now, a shorthand way of doing this is to actually not even bother with this and just doing an empty string, dot join, and then joining all the list items. There we go. So all we're doing is combining lists into a string, and this is a common pattern that you'll see a lot of. I'll see you in the next one. Bye-bye. I want to teach you one last thing when it comes to lists, and it's called list unpacking. And it's a really, really nice feature. I really like it. With list unpacking, we can do something like this. Let's say I have a list that is, well, very simple, 1, 2, and 3. And I want to assign a variable to this list. Let's call it basket equals 1, 2, 3. But what if I wanted to assign a variable to each item? Well, I can actually do something like this, A, B, C. So that when I print A, and then let's print B, and then print C, and I click run, I get 1, 2, 3. And this is something that we've seen when we talked about variables, where even if it wasn't a list, as long as we gave it by comma, separated by comma, different values, we're able to print 1, 2, 3. But this is where list unpacking gets really, really useful. We can actually, let's say, extend our list to include all the way till 9. What if we wanted to unpack 1, 2, and 3, but keep everything else still in a list? Could we still do that? Well, with list unpacking, we can. All we need to do is say comma, and then add a star, and give it a variable name, whatever we like. Let's say other. So now if I print other, and I click run, look at that. I'm able to unpack my list however way I want. What if I add a comma here and add D? Well, if I run this, I get a list all the way until 8. But now D is, well, actually, the very last item. So that's very, very neat. Maybe the use case right now is not absolutely clear to you, but this is something that might help you, another tool in your toolbox, to unpack a list and change a list in different ways. We'll explore this more later on in this course, but for now, list unpacking. When you hear that word, now you know what it means. I'll see you in the next one. Bye-bye. Welcome back. When we talked about lists, we saw our special type of none, where some methods that worked on lists didn't really produce anything. They modified the lists in place, but the output of whatever they were doing was this thing none. Remember how we had in the output this none? What does that mean? If you remember, I mentioned none as a special data type that exists in Python. And most languages have something like this to represent the absence of value. In some other languages, you might have heard of null, which is another thing that, again, represents the absence of value. Now, why is this useful? Well, for now, it's hard to really conceptualize it. We'll see it being used a lot more as we get further into the course. But I could do something like A equals none. Let's say, for example, we're just starting a video game. And in this video game, we have a user's weapons. But when you're just starting the game, there are no weapons that the user has. Well, in that case, we might want to assign the variable weapons. Maybe in our code, we use this variable, but we also want to know that this user doesn't really have any weapons. It's none. So this is completely valid Python. If I run this, I get none. And we'll explore this a little bit more throughout the course, like I said, but hopefully this way you're not intimidated when you see it. As the name suggests, it's just nothing. Let's talk about our next data structure. And this one is called a dictionary. In other languages, it might be called a hash table, maybe map or objects. In Python, we have this idea of dictionary, or as Python likes to call it, dict. I have to make sure I pronounce that properly. That's a really hard word to say when you're recording and you're repeating it over and over. Anyway, dictionary. What is it? Well, it's a data type in Python, but it's also a data structure. Remember that I mentioned this idea of data structure when we talked about lists. They were the first data structure in Python that we learned. It's a way for us to organize our data in a form that has some different pros and cons on how we access it. For example, with lists, we saw that they're easily ordered. We can access them through indexes like 0, 1. We can reverse them. We can insert into them. It was really, really nice. What about dictionaries? Well, let's see what a dictionary looks like. A dictionary will look something like this. We'll have a key and a value. Then another comma, and then another key and another value. Let's decipher this. So I'm using curly brackets here, which denotes a dictionary. And unlike a list, we have what we call a key-value pair. A key is a string for us to grab the value. What do I mean? Well, in order for us to access any of these values, I would go dictionary and then say the key. In our case, let's say we want to grab B. We would grab the key, and then when we print here the result, we get the value 2. We're essentially telling the computer, hey, I have this variable dictionary. Remember, I can name this whatever I want. I have this variable dictionary. I want you to go find the key B. And this key B, if it exists, grab me the value. So it's going to go into your memory or into the machine's memory. It's going to find where B is stored in our memory and grab the value. So in the bookshelf B, we have the value 2. What if we do C, which doesn't exist? If I click run, nope, I get an error. It tells me, hey, sorry, you're looking for key C, but I don't really have that key. And this is what a dictionary is. A dictionary is an unordered key-value pair. What do I mean by that? Unordered means that they are not right next to each other in memory. Remember, with lists, we could access lists with index of 0, then index of 1, index of 2. All those bookshelves were right next to each other. A dictionary, on the other hand, they're all over the place. Although I've put A and B here, this might be in one spot in memory, and this one in another spot in memory. And if I added, let's say, X, this will be in another spot in memory. And this might not be in order. Maybe I've written it A, B, X, but when I actually return the entire dictionary, maybe I don't have this in order. These are all just scattered all across our memory. As you see here, when I receive the dictionary, I get these things in order, but that's only because it's small. If I had a really, really large dictionary, I might not have them in order that I've inserted it in. So a dictionary is an unordered key-value pair. And as long as we know the key, that is, whatever the key that we're looking for, then we just give that. And our computer is going to know, hey, where in memory to look to grab the values. Now, here's the cool thing about data structures, like dictionaries and lists. They're containers around data, right? So this can be anything that we want. Let's say we want this one to be a list, 1, 2, 3. Maybe we want this to be a string, hello. And maybe this is a Boolean value, like true. That is completely valid. I can access the A like so, and I get the list. What if I want the second item in the list? Well, I do index of 1, like this. And there you go, I get 2. And this is the same with lists. And you'll see this a lot, where if we had a list, or let's call it my list, and my list contains a dictionary that has, let's say, A, 1, and you know what? Let's just copy and paste this. We'll do this. So we'll have the first item in the array, like this, then comma, then another item in the array, and this time around, this one has 4, 5, 6. So that I can now grab from my list the first item in the array, and then maybe grab the A, that is the A key. So remember, this is a string. And then we want to grab, let's say, the third item. So we'll go 2. If I run this, I should get 3 and 2. There you go. Now, you might be asking yourself, what's the deal with these data structures? Like, why do we need dictionary? Why do we need list? Why can't we just have one thing that does everything? Isn't that simpler? Think about that, because in the next video, I'm going to try and answer that question for you. Let's talk about our next developer fundamentals. And this one is understanding data structures. A really good programmer is a programmer that is able to decide what data structure to use when. Up until now, we've learned about dictionaries and lists, and we'll learn about a couple more throughout the course. But a really good programmer, a programmer who's experienced, is able to understand what the trade-offs are, when to use what. And although I can give you a list of this is when you should do this, and this is when you should use maybe dictionaries, the thing is, this takes practice and experience. So throughout our course and then the exercises that we're going to do, the projects we're going to build at the end, I hope that this idea of understanding when to use what data structure makes sense to you. But let's go back to our example. When should you use a list and when should you use a dictionary? Well, the first thing we have to realize that a dictionary is not sorted, right? A list has order. It has 0, 1, indexes, so on and so forth. A dictionary has no order. So maybe if you want to have a list of people in line at your shop, well, you should probably use a list. But maybe you have a user that is playing a game, and that user has first name, maybe weapons, maybe an age. That doesn't have to be ordered, so you might use a dictionary. Also, you'll notice that dictionaries hold more information than lists, right? Because lists only have that single value. That is, a list has the index and then whatever the value is. And here we have a dictionary inside of a list, which is holding a lot of information. Deep down, a list is simply an index and some sort of value here, right? Versus a dictionary that holds a lot more information. It holds a key. So this could be the weapons of that user. Hello can be the greeting of that user. Maybe is magic is another information about that user. So we're able to have both keys and values in a dictionary. So it holds a lot more information. And as we learn different data structures, you'll have these different pros and cons. You'll start to understand as to when to use what. All right, there's another Developer Fundamentals. I'll see you in the next one. Bye-bye. Welcome back. I mentioned to you that a dictionary's values can hold any sort of data type. But what about the keys? Up until now, I've only used strings to denote a key. But could I do something like this? Could I do 1, 2, 3 like this? Well, let's have a look. Let's give it a try. If I do 1, 2, 3, and I click run, I get 1, 2, 3. Awesome, that works. What about true? If I have a key true and I click run, will that work? Yep, it looks like it works. What about a list? What if I have a list of, let's say, just 100? Would that work? If I click run, nope, it doesn't work. It says unhashable type list. What does that mean? Dictionary keys need to have a special property. A key needs to be immutable. That is, a key cannot change. And numbers, booleans, this is a value that cannot change. A string, if you remember, is a value that cannot change. It's immutable. But a list, if you remember, can be changed, right? On a list, I can reassign, let's say, the index of 0 to something else, right? So because of that, a dictionary says, hey, my keys, because I'm storing them in memory and I don't want to lose them, it has to be something that isn't going to change on me. Maybe a programmer comes in and by mistake changes this array of 100 to have an index of something else. Well, dictionary doesn't really want that because it doesn't want to lose this value. So a dictionary key always has to be immutable. And as we learn a few other things like a tuple that we'll see in upcoming videos, you can use those as keys as well. However, most of the time, 99% of the time, a key for a dictionary is usually something descriptive like a string. Okay, but what about this? What if we have another string, 1, 2, 3? And let's just remove this for now. What happens when I search for 1, 2, 3, the string? If I click run, I get hello. A key in a dictionary has to be unique because there can only be one key, because that key is going to represent a bookshelf in that memory space. So anytime I do the same key and maybe add a value, it's going to overwrite. So this no longer exists. A key has to be unique, and it's something that can only exist, well, just once. Otherwise, we overwrite it, which is why you see hello here. We've lost the array 1, 2, 3. Let's explore this idea a little bit more in the next video. Welcome back. Now, if you remember, let's have something different here. So we have unique keys. If you remember, we have to have unique keys. So let's say this is greet, and this is let's say a basket. And we can access basket like this. If I click run, I get 1, 2, 3. But what if we don't know what this dictionary is? Maybe a dictionary is something, well, somewhere else where we can't see. But we want to know if this, let's call this user, if this user has maybe property like age. So do they have this age key? Well, if I click run, I get an error, key error, age. Age doesn't exist. But remember, errors in our programs, and this is something we'll cover later on, are not good. They're going to stop the program as soon as the Python interpreter enters an error. It's going to kick out of the program and say, hey, you have an error, and it's going to completely ignore what's underneath it. Here we don't have anything, but in a real life program, we want to avoid these errors because it stops execution. So another good way to access a key and to see if it even exists is to use .get. And guess what .get is? Did you guess a method? Well, there you go. .get is a method on the object or the dictionary in Python. So here, if we do get age and do run, I get none. So my program doesn't error. It just says, hey, there is nothing there. It's an absence of value. And we've learned what none means by now. So that's a really nice way to avoid those errors. By the way, if let's say there's no age in the user, but you want to have a default value, you can do something like this. So you add a comma, and then here you say whatever you want as the default value. So let's figure that out. If I click run, I get 55. Because now I'm saying, hey, grab the age from the user dictionary. If age doesn't exist on the user dictionary, use 55. So now we have 55. But if the user already has age, and I click run, I get 20. So this is, hey, in case age doesn't exist, add a default value. That's really, really nice. Now, I'm going to show you another way to create a dictionary, which is not very common. Most of the time, you want to use this syntax. But just so you're aware of it, here's another way. Let's say we have a new user, so user 2. I can create here a dictionary by saying dict, which again is a built-in function. And in here, look at that. It shows me, hey, this is going to create a new empty dictionary. And we can create different values, key value pairs. And we simply say, I want the key to equal the value. So in my case, let's just say that I want the name to equal John John. If I now print out user 2, well, before I click run, I see that I have a red underline. And by the way, if you see here pi flakes, that's something called linting, something we'll talk about when we talk about developer environments. We're using this linter that tells you whenever you make errors in Python, and it says keywords can be an expression. That just means that, hey, the keyword needs to be, well, just a variable that we create. So if I click run here, look at that. I have name John John. So we've created a user with this key value pair. Now, like I said, this way of creating dictionaries is not very common. Most of the time, you'll do something like this, but at least now you know that this is why this built-in function exists. I'll see you in the next one. Bye-bye. By the way, there is actually one more way that we've actually seen in lists how to look for an item in a dictionary. Remember how in lists we used the keyword in? We said something along the lines of, hey, is I in a list that contains I? Or we even used a string like hi. Well, you can do the same with dictionaries. I can say, does basket exist in user? And let's print this out and run. And it's going to say, yep, basket does exist in user. What about size? Does that exist? Nope, that's false. That does not exist in user. But here is where it gets really interesting. And this, again, is another dictionary method that we can use. And by the way, you can see that there's not that many dictionary methods that, well, dictionaries have. Luckily, we're going to go over the main ones here. The one is called keys. And keys simply checks the keys. What are the keys of user? So if I go hello here and I click run, well, no, keys are, on this side, not this. So this is a value. So if I want to check keys, I'd say age, which is true. But if I want to check values, well, in that case, if I do hello, I get true. It's going to go over, or what we call iterate, over the values. Another one that's really useful is the items. And items is special because we've seen keys and values. But items actually grabs the entire item. So the way we can actually see this is, let's just remove and click run. All right. This is interesting. I have dict items here, and I grab, looks like a list. And in here we have a bracket, basket, 1, 2, 3, greet hello, and age 20. But there's some weird syntax here that we haven't seen before. And this is actually a tuple. So we're going to hold off on this and talk about this a little bit more when we talk about our next data structure. But keys, values, and items is an easy way for us to grab these things for us from our dictionary. Let's continue on with other dictionary methods that we might use. One is a very nice one. It's called clear. And if I run this, you see that I get an empty dictionary. What if I just run users.clear here and run user? Well, it's still an empty object or an empty dictionary. So you can see here that clear doesn't actually return anything. It doesn't, well, it's just in place, removes whatever the dictionary has. So it just creates an empty dictionary. What about copy? Well, a copy allows us to copy a user so that if I print user and user2 and I click run, I get two users, each keys and values copied. But if I now, let's say, clear the first user and I click run, the first user is empty, but because I've copied the second user has the old information. And this is a concept that we've talked about before. Another useful command, and let's just go back to having user, is user.pop, which removes a key and a value from the dictionary. So in our case, let's just say we want to remove the key that is age. So I'm going to say age. And if I run this, I get 20 because pop returns the value of whatever got removed. But if I do print user now, you'll see that age does not exist anymore because we've popped it off. But pop, as you can see, removes the actual value or returns the actual value 20. Here's another really fun one, pop item. And honestly, this I haven't used much, but I just think it's a fun one. Pop item, if you guessed, well, you're not going to guess. Oh, and that's because I have to make sure I write it properly with lowercase. If I run this, what just happened? It randomly pops off something. One of the keys and the values. In this case, age 20 is removed. So the last item on the dictionary gets removed, but remember, a dictionary is unordered. So if this was a massive, massive dictionary that, well, doesn't have any order to it, sometimes it removes some pair, as you can see, not the last one, but some pair of key value. So you have to be careful with this one. It doesn't necessarily just remove the last thing that you entered, but it might be useful on some occasions. Finally, we have something called update. An update simply updates, as the name suggests, a key value. So let's have a look here. All we have to do is give it a new dictionary, so curly brackets, and just simply say, hey, I want to update age to 55. If I click run, oh, and I forgot a bracket here. Let's try that again. If I click run, there you go. Age got updated. But if this was a key that doesn't exist, like ages, and I click run, it will still update with a new key item. So this is another really useful method. All right, that's it for dictionaries. I'll see you in the next video. Hooray, it's time for our third data structure as we continue down to our different data types in Python. And this one is called a tuple or tuple, depending on how you like to pronounce it. And we actually saw this slightly when we talked about dictionaries. But before we get into that, what are tuples? Well, a tuple are like lists, but unlike lists, we cannot modify them. They are immutable. So you can think of them as immutable lists. And they look like this. So let's call it my tuple. is going to use brackets to denote a tuple. And we can do 1, 2, 3, 4, 5, just like a list. Now, you remember how in a list we could have modified this and said index of 1, well, now is going to equal z. If I run this, it's going to error out. It's going to tell me, hey, tuple object does not support item assignment. A tuple is immutable. Once you create it, it's the way it is. You can't sort it or reverse it like we saw with lists. It's just there. What about this? Can I just print a tuple and just grab the second item on that tuple? Well, yes, you can. Just like a list, you can access it through an index. Can I maybe do, does 5 exist in my tuple, just like we could in a list? Well, yes, we can. The difference is that it's immutable, right? Now, why do we need this? I mean, we already have lists, so why do I have to learn tuple if, it's pretty much the same as list? It's the only thing is I can't change it. There's a few benefits to this. For example, if you don't need to change the list, that makes things easier because it tells other programmers looking at your code, hey, this shouldn't be changed. Unlike a list, I want this to stay the way it is. Keep this order. So it makes things easier and more efficient. It makes your code safer because people can modify it, right? It makes code more predictable. However, it makes code more predictable, but it's less flexible than a list. I can't really sort a tuple. I can't run reverse on tuple. Now, because of this, because they are less flexible, the other good thing about them is that they're slightly more performant than lists. So they're usually faster than lists. And if you don't need a list to change, well, use a tuple. So a good use of a tuple, for example, if you work at Uber, is geographic location and coordinates, right? You can have latitude and longitude here. And because, let's say, this won't change, or maybe a user's location or pickup point doesn't often change, we can just use a tuple. However, maybe when you're in a car as a driver and you're an Uber driver, well, you probably need your coordinates, your latitude, longitude in a list because your car is moving. That's constantly changing. And we saw tuple when we talked about dictionaries, right? Remember when we did user or we did user.items? And then I said, hey, just print user.items. And we saw here that we got a dictionary items. And inside of this dictionary, we see that basket 1, 2, 3, greet, hello, and age 20 are a tuple. So this actually returns our key and value as a tuple. And as I mentioned before, a dictionary can have keys that are immutable. So a tuple is a completely valid key in Python. So I can do 1, 2 here, and that is a valid key in a dictionary. And the way I would access this would be like user, curly bracket, 1, 2. So that if I click run here, oh, I have an extra bracket. Let's fix that. Let's click run again. And there you go. I'm able to grab user, tuple 1, 2, and grab 1, 2, 3 list. You see here how I'm trying to use different data structures, combining them together. Let's take a break and finish off our understanding of tuple in the next video. Now, tuples, like I said, are quite similar to lists. So if I wanted to, I can say new tuple and use my tuple and then slice that tuple. So for example, if I do 1, 2 like this and print new tuple, I'm going to get 2, comma. Why is that? Well, we start at 0, 1 and end at 2. If I did 4 here and click run, I get 2, 3, 4. It's still a tuple, but you have to remember that a tuple that only has a single item tends to have this little comma at the end, but it's still a tuple. And just like a list, I can assign different things. For example, I can say x equals to my tuple 0, and then I can say y equals my tuple 1, and x and y will equal 1 and 2. But a short form of doing this, again, similar to lists, is to say, hey, I want x, y, z, and you know what? Other to be the values assigned from the tuple. So that if I do x here and I run, I get 1. If I do z and I run, I get 3. What if I do other? And if I click run, I get 4 and 5 as a list. All right, if your head doesn't hurt by now, don't worry, I have some good news. Luckily for us, a tuple has only 2 methods that we care about: count and index. How nice is that? So nice and simple. Guess what these mean? So let's go back to my tuple and now try these out. If I go my tuple.count, well, it's going to count the value. So if we want to count how many 5s occur in the tuple, I get 1. If I had another 5 in the tuple, I get 2. What about index? What's the index of 5? Well, the index of 5 is 4, because 0, 1, 2, 3, 4. The first value that it finds, it's going to return the index of. And then finally, we can also do length, right? We can use this built-in function to run length, and it's going to tell us that, yep, it has a length of 6. Awesome. There it is. We're flying through them now. This is our third data structure. Remember, they're simply lists that are immutable. I'll see you in the next one. Bye-bye. Can you believe it? I hope I didn't put you to sleep, but we're almost there. We have one last main data type, set, and then we're done. I know this isn't the most exciting topic. Trust me, this is the hardest part. When you're starting out and you're just learning these things without understanding, why do I need this? How am I going to build the next game? How am I going to build the next Netflix? How am I going to build the next coolest Apple app? You're looking at this and thinking, I just learned a bunch of theory. I feel like I'm in math class all over again. I know, trust me, I went through this. I was a self-taught programmer as well. These are the Lego blocks that builds our foundation. Once we learn these, we can move on to new things, and you'll see that once you climb this little mountain, things become so much easier. And you'll realize the power when we start building these projects toward the end of the class, where you're going to say, oh, all these blocks that we learned, all this frankly boring part is all going to make sense. So hang in there. It's supposed to be hard. It's supposed to be tough, but you'll see very soon why this is so powerful and why what we've just learned is going to allow us to build some really awesome things and create some really awesome programs. So let's finish off with the last one. The last data type, the last data structure that we'll see in Python, at least from the main ones. And it's called set. And sets are simply unordered collections of unique objects. Let's have a look. Let's create a my set. And my set we create with curly brackets like a dictionary, but instead of a dictionary, we don't have key value pairs. Instead, we just have values like 1, 2, 3, 4, 5. That's it. That's a set. We just created a set. But remember the definition I gave you. Set is an unordered collection of unique objects. What does that mean? Well, if I print this and say my set, and I click run, I get a set. But if I had, let's say, another 5 in here, and I click run, it only returns the unique sets or unique items. You see, in a set, there's no duplicates. Everything has to be unique. So this 5 just never gets added to a set. For example, you can add things to a set like my set, and then I can say .add and give it a value like 100. And then let's say I do my set.add and then give it 2. If I click run here, I see that I was able to add 100, but 2 wasn't really added because my set already contained that data. It's unordered. I mean, we've created 1, 2, 3, 4, 5 here, but there's no real order to it. There's no bookshelf in our memory space that is right next to each other. These are all over the place in memory, but a set is able to find them because they're all unique. So they're all in just one location in memory. So let me ask you this, and this is going to be a fun little exercise. If I gave you an array, and let's say this array contained, this right here. And I want you to return an array with no duplicates. So I want everything in, let's call it my list. And a programmer has already created this. Okay? And then your task is to create or return a list or a collection that has only unique items. How would you go about converting this into a set? Well, we've seen this before. We have a set function, and we simply wrap my list in that set. And let's print it out. I click run. Check it out. We have formed a new set from a list. And I've removed all duplicate values. When would this be useful? Imagine if we had usernames, right? Or email addresses. We're collecting email addresses on our startup page, but we don't want to have duplicate emails. We might want to convert this, a list of emails, to a set and remove any duplicates so we're not sending emails over and over. So that's really cool. What about this? Let's change this into a set. So let's call it my set. Going to change this into a set. There you go. And then what if I wanted to access my set at index of 0? Set object does not support indexing. Well, again, you can think of it more as a dictionary. In order to access a set, we have to grab by the item that's in it. That's the key to getting the information from memory. The way we would check if something exists is we simply say, hey, is 1 in my set? And we run this, and we get true. We can also do length of my set, and we get 5. Again, nothing too crazy, but 1, 2, 3, 4, 5. Remember, it only counts the unique things because this will never get entered. It's a set. And alternatively, we can also convert this into a list. If I click run here, you'll see that I now have my set as a list. And then we can also do, let's say, my set.copy, and actually copy my set into something, let's say, new or new set. And then this will be completely different or a new copy than this original one. So let's test this out. This new set, if I use a method that we may have seen before, which is my set.clear, which, as you can imagine, clears the set, and I click run, I have that new set, but when I try and print our old set, which was my set, it's going to be empty, an empty set. But the true power of sets comes in the next couple methods that I'm going to show you. And sets have quite a few methods, but don't worry, most of them are quite similar. So let's explore that in the next video. Welcome back. The methods we're going to talk about when it comes to sets are right here. It looks like a lot, but they're quite similar, so hang in there. I have 2 sets for us. Our my set, which is 1 through 5, and then your set, which is 4 through 10. Now, let's go one by one and see what these methods do. And if you've ever seen Venn diagrams in your school, for example, two circles that are overlapping each other, what we're about to do is quite similar to this. The first one is difference. And sets are very useful when having two sets and comparing them to each other. So for example, in here, difference simply says my set dot difference, and we give it another set, such as your set. If I print this right here and I click run, I get 1, 2, 3. It's going to find the difference of the first my set with your set. So any duplicates between the two, which is 4 and 5, gets ignored, and it only shows the difference, that is 1, 2, 3. What's different between my set and your set when viewed from my set? Well, your set doesn't have 1, 2, 3. What about the next one? Discard. Again, if we do my set dot discard, it says it removes an element from a set if it is a member. So here we can say discard 5. And if I do print my set and I click run, I get none. But if I print here my set and I click run, I get 1, 2, 3, 4 because we've just discarded 5. It modifies our set. Just to keep our working space clean, I'm going to comment these out. Next is difference update. So I'm going to say my set, and then once again, let's see what difference update does. Remove all elements of another set from this set. So if I do your set here, and once again, I do print, and I click run, I get none because it just modifies my set. So remember, we just have to have our print, my set, and now this my set is updated with just 1, 2, and 3 because we're updating it so that the differences are removed. So 4 and 5 are removed. Unlike difference, where it just told you the difference without changing. Again, if we go back here and simply do my set, and I click run, you see that my set here was not modified right here, but then my set bottom was modified because of difference update. All right, a few more to go. Intersection. And this one, once again, my set. And in here, once again, let's read what it does. It just has intersection with something else. Well, let's find out. If I do your set here, and I do print, and I run this, it's going to give me 4, 5, because that's the intersection, the two common things that my set and your set has. What about is disjoint? Well, if I do my set, and then your set, I feel like I'm saying those words over and over. Hopefully that's not too annoying. And then here, if, let's comment this out, we run this, I get false. Is disjoint simply says, hey, are those two circles overlapping? Do they have anything in common? If, for example, my set didn't have 4 and 5, and I click run, I get true, because is disjointed means these sets have nothing in common. Awesome, just a few more. The next ones we're going to see is subset and is superset. But actually, before we do that, let's do union. Let's see what this does. Union will say my set. And in here, we want to add the other set, your set. If we print this and click run, I get 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What did that just do? Well, union just united these sets together, but removed any duplicates. That's kind of nice. And as you can see, it created a new set for us. It returned a new set. By the way, there's actually a shorthand that you can do here in Python, which is the shift and then the key above your enter, which is right here, this straight line. So shift and then the backslash, but if you press shift, you'll get this little straight line. If you print this, well, remove the brackets here. Let's run again. And you see that works as well. And by the way, this also exists for intersection. Again, you don't see it that often, but with intersection, you can do the same thing where you just do the end. And if you do that, it gives you the intersection of my set and your set. All right, I promised you this is going to be short, so 2 other ones. Is subset and is superset. As you can imagine, my set, if let's say my set only has 4 and 5, and I say, hey, is my set, is that a subset of your set? And I print this. If I click run, it's true. My set is a subset. That is, it's inside of the circle of your set because 4 and 5 is inside of it. So my set, the entirety of my set is inside of this other set, which we call a subset. On the other hand, we also have this idea of superset. So if I do, instead of is subset, is superset, I'll get false because, well, my set is not a superset. It doesn't encompass your set. It's the other way around. Your set is a superset of my set. Because your set encompasses everything that my set has, which is 4 and 5. Oh boy, that was a lot. And you're asking yourself, there is no way I'm going to memorize any of that. Well, good. I don't memorize any of this either. As a matter of fact, I usually go to the Python documentation or just Google around. And because I know sets exist, if I ever want to compare, let's say, 2 sets, I know to just go here and find the tool that I want. That's the key of a programmer that I keep mentioning over and over. It's not memorization. It's the ability to know that there's tools that you can use and being able to Google for them. I know it doesn't sound exciting because in movies you see everybody typing super fast and coding everything, but that's just not real life. In real life, you just Google around, find solutions because by now you know what sets are, you know what sets can do, so that you can Google for methods that are appropriate to your problem. I'll see you in the next one. Bye-bye. Welcome back. We learned about our basic Python data types. We also learned a little bit about some of the terms that we might use when talking about code. We learned a few best practices, but most importantly, we learned how to perform actions on these data types. We saw that there's built-in functions that we can run on any data type, such as the print function. But we also learned that most of these data types have their own methods. That is, that dot some sort of a name and then the brackets to perform some actions on them. Now we're still scratching the surface here, but we now go into an area that gets really, really exciting. Because up until now, what we've been doing is this. Every time we write code, we do something here, and then we go to the second line and do something else, and then finally go to the third line and do something else, and so on and so forth. Our Python interpreter just went line by line, one all the way to whatever line number we have on our .py file, and just ran the code. And it ran it really fast because machines are good at that. They run code really fast. but we haven't discovered the true power of programming, and specifically programming for machines. You see, the power comes when we start to incorporate the idea of maybe running multiple lines over and over, or maybe skipping a line and going from line 1 to line 3. And in this section, we're going to talk about the idea of conditions and conditional logic. We're going to talk about looping and loops, where we can perform actions hundreds, thousands, millions of times over and over, something that machines are really, really good at. And that's when programming becomes really powerful, because machines can do certain tasks a lot better and a lot faster than humans. So we're now going to break into a new world where instead of going from 1, 2, 3, everything in order, we're going to start to break some of that apart so that we have more control over our programs than just going line by line. Let's find out how to do that in the next video. Let's talk about conditional logic, an important concept all over programming. What do I mean by conditional logic? We've learned about Booleans, right? We have true and we have false. And some of you might be wondering why they're so useful. And when it comes to conditional logic, Booleans are really, really important. For example, let's say we create a variable, is old. And you know what? We're going to create a car that automatically detects if you can start the engine. Maybe if you're not old enough, the engine won't start and it won't let you drive. So that they make sure that this car is super safe and only people that are perhaps over 18 can drive it. So how can we code something like that? Let's assume Tesla has a new feature like that. Well, we'll have something like is old, and we'll set this to true, right? Maybe we have something else. Maybe it checks the license to make sure that we have a license. So we can say is license. And then we can set it to true. Now, these could change, true and false, depending on the user and the driver. But when I talk about conditionals, this is what I mean. In Python, we can use the if keyword to say if some condition exists, and this is just me writing it, it doesn't exist. You can see that I get a red underline with invalid syntax. But here we want to say a condition that evaluates to true or false. In our case, we can say, hey, if is old, which what does it evaluate to? Well, it evaluates to true. If that's true, then let's say print you are old enough to drive. Now, there's a few new things here. One, I've added a semicolon or a colon, and then you'll see here that the indentation is different. As a matter of fact, when I press enter after the colon, you see that it automatically gives me a space. This tells the Python interpreter, I'm going to do an if statement, a conditional operation. And if this happens to be true, run everything that's inside of here that has this indentation. And if I do something without the indentation, let's say print check, check, this to the Python interpreter is like a completely new line. It is not part of this if block. And if you're using the REPL, you see over here I get a little minus sign. If I click this, you see how it hides? Well, what it does is it's saying, hey, this is a code block over here. It's an entire thing in itself. But anything outside that is not indented, well, doesn't belong to it. So to a Python interpreter, it's going to say, I have this line, and then I have this line. Let me show you what I mean. If I run this program, I get, you are old enough to drive, and then I also get check, check. But what if I say is old is now false? What do you think will happen? If I run this, I get check, check. our Python interpreter is going to say, hey, set variable is old to false. Hey, set is licensed equals to true. And then it's going to go to line 3. Nope, nothing there. I'm going to keep going. Line 4, hey, if is old, is this true? No, if old is false. And the interpreter is going to say, okay, I'm only supposed to run this piece of code if this is true. Because this is now false, I'm just going to completely ignore what's underneath here and just go to the next line that has, well, no indentation. So it's going to print check, check. And this is the power of conditionals. We're able to essentially skip lines. The interpreter doesn't even care what's in here because I just told my program to skip from line 4 to line 6. How cool is that? So we learned that there's this if keyword, but there's also another thing we can use called else. And you'll notice here that I didn't add it to the indentation. And else, as the name suggests, simply says, hey, if this something is true, then do this. Otherwise, also else, do this. And again, you see that I've added the indentation. So try to guess what's about to happen in this program. If I click run, I get check, check, because it's saying, hey, is old, is that true? Nope, it's not true. Okay, I'm going to completely ignore that. The interpreter sees else. Okay, well, this wasn't true, so I'm going to run. Whenever this evaluates to false, I'm going to always run print check, check. What if I change is old to now equal to true? What will happen next? Well, I get you are old enough to drive. Else only runs if the if block of code evaluates to false. Very, very cool. All right, let me ask you another question. What if I did print here? And let's change this to you are not of age. If I run this, is that what you expected? Well, I hope by now you agree that this is the expected behavior. Because is old is true, I'm going to print this. And then Python interpreter is going to say, well, this was true, so I'm going to completely ignore the else block and then just go to the next line. What's on line 8? Nothing. So I'm going to go to line 9 and now I'm going to print okay, okay, okay. As you can see, we're now controlling the flow of our programs, where instead of going from 1 to 9, just line by line, we're now saying at line 4, do some sort of check, and based on that, skip a few lines. Very, very cool. All right, there's one other thing I want to show you, and it's the if. And I know this kind of looks weird. You would think that it'll be else if, but no, no, no. It's if. And what do you think this does? Well, you use it in combination with if. You say if something, if otherwise, else, if another condition, so let's say is licensed, then do another condition. So let's say print you can drive now. So let's go through this again. I'm going to say, is this person old enough? If that person is old enough and this evaluates to true, well then I want you to run this. Otherwise, I want you to run this condition. Hey, is this true? No. If it's not true, then jump to else. So what will happen here? If I click run, we get true for the first conditional block right over here. So automatically Python interpreter is going to say, well, we just got true here, so I'm going to ignore this and ignore this, and then print okay, okay. But let's say that is old is now false. What will happen next? If I click run, this is false, so Python interpreter is going to say, nope, not going to care about this block. And I'm going to go, hey, else if a condition, hey, is this person licensed? Yep, they are. So I'm going to print you can drive now and ignore else. So it works like this. What if both of these were false? Well, as you can imagine, the Python interpreter is going to ignore, it's going to run this, say, nope, this is false, this, nope, this is false, and then finally it's going to run this. You see that else is a catch-all. That is, if none of these conditions are true, then we're just going to run this. So it's a backup in a sense. Hey, if all things fail, then just do this. Very, very cool. Now, if you look at this program, you're thinking, this program doesn't really work that well, does it? I mean, we're checking if the person is old and if person is licensed, but shouldn't we check both? We want somebody who has a license and who's old enough to drive. This is a buggy program. If we implement this in a Tesla, well, we're gonna get a lot of lawsuits, right? Because we can get somebody who's maybe licensed but isn't old enough, which I guess doesn't make sense. But we can get somebody who is old enough but never got their driver's license, and somehow we get access to the car and they can start the engine and drive, and that's a lawsuit waiting to happen. So how can we fix this? You know what? The power is that this is an expression, right? An expression, if you remember, is something that produces a value. And that means that this doesn't have to, just have true here. It could be an expression. So I could say, if is old and is licensed, then I can do that. And this is something new that we haven't seen before, the and. This is another keyword in Python. And in an upcoming video, we're going to talk about more of these keywords. But this should read like English, right? If is old and is licensed, then do this. So we can now remove the elif, and then here, both expressions need to evaluate to true. That is, whatever happens here, this has to evaluate to true and this has to evaluate to true. And only when both are true, again, as and states, then you're old enough to drive and you have a license. So that if I run this, well, I get an error, right? Because, or not an error, but it goes into the else block because both of these are false. If only one of them is true and I click run, you are not of age because both of these have to be true. If I click run, hey, all right, the car is starting. You can drive away with your Tesla. Okay, before I finish this video, because this is a lot, I want to just note one thing. That is the elif statement. The elif statement is really, really useful because when you have code like this, where you have an if statement and an else statement, usually you only see one of each. I mean, sure, in another part of the program, I could have another if statement and an if statement with another else statement inside of here. But usually, when you have this grouping together, you only see one if and one else, but you can have multiple elifs. So I can have elif another condition here, and then I can have another elif another condition here. And you can have as many as you want. Eventually, the program is going to either evaluate one of these conditions to true, or it's going to go into the else block. But usually you follow this order. All right, that was a lot. Let's take a break and explore this topic a little bit more. I'll see you in the next one. Bye-bye. I want to add a quick note about this spacing that we see in this code. Now, this isn't just for Python. In other languages, you'll always see this. You're not going to see that every single line of code always starts as, well, in the first space. Different languages will use this differently, but in order to organize code, usually you'll see some indentation like this. Now, Python, however, is unique because the indentation and spaces that we see here makes the interpreter see it and say, hey, this means something. The interpreter would actually see the space and say, because there's space here, I know that this is part of the if block. In other languages, like JavaScript, well, you have something similar, but usually you'll have an if statement and then some condition, followed by, make sure I spell condition right, followed by something like a curly brace. And in here, whatever is in here, you can see that I still get the space and I can do whatever I want. But JavaScript interpreter doesn't really care that there's spaces. If I want, I could write my code just on one line like this, and it's still valid JavaScript code. So people usually do this spacing more for style purposes. Python, on the other hand, is not just for styling that we do this, but because the interpreter actually finds meaning in the spaces, which is actually one of the big selling points with Python. It's very clean. There's no extra stuff here that makes it difficult. I mean, it's just English, right? If is old and if is licensed, then print this. It's just really nice to read and really clean. Now, if you notice here, my editor, and we're going to talk about editors and IDEs in an upcoming section, but if you are using the proper tools, this automatically is created for you. Now, in the programming world, there's this debate about tabs and spaces, and we're not going to get into it. It's frankly a little bit silly. That is, some people prefer to here, if they want to create a space, they might use spaces or they might use tabs. At the end of the day, with Python, the rule is you can use spaces, you can use the tab, but the idea that if you use spaces, you usually use 4 spaces. It's just a standard. Now, if you notice here, I actually don't have 4 spaces. It's 2 spaces here. And that is because up until now, well, I've just been following along whatever this editor gives me. But if you look over here, there's an auto format button. If I click on this, it automatically formats my code into the appropriate format. And you see right over here that I now have 4 spaces. But you see that the code still works. Again, it's because at the end of the day, the important part is that there's a distinction between hierarchies. That is the top and then maybe the children. But the interpreter itself is going to notice these spaces. So you do have to be careful because based on where this print is, as soon as I add a tab in here and I click run, well, I get is old and is licensed. But as soon as one of this is false and I click run, you see that OK runs only if this condition fails. Again, if previously both of these were true, I only get the first line printed. So that little space here changes the outcome of my program. So you have to really be careful with this. And luckily, your editor or where you code is going to help you out with this. But it is a gotcha that if you're just starting out, you want to be mindful of. All right, no more debates about spaces and tabs. I'll see you in the next video. Bye-bye. Welcome back. In this video, I want to talk about the idea of truthy and falsy. What do they mean? And you'll hear this a lot in Python programming. You see, up until now, you've used booleans here as values. So it was really easy. If true and true, then run this code. But Python can do other things as well. For example, if this was 5 and this was, let's say, hello, what do you think will happen here in our program? Well, if I click run, you are old enough to drive and you have a license. Is that what you expected? And this is because what Python does underneath the hood is actually convert these to booleans for you. So it's almost as if it is doing this. Remember type conversion. We're converting the type to Boolean as soon as we get to this if statement, because Python is saying, hey, I want true or false. I don't care what is old is. I don't care what is licensed is. Just give me true or false so I know whether to do this or to go to the else block. Now, if I was to just print, let's do this here. Let's do print Boolean hello, and then finally print Boolean 5. Let's see what we get. We get true, true. And this is what we call a truthy value in Python. That is, it's a truthy value because if we run the Boolean type conversion on it, it evaluates into true. What's a falsy value? Well, if I do 0, and if I do, let's say, an empty string, and I click run, those are falsy. That is, it's not actually false, but it is falsy because if we run Boolean on it to Python, it's going to say, oh, this is false. And 0, that's false. And that kind of makes sense, right? And if you actually go to Stack Overflow, if you've never seen Stack Overflow before, if you ever have programming questions and you're Googling them, usually the top 5 answers will contain either 1 or 2 Stack Overflow answers. And basically what happens is people ask questions like, what is truthy and falsy in Python? And you get answers. So you can see over here that it has 4 answers, and you usually look for the check mark, which means that this is a verified answer. It means that, hey, this question owner has accepted it as the best answer. So the person who asked this question just said, yeah, this is the right answer. This is the best one. But you also have other people voting. So you can see that this answer received 46 marks. And although it was marked as the correct answer by the user, maybe somebody else came along later on and gave an even better answer. So now we have 123 upvotes. And you see that this answer is a lot better. All values are considered truthy except for the following. So you can actually see here that in Python, these values are considered falsy. You can see 0 here, you can see an empty string here, and then there's a few other ones. Empty set, you have an empty dictionary, empty list, empty tuple. You have decimals. You have things like fractions. You have 0.0. False is that. And also none is falsy. So that if I type in none here, that's false too. Now you don't need to memorize these because most of the time it makes sense, right? But it helps us do conditional logic very nicely. For example, let's remove this. And let's say that we have a user. And this user has to have a password and a username. If, let's say, the username is Johnny and the password is 123, well, instead of me saying, hey, if this user has password and username, and we're not checking if the username exists or password exists, we just want to make sure, hey, did this person fill out the form and did they try to submit a username and password? I can just simply say password and username. And I don't have to worry about converting this to a Boolean or anything like that, because if password and username exist, then try to log them in. And you see that it reads a lot nicer, because each one of these get evaluated into a truthy and falsy value. It's a nice little feature to keep Python, well, nice and simple and reading like English. I'll see you in the next video. Bye-bye. I want to talk to you about another way to do conditional logic. We saw the if, elif, and then the else statement. But there's another way called the ternary operator. Now, this is still the same as the else if or if else statements, but it's a shortcut. So you can only use these on certain conditional logic. So it doesn't mean that, hey, this is just a an entirely new way. This is a shortcut in a sense for you to make your code a little bit cleaner. Let's have a look. By the way, these ternary operators can also be called conditional expressions. And when you hear the word expression, that should mean something to you, right? It's an expression because it evaluates to a value. So a ternary operator or a conditional expression is an operation that evaluates to something based on the condition being true or not. And it's actually a new feature of Python as of version 2.4. So let's have a look. The way we use this is to say is condition. If this is true, then do this. So this is the condition if true. And bear with me here. It is a little bit confusing at first. We say if, and here we give condition. Otherwise, condition if else. All right, that is a little confusing. So let's go through it. So the if is going to check this condition. So it doesn't actually start with here. It's going to say, hey, if this condition. Now, this is going to evaluate to either true or false. If it's true, then we're going to do this. Otherwise, we're going to do this. So let me show you an example of how that would work. Let's say we're trying to determine if a user is your friend. So we'll say is friend. And here we can set true or false for friend. Maybe we can check on Facebook if users can message you. Or on Twitter, whether Twitter users can give you direct messages. Well, here, and let's do can message. And here we can do our ternary operator. We're going to say message aloud if, so this is if the condition is true. The condition is, hey, is this person your friend? Otherwise, condition that is false, well, I'm going to say not allowed to message. And you can see here that this is a one-liner. It looks like 2 lines, but you can see over here that it's not really. It's just that we're wrapping so we can see the entire code. So let's run this and see what can message prints. If I run this, message is allowed because, well, we've assigned message allowed to can message because, well, the condition was true. If this person wasn't my friend and I run this, not allowed to message because the condition, the if condition, evaluates to false. I know the ordering here can be a little bit confusing, so you might have to look at it a couple of times, and you do need to use it a few times to really remember it, but this is the general rule. Condition if true, if condition, else condition if. Not if else, if false. Can't spell. All right, a nice shorthand way to do something when a condition is either true or false, or evaluates to true or false. All right, I'll see you in the next video. Bye-bye. It's time to talk about another topic that sounds a lot more confusing, short-circuiting, than it actually is. It's quite simple. Short-circuiting looks something like this. Remember when I taught you the word and? So we can use, let's say, for example, is friend equals to true, and let's say is user is equal to true. And I can do an expression here saying is friend and is user. Now, in here, when we run this, let's print it here just so we can see. If I run this, I get true because both of these evaluate to true. So that if I had this as an if block, let's say if it was if is friend and is user, print best friends forever. Now, short circuiting can be done when we use something like or. which we haven't seen before. But again, you can see here that it's highlighted in blue, so it is a keyword, a Python keyword. Now, or says, if either one of these conditions are true, then run this piece of code. So if I run this, I get best friends forever. Now let me ask you this. Which operation do you think is more performant? The or the and? Is there a difference? As a matter of fact, there is because of short circuiting. You see, when I do or here, because I only care if either one of these is true, the Python interpreter is going to say if is friend, and it's going to evaluate that and say, oh, this is true. And then it's going to see the word or, and it's going to say, hey, I don't care what this is. Maybe this is a really heavy operation or something that I need to look up. Well, I don't really care because this is already true. Whether this is true or this is false, I don't really care because either way, I'm going to have to print this. As you can see, it still prints best friends forever. So short circuiting happens when the interpreter is smart enough to say, I already did enough work. I don't care what this is. This is just wasted work if I do it. So I'm going to short circuit and say, hey, I'm going to just ignore this and I'm going to start printing. So using or is a little bit more efficient. But again, it depends on what you need. If you need to check if both isFriend and isUser is true, you'll have to use AND. But this works both ways with AND as well. For example, if isFriend is false, this is going to get short-circuited because I'm going to say, hey, if isFriend is false, well, I don't really care what isUser is because there's no way that both of these are true. I've already seen that one of them is false. So I'm going to ignore this and I'm going to print this. And when I say I mean our good old friend Python interpreter. Now, this topic of short-circuiting doesn't really get taught in beginner Python courses, but now if you hear this, maybe you hear this in an interview, as you can see, it sounds a lot more difficult than it actually is. And frankly, it makes a lot of sense, right? We want our machines to be efficient, and it is quite efficient due to short-circuiting. I'll see you in the next one. Bye-bye. Welcome back, and let's talk another term. Logical operators. And they're very, very useful when it comes to conditional logic. Let's have a look. Logical operators are, well, as a matter of fact, you've actually seen them before. AND is a logical operator. OR is a logical operator. It allows us to perform logic between two things. What else is a logical operator? Well, let me list it out for you. We have greater than, less than, equal to. Let's actually use them in an example. Is 4 greater than 5? Well, if I print this, what do you think will happen? Shouldn't be a surprise. That's false. 4 is not greater than 5. This is a logical operator that you may have seen in math class. If I do the opposite, is 4 less than 5? That makes sense. That's true. What about is 4 equal to 5? If I run this, I get false. Now, why did I use two equals here? Why not just do this? Well, if I run here, I get an error. Syntax error. Keyword can't be an expression. It's because, remember, equal is what we use to assign to a variable, right? And if you remember, I told you that a variable in Python can't start with a number. It has to be a letter or underscore. So when I do this, it's going to error because the interpreter is going to say, hey, I'm trying to assign variable 4 the value of 5. And, well, that's not really allowed. So we use double equals to tell the interpreter, hey, I'm not assigning a variable here. I want to compare things. And we can compare different things. I can do hello equals to hello equal to true. What if I do A is greater than B. I get false. Now, why is that? This I want you to Google on your own and figure out why is A greater than B. What if I do A, is that greater than capital A? That's true. This is interesting. And this is actually quite an interesting reason. So I know, it's easy for me to just give you an answer, but I want you to practice Googling this. And the reason I'm not giving you an answer is it's also because it's not very important. Because most of the time, you want to make code that is easy to understand and understandable. You're most likely using greater than and less than with numbers. So if you see something like this in code, well, you wouldn't know what's going on. What is this person trying to compare? Why are they doing is lowercase a greater than capital A? It's not something that you see very often. But the reason you get this expression is quite interesting. So I do recommend you Google into it. Like I said, I'm a strong believer in not holding your hand the entire way. I know so far the videos up until now have been quite easy, especially if you are an experienced programmer. But as we progress, you'll see that after this course, you need to figure things out on your own. And my job is not to just handhold you the entire way. It's to develop the skills in you to become an employable programmer. So I hope you bear with me as I just give you this little challenge. All right, we went a bit on a tangent, so let's bring it back. Can I do things like this? Is 1 greater than 2? Or you know what? Let's do less than 2 and less than 3 and less than 4. Will this work? Well, of course it will. It's just an expression, right, that we're evaluating. And all of this is true, but as soon as I change and something is false, it's going to short circuit, which we learned about previously, and return false. All right, so we know the greater than, equal to, less than sign. We also have greater than or equal to. So that if I do 0 here and I click run, I get true because it's saying, hey, is this greater than or equal to 0? I can also do less than or equal to 0. And here I get false because 0 or 1 is not greater or equal to 0. But if I do 0 here, I'll get true. Here's another one. What if I do this? Exclamation mark equal. This means in Python not equal to. If I run this, I get false. And this is a little tricky. What it's saying is, hey, is this not equal to this? So it's the opposite of doing equals. If these two things don't equal, it's going to say true. So if I do 1 here, I'll get true because these two things do not equal. So we've learned greater to or less than, greater to, equals, equals or greater or equal to. We've learned about less than or equal to. We've learned about not equal to, but we've also learned about and or. And finally, there's one more I want to teach you, and it's the not keyword. I know, it's a little much, but it's not as hard as you think. Not is, well, the opposite. So if I do here, not true, what do I get? I get false. And you see that not is also a function. So it's a keyword, but also a function that we can use. If I do not false, again, I just get the opposite. What if I do this? What if I do not 1 equals to 1? What will I get here? I get false because this expression evaluates to true, and then not just does the opposite. So let's take a break here and work on a little bit of an exercise to make sure that we understand this. Welcome back. Let's do a fun little exercise. We just got hired by a gaming company, and we're creating this wizard game. And this wizard game has the is magician in the user's profile And for now, we'll just set it to false. We also have is expert. And whether this user is an expert at this game, we'll leave it at true for now. And then, let's do this here. I want you to check if both, or check if magician and expert. And if that's the case, if true, then I want you to print you are a master magician. And also, I want you to check if magician, but not expert. If that's the case, I want to just print at least you're getting there. And then finally, let's do a check that says if you're not a magician, I want you to say, well, you need magic powers. Now, I want you to use what you've learned about logical operators to create this conditional logic. You can pause the video if you want and try it yourself in a REPL. Otherwise, I'm going to keep going with an answer. But you should be able to solve this fairly easily if you've been following the videos and exercises so far. So let's start with the first one, where we say you are a master magician. So I'm going to say if is expert and is magician, I'm going to print you are a master magician. So I'm going to copy that and say print you are a master magician. Nothing too crazy here. And then next one, I'm going to say if, or I could even say if I want. And again, this is something that you can decide what you prefer. I usually like using if it's part of the same concept as the first one. In this case, yeah, we're still trying to figure out what type of user it is. So we'll use elif and we'll say elif. We want to check if it's a magician. So that is magician. So we're going to check if that's true. But we also want to check if, well, not an expert. Now, how do we do this? I mean, we could say use short circuiting and say is expert. And even if this is false, we can get true here because is magician, short circuit, and print this part. At least you're getting there. Because the interesting here is that this code block is never going to run if both of these are true, because in the first if block, we're checking that. So that as soon as this is true, we're going to completely ignore the elif. So we could do that, but this is a little bit hard to read because I really have to think about it. If I come back to the code or somebody else looks at my code, it's not clear that unless I comment that I'm checking if it's magician but not expert. Because this will never run if is magician is false, then that's what they're checking for. I know it's kind of confusing even saying it. So I prefer using something like this, using and not. And that reads a lot better, right? It makes a lot more sense. Hey, if this person is an expert and magician, do this. Otherwise, if this person is magician and not an expert, then print this. That reads pretty nicely. And yes, you can do this because remember, not is simply checking and inverting whatever the Boolean expression is. So this still evaluates to a Boolean that and can check. All right, let's finish the final one. If you're not a magician, you need magic powers. So how do we check here? Well, we can do another if and say not is magician. And if I run it like this and say print, and we'll just copy here, you need magic powers. And let's remove the comments for now, just so we can see the blocks of code. And we're going to test our program. Hopefully we coded it properly. Hopefully there's no bugs, but let's have a look. If I run this, you need magic powers. Why is that? Well, if magician is false, none of these are going to work. What if I change this to true? And I click run. All right. I am a master magician because I'm an expert as well as a magician. What if I turn this to false and I click run? Hey, at least you're getting there. I'm a magician, but I'm not an expert yet. I still need to improve my gameplay. Now, you may have gotten a different answer than me. And there's many ways to do this, right? You could have used an else statement. You could have used or. Conditional logic is all about writing code that makes sense, not only to you, but for other people reading your code. The idea is not to be extremely clever or really worry about short-circuiting. Yes, it can be more performant, but a machine is so powerful that just tiny bit of optimization there is usually not worth it when you're losing perhaps readability. So you want to make sure that your code reads like English. And this is a topic that, frankly, a lot of beginner programmers have a hard time understanding, where they try to be as clever as possible, write as little code as possible in the shortest possible lines, when instead you want to focus on readability. Because a code that is easy to understand is a sign of a good developer. And I hope looking at this, you're thinking, yeah, this is pretty easy. I mean, this all makes sense. But this is not the only way. Maybe my version of what reads well is different than yours. The idea is to each of us try our best to make our code simple and nice. And in programming, there is no one right answer. There are many ways to solve a problem, but the key is to solve it in a simple manner that is readable. I hope you had fun, and I'll see you in the next one. All right, in this video, I'm going to try and trick you. I want you to look at these expressions where I'm checking for equality, right? I'm saying, hey, does true equal 1? Does empty string equal 1? Do two arrays that are empty equal, well, each other? Now, pause the video here and try to guess what the outcomes of this are going to be. Ready? By the way, if you get 100% on this, well, good for you, because if this was my first time learning Python, I wouldn't get this. Let's go. Is that what you expected? True evaluated, so true equals 1 evaluated to true. An empty string equals to 1 evaluated to false. That makes sense because they definitely don't equal each other, right? An empty array doesn't equal to 1. And a 10 equals 10.0. And then both arrays that are empty equal to true. Now, the reason I'm showing you here is that the double equals checks for equality or equality of value. That is, if, for example, the first one, true equals to 1, there's two different types. One's an integer, one's a Boolean. It will convert them into the same type. In this case, this will be converted like this to a Boolean value. And if you remember, 1 is truthy. So this will evaluate to true, which is why we get true. What about the other one? Well, an empty string is falsy, so it evaluates to false, and false doesn't equal true, right? Because we're checking for equality here. So one of these gets converted to the other's type. What about an empty array? Again, an empty array is actually falsy. So that's not going to equal 1. A 10 equals to a float of 10.0. That gets converted to an integer or a float. and they're going to equal each other. And that's an expected behavior. And then an empty array, well, equals an empty array. If I add in this array 1, 2, 3, 1, 2, 3, and I click run, I get an invalid syntax. Oh, because I have this here. Let's run that again. I get true. That makes sense. Let's change this to 1 and see what happens. If I click run, all right, still false. Now, this does get a little tricky, right? Like, should this have evaluated to true, but no, we get false. So this doesn't get converted in type versus what we had here. Now, don't get confused by this because this would be bad code. If you're checking something like this, well, obviously you should be checking two of the same types together. Ideally, when you use comparison operators or logical operators like this, you're comparing two types and you're not letting Python do this type conversion, and hopefully Python figures it out for us. But I hope the double equality makes sense, because there's another check that we can do, which is. And is, well, is a keyword in Python. What happens if we change all these equal signs to is? Do you think there would be a difference? Let's have a look. If I click run, I get false for everything. So what's the difference here? Equals checks for the equality in value, such as 1, 2, 3. Well, that has the same value as 1, 2, 3 in a list. Is actually checks if the location in memory where this value is stored is the same. Let's go through that. So true, is that 1? No, true is not 1. True is, well, only true, right? That will be true. What about string 1? Is that 1? No, I mean, for 1 to be a string, that needs to be 1, right? Because the 1 string isn't only in one place in memory. It's literally the exact same thing. What about this list? As a matter of fact, let's do is array, empty array. Is that, or is this list a list? Well, if we run this, I still get false. And this is a little tricky and also advanced. Every time I create a list, it's added in memory somewhere. So this is in a location in memory. But whenever I create a new list, it's created in another location. So these are two completely different lists that live in different locations in memory. So it's going to check, hey, is this in the same memory space, same bookshelf as that one? Nope, that's not it. But why does this work for things like numbers and strings? And that's because underneath the hood, these are types that are very simple that are in memory but in one location. Versus something like a list, even though this might be the same list with the same items, because this is a data structure, every time we create it, it's created in a new location. So that even if we have a variable a that contains this list, and by the way, this will be the same for all our data structures like dictionaries, sets, tuples. If I do b equals this, and I check a, is that b? Nope, they're created in a different memory space. So this, where a points, is in a different place than where b points. But if I do a equals to b, I get true because this double equality checks only the values. Now, this is a bit of a hard topic. So you might have to watch this video a couple of times. You might have to practice this a few times yourself. But just keep in mind the difference between is and double equals. Is tends to be a little stricter You're checking for the exact thing that you're looking for versus equality, which checks the value. All right, that was a doozy. I'll see you in the next video. Bye-bye. Let's talk about loops. We've talked about conditional operators, logical operators, but loops gives us a whole new power when it comes to our machines. The concept of loops or looping in programming is really, really powerful. We saw that with logical operators and conditional logic, we're able to skip lines in our program so that we don't always go 1, 2, 3, 4, 5, 6, so on and so forth. But loops do a really interesting thing. It allows us to run lines of code over and over and over. And that's really powerful because that means we can run things thousands of times, millions of times. And this is where machines excel. Machines excel at doing small tasks over and over really, really fast. Way better than humans. So loops are one of the most powerful features of programming languages. So how do we create one? Well, it's as simple as using what we call for, or in Python, we call them for loops. With this keyword, for, we're able to say for, let's say item in 0 to mastery, do something. So they're kind of like conditional operators. Instead of if, we have for, but then we have this thing, right? Where we have item, which, what is that? We don't really know. Well, this is a variable that we create. We can name it whatever we want. We can say I. We can say teddy bears. Whatever we want. This is a variable. And a variable is created here for each item after the in. So it's saying, hey, for every item in 0 to mastery, do something. And we've seen this in keyword before. And we'll dig deep into this later, but we call this an iterable. An iterable is something that is able to get looped over. So an iterable allows us to use this notation of a for something in an iterable to iterate over each item. In our case, if I print item here and I click run, look at that. It prints each item in the iterable, which is the string 0 to mastery. So every letter, it goes into every bookshelf in our machine's memory and prints each item one at a time. Now this works with strings, but we can also use lists like 1, 2, 3, 4, 5 that we've seen before. If I click run, again, this is an iterable. We're able to iterate over it and it grabs each item in the list. Let's do a set. Can we do this with a set? Well, if I click run, that works as well. What about a tuple? Let's do it with a tuple. If I click run, that works as well. That's amazing. What about a dictionary? Well, we'll get to dictionaries in a bit. So for loops allow us to iterate over anything that has a collection of items. So that in this case, we're looping 1, 2, 3, 4, 5 times. And you can see over here that we have the colon and then the indentation to tell Python, hey, whatever comes here, I can print item again. I can print item again. I can do it as many times as possible. As long as I have indentation, it's going to keep printing our numbers. But as soon as I open up here and print something else, well, I only get that once because it's not in the loop. So our program first runs this for 1, so it's going to print 1 3 times, then 2, then 3, then 4, then 5, and then only finally then it goes to print. You see how we're looping over and over and over. Now, what happens if I try and print item here? And I click run? Did you see that? Item gets printed at the very end here. I don't know if you can notice it, but you see that there's 4 5s. We've printed 1, 2, 3, 4, each 3 times, but 5 gets printed 4 times because this last print at the very end is, well, 5. Because by the time the loop ends, the value of item is actually 5. Let me ask you this. Can I do something like for, let's say, X in another list that contains strings A, B, and C? Could I do something like this? Absolutely. I can nest things in Python. And as a matter of fact, when we do conditionals in Python, like if statements, we can always nest those as well. Because in Python, it's always the indentation, right? So I can say print here item, and then also print, and you know what? Let's print them one next to the other. So I'm going to say print item and print X. If I click run, you see that we're printing 1 and A, 1 and B, 1 and C. Because item, we run line 1, so item is currently 1. So we're going to go to the next line, line 2. And we're going to say, we're going to loop over this iterable. And we're going to say this is X. So this is going to be 1, this is going to be A. And then Python comes back to line 2 because we're still in this loop. And we're going to say, hey, what's X now? Well, we're done with A, so let's go to B. So it's going to run B. And then C. And only once this is done does it go back out and now starts with 2, which is right here. 2A, 2B, 2C. So you can have nested loops over and over and over as well. All right, so these are loops. And right now, maybe it's not completely obvious why these may be useful. But before we get into that, I want to talk about this idea of iterable in the next video. Welcome back. I kept mentioning this key term, iterable. But what does it really mean? Iterable, you're going to hear that over and over in Python programming and other programming languages as well. And as we discussed a little bit in the previous video, iterable simply means it is an object or a collection that can be iterated over. So again, an iterable can be a list, can be a dictionary, can be a tuple, can be a set. It's a collection of items. We also saw that a string could be iterable. Now, these things are iterable. Why? Because they can be iterated. That is, iterated means we can go one by one to check each item in the collection. And you're going to hear this over and over when talking to Python programmers. So you want to make sure that you have that vocabulary. You're iterating over something. You're looping over something. So iterable is the noun, and iterated or iterate is the action of iterating over an iterable. I know, it's a little confusing. Now, many objects in Python, like I said, are iterable. But there's a few special ones that we haven't covered yet. Specifically, dictionary. We saw how lists, tuples, sets, and strings can be iterated. But what about an object? Let's say we have an object here, and this object will be users. And users, or user, will have a name of Gollum. We'll have age of 5006. Gollum's pretty old. And then we'll say can swim. Gollum, let's say, cannot swim. False. What if we use this object right here for item in user, and we print right here the item? What do you think will happen? Let's run this. Well, I get an error because I forgot a semicolon here, and we don't want equals, we want semicolon. And then obviously this needs to be a string as well. Now, if I click run here, look at that. I get name, age, and can swim. So I've printed the keys of the dictionary. Now, this dictionary, we have the keys. That's great, but what if I wanted actually the values? Is there a way to do this? Well, dictionaries have 3 methods that are really, really useful when we want to loop over their keys and values. The first one is items. And with items, when I do this and I click run, you'll see that I get the key value pair in a tuple. And this is a very common pattern that you'll see a lot. Another one that we have is values. And guess what that does? That gives us the values of the dictionary. And we saw that user, just leaving it blank, gives us the keys. But we have a method that is more descriptive and allows us to show exactly what we want to do, which is keys. And if we run this, you'll see that I'm able to iterate over the keys. And these 3 methods are very common, and you're going to use them a lot in your programming career. So make sure you take note of them. Items, values, and keys. It allows us to iterate over dictionaries. But another interesting thing that you can do, and another common pattern when iterating over dictionaries, is what if you want to print, for example, separately the items, name, and column. So right now we're returning a tuple. And we saw that we can do tuple unpacking, right? I can say key value equals item, and then just print key value. If I run this, you see that I'm able to print these. But there's actually a shorthand way of being able to do this. In here, in the for loop, I can say key value and just completely avoid this entire line. And if I run this, there you go. It still works. And this, again, is a very common pattern, where if you're collecting the items of a dictionary, you can separate them into key and value, or you might even see shorthand K and V. Again, these can be any variables that you want. You can name them whatever helps your code be more readable. By the way, just for fun, let's say in the last line here, I want to iterate over the number 50. What do you think will happen then if I click run? Sorry, name error. Name key. Oh, I get an error here because I haven't changed these, so let's change these back. That's not the error I was expecting. The error I was expecting was this. Type error. Int object is not iterable. Now this error should make sense now because I've said it over and over. Why is it not iterable? Well, because it's not an object that can be iterated over. It's not a collection of items. Because we learned that in Python, these are iterable. I'll see you in the next video. Bye-bye. Welcome back. Let's try a simple exercise. I want you to build a simple counter. And this counter is going to count the items in our list. What does that mean? Well, let's say I have a list, and this is a reserved word. Remember, it's an actual word in Python. So let's name it my list as a variable. And this list has 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. What I want you to do is using looping to loop over this iterable list and sum up the total of the list. Pause the video if you need to. Otherwise, let's see how we can do that. What I'll do is create a counter variable. that will equal to 0 to start off with. And then I'll say for item in my list, I'm going to counter equals counter plus item. And then at the end, I'm going to print counter. Let's see if this works. I'm going to hit run, and I get 55, which, if my quick math is right, should be correct. Now, when doing this exercise, you may have gotten tripped up a bit. So let's think about this. Some of you may have made an error where you did the print here. But if you did the print here, you remember that it's going to get looped over. It's part of this code block because of the indentation, and it's going to print as many times as there are items. So you have to make sure that the indentation is like this so that you get the total. The other thing that you noticed is that in order for you to keep a counter or a total of all these items, you had to make sure that you had a variable outside of the loop, because the loop runs the code over and over. And you needed something on the outside that doesn't change. Because if you moved the counter to 0 here, well, every time the counter would be reset to 0. So that by the time we get to 10, counter would be 0. So you get 0 plus 10, which equals 10. And then you'd get, well, 10. So you have to be careful here that the indentation is an indication of us looping. And when you loop something and you want to keep a tally or total of something, that you have these issues of making sure that what you want to loop over is inside of this code block. But what you don't want to, if you want to have some sort of information that's outside of this loop, that you keep it like this. If you weren't tricked by this question, good job. If you were, don't worry, it's all part of learning. I'll see you in the next one. Bye-bye. When looping in Python, one of the most common tools is this range function that we get out of the box with Python. And you see here that range, well, is a range object, a special type of object in Python that returns an object that produces a sequence of integers from start to stop. Let's explore that a little bit more. If I print here a range, and I say range 100, and I click run, I get range of 0 to 100. So it looks like a tuple, but it's not. It's a range object. It's a special type of object. And range, you can give it like this, which gives you a default of 0 to whatever you give it, which is 100. Or you can just simply type 0, 100. And if I click run, it's the same thing. But where range becomes really useful, and you'll see this in 99% of cases in Python, is in for loops. You see, besides tuples and lists and sets and dictionaries and strings, you can iterate over a range. So for example, if I do for I in range, and let's just say item, or in our case, let's just do number in range, and in here I do print number. If I run this, you'll see that I'll get numbers 1 to 100. And why is this useful? Well, using range, I was able to loop 100 times. As you can see, all the way till 99, because our count starts at 0. And we're able to loop as many times as I want. So I can tell the loop. Maybe we want to loop a certain number of times. Maybe you want to loop 10 times, where I can tell the loop how many times to run. It's extremely useful. Maybe here we're performing some action where it says, I don't know, email list. So we want to send 10 emails to an email list, for example. Well, again, I can just click run, and I sent that email, well, a bunch of times, 10 times. Another neat trick is that, well, you might not even need number, right? We're not really using it in our code. And often what you'll find in Python programs is if a programmer doesn't need this variable, you just do an underscore. And this is just a variable. I mean, you could use it like this, and you'll still get these numbers, but it just indicates to other people that, hey, I don't really care what this variable is. I'm just trying to use range so that we can loop over things, let's say 10 times. Now, range also comes with a third parameter. And what that is the step over. So if I do 2, and by the way, default is 1 here. If I do 2, it jumps from 0 to 10 by 2, which is very, very handy. So what is range? Well, range creates a special kind of object that we can iterate over. Okay, what if I do right here. What if I do -1? Well, if I run this, that's not going to work because, well, let me show you why. If I change this to 0 and 10, and I do -1, it's going to go in the opposite direction. But if I did just 10 and 0, that's not going to work. If we want to do something in reverse, we just have to make sure that we add that -1. Or if we want to step back twice, then we click run. So you have a lot of options to play with the range. You can do ascending, descending. One final thing. Another place that you might see ranges, and like I said, most of the time they're in for loops, but you can also do something interesting like, let's say, a range of 10. And then if we wrap this in a list, remember a list function allows us to convert something to a list. If I run this, did you see that? Let's simplify this so that this range is going to just be 2. If I click run, you see that I loop 2 times. And in here, I'm going to print, first of all, I'm going to create a range, an iterable object that has 10 items. And then I'm going to convert that into a list. So you can see here, 0 to 9 into a list. So this is a quick way to create a list that, well, has integers. A neat trick that you'll definitely use along your programmer journey. I'll see you in the next one. Bye-bye. Let me show you another useful function that we'll use just like range. Mind you, it's not as common as range. Range, you'll see it a lot in Python code, but this other one is still very useful, and it's called enumerate. Now, what does it do? Let's have a look. I can do a for loop, and I'll say for, and we'll say character in enumerate, and then enumerate, we wrap around something that, well, we want to enumerate. So let's see what that means. It returns an enumerate object. So iterable must be another object that supports iteration. So we have to give it something that enumerate can iterate over. So this time around, let's just do a string that says hello. Now, enumerate is special because what it's going to give us is it's going to take an iterable object and gives you an index counter and the item at that index. What do I mean by that? Well, you can actually say I, comma, character. So we're unpacking this and we're saying, hey, print I and character. If I click run, look at that. I get hello iterated over. Again, if we don't have enumerate, then we would have just gotten hello. But we also, because we use enumerate, we get this I, or index, of each item and where it is in the index. So that if I had a list here, let's say 1, 2, 3, again, I'm able to use and access the index number of the item as well. what if we had a tuple? Again, we get the index number. So enumerate is very useful if you need the index counter of the item that you're looping through. So let's do a little exercise. Let's say that we want to create a script that enumerates a list of numbers 1 through 10. So we'll use range to create that. I'm going to say list, and then I'm going to say range. I know there's a lot of functions here. Range, that is 100 actually. Let's do that. And I want to be told what the index of the number 50 is. So pause the video if you need to do that. Now, here, I want it so that, let me make this a little bit bigger. I want it so that we only print the index of, let's say, the value 50. I want to know where 50 is in the list. Now, again, this is a simple example, so you can probably already guess what the answer is. But how would you code this so that only in here we get the index of 50? Or it says the index of 50 is whatever. Pause the video if you want to give it a go. Otherwise, let's try this. I'm going to do a conditional and says if character is equal to 50, then I'm going to print index, or I'm going to do an F string, and I'll say that the index of 50 is, and then I'll add the index in here. So that if I run, I get index of 50 is 50. And just to confirm, if, for example, I just print here, and let's say print I in character, I click run, we see that, yep, we have the indexes the same as the numbers. Again, not too difficult of a question, but you see here that we're able to extract this information. Again, not as useful as range, but you will see it occasionally in code. So I wanted to make sure that you're not surprised by it. As you can see, it's not that difficult. Welcome back. Up until now, we've learned that with looping, we can use for. But there's actually another way for us to loop. And it's called, instead of a for loop, a while loop. And while loop is a little different in that we say while a condition is happening, do something. So you can see that there's a bit of a difference here. For example, I can say that while 0 is less than 50, do something. Or I can say, for example, I equals to 0, and I'm going to say while I is less than 50, print I. Now, if I ran this program, what do you think will happen? Let's find out. If I click run. All right, do you see that? I don't know if you can tell, but I'm scrolling right now through all of this. It's looping, 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 looping. And you see that the programming's still running. As a matter of fact, I have to stop it because what it was doing is it was looping and looping and looping, because if we look at the code, well, 0 is always going to be less than 50. So what happened was, while this was true, we printed I. And then the Python interpreter went back to line 2 and says, hey, is 0 still less than 50? Yep, okay, next line, print. Hey, is 0 still less than 50? Yep, okay, next line, print. And it kept going, kept going, kept going. Now, this is what we call an infinite loop. That is, the program doesn't know when to stop. I mean, we're telling it to just keep going forever, for eternity. And I have some safeguards in place here, but if you did this in code, you'd get this infinite loop until your program crashes. If you actually ran this code, well, it's going to keep running until the machine just doesn't have enough power anymore, enough resources to keep doing this over and over. Everything has limits, right? So with a while loop, we have to be really careful. This infinite loop can be very dangerous. So how can we solve this? We have this idea of a break statement. And break is, well, just another keyword in Python. And as you may have guessed, if I click run, look at that. It only runs once. As soon as Python sees break, it's going to say, all right, break out of the while loop. So it's going to go to line 5, and it's going to say, got nothing there, program's done. I'm going to exit out of the program. But okay, what if I want this to be looped 50 times? How can we solve that issue? Think about it. Well, we can just simply say I equals I plus 1. And then make sure that we change this to I. Now what's going to happen? If I click run, we stop, well, at 49. We've done it 50 times. We've looped through it 50 times because we kept incrementing I over and over. So that I, each time we came back to the loop, was incremented by 1. Now a shorthand for this, we've seen it before, is to do plus equals 1. So that if I run, look at that, same thing. So we're also able to break out of the while loop as long as we're able to turn a condition into false. So you'll see this a lot as well. So to jump out of a while loop, you can either turn the condition false, or you can break out of the while loop. Now, another interesting thing that we can do with a while loop is we can have else blocks. And here, we can say print done with all the work. And if I click run here, at the very end, look at that, done with all the work. And this should read like English, right? While I is less than 50, keep looping through here. And as soon as we get to the last part, where I becomes 50, where 50 is no longer less than 50, Python interpreter is going to say, all right, I don't care about anything under there. Let's go to the next line. And I get otherwise. So in this case, we don't have anything else happening. We can print done with all the work. But you're probably asking yourself, hold on. Can't I just not do this and just make sure my indentation is at the end? Click run and that works, right? Why would I ever want to write else here? Well, else is a special case here. There is one thing that is useful. That is, if we added for example, a break statement here, and I click run, you'll see that the else statement does not print. And that is because the else block will only execute if there isn't a break. That is, if the while condition turns to false, then it's going to keep going and do the else. But if there is a break, it's going to break out of this whole thing and go to the 8th line. So a little gotcha here that you won't see else too often next to while, but there is that special case where else is used when you want to make sure that this will be executed only if there isn't a break statement. Only if the loop is finished doing whatever it's doing without the break statement. Let's take a break and explore while loops a little bit more. So when should you use a while loop and when should you use a for loop? And it really depends on the problem you're trying to solve. For example, in a for loop, I could do for item in, let's say, a list, 1, 2, 3. And just looking at this code, you know right away that it's going to be looped over 3 times, right? And I could say here, print item. But you can do this in a while loop as well. I can say I equals to 0, and then while I is less than, let's say, the length of the list, that is 1, 2, 3. Well, in that case, I want you to print I, or the item, and then increment I by 1. If I run this, I see that, well, technically here we're incrementing the I, which is the value, but let's say we had a list up here. So my list, and this list will be 1, 2, 3. Well, my list can be iterated with a for loop, or it can be iterated with a while loop, and we simply say my list at index of I. And if I run this, I get the same results. But which one do you think is better? First off, while loops are very flexible. We can do a lot because we have this conditional statement. We can loop more than 3 times if we really wanted to. So in that case, while loops are more powerful. But for loops are simpler, right? Like this code reads really nicely and really well. It makes sense. We just want to loop over something that we already know how many times we want to loop over, 3 times. With a while loop, we have to create this variable, and we have to make sure we remember to increment the variable so we don't get an infinite loop. So with a while loop, you need to make sure we remember to halt the loop at some point. So my rule is usually this. For simple loops or iterating over iterable objects, for loops are great. But let's say you're not sure how many times you want to loop over something. You're not really sure how long it's going to take for looping. So you want to say while something is true, just keep looping. For example, let's say we're trying to go through an email list that we've collected on a website. And for each email list, we want to send an email. Well, while the list is still there, let's just keep sending emails. There are many, many cases, but one of the most useful ways to use the while loop is like this. Is to say while true, do something. And make sure that at the end we break. Hold on, what's happening here? I'm saying while true, wouldn't that create an infinite loop? I mean, true is always going to be true. And you'd be right if you notice that. But again, we have a break statement here. So at the end, after we run line 3, it's going to break. But now we can do something powerful like input here. And if you remember, an input is going to ask us for a prompt to enter something. So I can say, hey, input, say something. And if I click run, it's going to say, hey, say something. You know what? Let's add a semicolon here or a colon here. And let's try that again. And look at that. It's saying, say something. I'm on line 3 right now. So I'm going to say, hi. And did you see that? We just broke out of the loop. It only asked me once. Even though this was true, as soon as we got to line 4, I was done. But what if I remove this? And I click run. If I say something, I say hi, and then it asks me again, hi, hi. I'm telling hi, and it keeps asking me, and we have an infinite loop. But the interesting thing here is that we can use conditional logic, right? What if we said response here and collect whatever the response is and say if response is equal to, let's say, bye, then I'm going to break. So that if I run this again, I say hi, keeps asking me, and you know what? I'm getting annoyed with you, machine. I'm going to say bye. It's going to exit it out for me. How cool is that? So while loops are extremely useful for tasks like this, where looping can happen for a long time. You don't know how many times it's going to happen. But this is something that you're just going to have to get used to with practice. Eventually, and I promise you this happens where you'll figure out when to use while, when to use for loop. But at the end of the day, use whatever solves your problem. I'll see you in the next one. Bye-bye. Welcome back. Now, up until now, we saw the break keyword that we can use to break out of a loop. And you see here that we're able to loop with a for loop, but with a while loop, as soon as we break, we're done. We've just, well, broken out of the loop. But could we do that in a for loop? Let's find out. Yep, break keyword works in a for loop as well. But there's actually two other things that we can use besides break. One is called continue. And you can see here, again, blue highlighting. If I do continue here and I click run, there you go. We get our looping again. But you're thinking, why do we need this? Like, it seems completely useless, right? Well, a break, when we use the break statement, it breaks out of the current and closing loop. So when we used a break statement, we broke out of this loop, right? This whole while loop, we just exited it. And same with the for loop, we completely exited it. However, with a continue, what we're saying is, hey, whatever happens when you hit this line, continue on to the top of the enclosing loop. So the current enclosing loop, what is it? It's this for loop. So it's going to go back to the for loop. So that if I do something like print here, so that we get it printed twice, or you know what? Let's just move print down here, like that. And then same here, we're going to just print at the bottom after continue. If I click run, nothing gets printed because as soon as it sees continue, it's going to say, okay, I'm going to go back to the loop. And it's going to keep going, keep going, keep going until, well, the loop ends so that we never actually hit line 10 and line 4. So that becomes really useful in conditional logic as well. Finally, the third one is called pass. And pass is, well, not very useful. It essentially does nothing. If I click run here, and again, it shows me here, line 10, something's wrong. Well, we have to move print up to the top so that, well, we don't get my list of index of 3, which doesn't exist. So again, going back here, if I click run, pass doesn't do absolutely anything. It just essentially passes to the next line. So why is that ever useful? It's very rare that you'll see pass in your code, but pass is a good way to have, let's say, a placeholder while you're coding. For example, you want to loop through the for loop, but we don't know what we want to do yet in the code. Let's say that here we're still thinking about it. If I do this and I click run, I get an error here because, whoa. Expected an indented block, because now the for loop or the Python interpreter is looking for the next, like, what am I supposed to do with the loop? I'm trying to loop and there's no code for me. So you can add a pass here to at least fill something for the for loop to say, hey, I'm thinking about it. I'm just going to pass it for now just so you have something so you don't bug me, and I'll come back to it. So if I click run, that still works. So pass is one of those placeholders that we can use so that there is a line of code that does absolutely nothing that we can still pass through. Again, a very rare thing to see in production code, but while you're developing, some developers like using pass. And there you have it. Break, continue, and pass. I'll see you in the next one. Bye-bye. All right. Your head must be spinning because of all these looping. That's a really bad joke. But I thought it was funny because I've been recording for hours now and I think I'm going a little kooky. So this is going to be my last video for the day, not for the course, but we're going to do a little fun exercise. Now, I call all exercises fun. Obviously, I'm biased, but this one's especially fun. What are we going to do? Well, we're going to simulate what a computer does when we have something like a graphical user interface. That is, a computer is able to display, let's say, even an image over here, right? I can see the robot over here. I can see the mouse. This is a graphical user interface. I see pictures, I see images on my screen, these pixels on my screen, and I can control them. Well, we're going to create a basic version of this to show you how a computer would work just from the stuff that we've learned up until now, using loops and using conditional logic. So what are we going to do? Well, this is the exercise. And you can check out the REPL here, or you can recreate this, or again, in this video, you should have resources attached that you can play with it yourself. And what I want you to do is I want you to loop through this list of lists, and every time you encounter a 0, I want you to display on the screen over here an empty space. Because 0 in a computer denotes nothing, right? We want a blank on the screen. However, when I see a 1, I want to simulate a pixel, right? That tiny, tiny dot on our computers that can be full of colors. It could be green, it can be blue, it can be orange. But for our case, I want it to be a star. And using that, I want you to create a program that takes this picture that, let's say, is in our database or in our computer's hard drive and displays it on the screen using space or multiply. And all I want you to do is when I click run, I want you to display that image right here. All right, this is a little tough one and I'm kind of letting you figure out on your own, but trust me, you've learned all the tools necessary to do this. Pause the video, give it a go. Otherwise, I'm going to show you how it's done. So the very first thing I like to do is to think about what I'm about to do. I want to make sure that we have a plan in mind. So I'm going to comment first, and I'm going to say, well, we definitely want to iterate over a picture, right? So we're going to do some sort of iteration here. So that's number 1. And then in here, I want to say that if it's a 0, then I want to print an empty space. And if it's a 1, I want to print a star. All right, so that's the plan. Okay, so this shouldn't be too hard. Actually, before you get started, in order for this to work, you need to Google a special parameter or special option that you can give the print function. And as a matter of fact, the print function that you need to add, or the option that you need to add, is this end option. And if we scroll down, it doesn't display it that well, but you can see here, string appended after the last value. So the default when we print something is a new line, but ideally we might not want a new line. So when that happens, you might have to use this end option. Now, I know I left it really vague. I want you to practice Googling this and figuring out from your mistake. You're going to have a bug when you create this code, when you try to display this information. But try to solve it using the tools that you have of problem solving. All right, enough talk. Let's get to it. So the first thing I want to do is iterate over the picture. I'm going to say for image in picture, because, well, this is one picture right here. So this is the picture, but it's inside of a list because we can have multiple pictures. And then I'm going to loop once again over this individual list. So once again, I need to do a for loop, and this time I'm going to say for pixel, because each one of this is a pixel in the image. So this is a nested for loop. Now, I'm going to add a conditional and say if pixel equals 1, then I'm going to print a star. Otherwise, I'm going to print an empty string. Well, maybe not empty, right? Because we do want a space, a blank space in the image. All right, so let's see if this works. If I click run, that's not really what I wanted. I want a clear image here, but I'm just getting things one in line. And remember, this was the little trick where a print, every time it prints, it creates a new line. The default, again, if we close this, you'll see is that end equals to this escape sequence of new line. So we can change that by simply saying star, comma, end, and then I'm going to say for the end, I don't want a new line. I just want, well, a string, but an empty string. And same over here. If I do comma, end, and if I click run, all right, it's getting a little bit better, but now I have an issue where we don't have any new lines. Everything is on one line. That's not good. How can we solve this? Well, ideally, at the end of this first loop, where we're just going the image or the line in the image, at the end of this, we create a new line right here, right? So again, looking at the indentation, I don't want a new line on every pixel, which we had the first time, but I also want to add a line between the lists of rows. So maybe a better name for this will be a row in picture. And in here, I'm going to add at the end of this for loop, so after we're done looping through the entire row, at the bottom here, I'm going to print an empty line. But remember, the default is going to be a new line. So again, an empty string, it's going to default to a new line, and we're still going to have this code. If I run this, I get an error because image is not defined because I've just changed this to a row. So let's do row here, click run, and look at that. We have our beautiful Christmas tree. If you don't think this is beautiful, this is the best I could, but this is a Christmas tree. And we finally have it displaying. We've used loops, we've used conditional logic, and we used a little Googling to figure out, hey, we need this option. Now, our code works, but I want to do something better here. And in the next video, I want to clean up this code a little bit and cover a very important topic when it comes to programming. I'll see you in that one. Bye-bye. It's happening, our next developer fundamentals, and that is, what is good code? I mean, what is good? That seems so vague, right? Like when somebody says, I'm a good coder, I'm an excellent programmer, he's a senior programmer, he's an expert programmer, he's a tech lead, he's a genius. What does that really mean? Well, you can narrow it down to these simple statements. What is clean, good code? I kind of gave it away. The first one is clean. That is, we want to make sure our code is following a style that, let's say, the Python community endorses. Are we following the best practices? And Python has this great feature of auto-format. And Python has standard ways of using spaces to make sure that our code is clean. I'm not using unnecessarily ugly spaces like this, or maybe making lists really weird and funky, maybe no spaces in between here. Maybe I have a lot of random comments over here. We're keeping our code clean. We make sure that every line that we have is easily readable, but also we don't have any extra stuff that we don't need in there. And this also relates to the idea of readability. Now, readability means the ability to read your own code. Maybe 2 years down the road, you're going to come back and look at the code. Are you going to be able to understand it? If you work in teams or for companies and other coworkers come and look at your code, is it easy to understand? And here, this is obviously personal preference, but most of the time the ideas are simple. For example, I'm using names here that make sense. If I had variable names that don't make sense, it'll be really hard for somebody to read my code. Maybe people will be confused why I have this print statement here. In that case, maybe I should comment in here being like, need a new line after every row. Or maybe they'll be confused why we need this as well. So depending on your style, you might want to add comments. Make sure that the naming of your variables are good, and maybe making sure that it's not only you that understands the code. The other one is the idea of predictability. And this is my favorite one. That is, sometimes people try to be really clever with their code, trying to have the most compact code, or using the newest features or some really obscure tools or functions that are not very common just to look, well, frankly, smart. But you want to have code that makes sense, that does things, just one thing really well. Now, this code is quite small, so it's quite predictable. It just has one pass through and it's easy to predict what's going to happen. We're going to print. But as we get more and more into the course, you'll see that our code is going to get larger and larger. And having predictable, easy to understand code is really important. And then finally, this is an important principle that you hear everywhere, is DRY. Do not repeat yourself. You don't want to have code that you're constantly repeating yourself over and over. Again, this is a small example. But it's very easy as a programmer to say, oh, I'm going to copy this and then I'm going to run this again so that if I click run, look at that, I have 2 trees now. This is amazing. But maybe that's not the best idea. You now have 28 lines of code and people might be confused why we're doing this twice. Maybe instead, we want to programmatically have a counter here of maybe saying running this twice, or maybe using something like functions, which we'll learn later, to make sure that we can repeat this process over and over and over. Now, keep these in the back of your mind, because throughout the course, we're going to explore these topics. But let's say I just came onto this code and I wanted to clean it up a bit. Again, this is just personal preference, but these are some of the things that I would do. One is here, pixels equal to 1. Instead, this is kind of confusing. I'm just going to say if there's a pixel here, and I know that pixels are either 0 and 1, then print here, because this is a truthy value that will just evaluate to true. So that just kind of cleaned out my code a little bit better. Next, another thing that I might do, maybe I want to make this more extensible, which might mean doing something like, let's say, fill variable that equals to the star, and then maybe empty, which equals to an empty string, and change these to fill and empty. Now, this is extra line of code, but for example, if we're doing this multiple times, instead of perhaps maybe we're running print over and over and over, or maybe we have another line of print over here, and another line of print over here, and then maybe another line of print over here that is empty. Instead of me having to change 5 locations here, I can now change just this part. And maybe instead of star, I want to display, I don't know, $sign. And if I run this, all right, I get a little different image here. But again, I was able to just change the variable, and the variable was used to fill out whatever I needed done. Now, these are all things that you do need a bit of experience to get used to, but we'll hopefully explore this throughout the course, and by the end of it, you'll have all these best practices in mind. I'll see you in the next one. Bye-bye. Welcome back. Let's do an exercise where we check for duplicates in a list. So I have some list here, and I want you to be able to check this list and print whatever the duplicate values are. In this case, we see that N has duplicates and also B has duplicates. So I want you to print B and D as a list in here. How would you go about doing that? Pause the video, give it a go. Otherwise, I'm going to keep going with the answer. And by the way, you're not allowed to use sets for this. So for this exercise, you can't use the data structure sets. Instead, you have to just use conditionals and loops that we've learned in the past couple of videos. So give it a try, pause the video, and when you're ready, I'm going to go ahead with the answer. First, I'm going to create a variable called duplicates, and this is going to be an empty list that we're going to populate with any duplicate values. Next, I'm going to loop over this list, so I'm going to say for value in some list. And in here, well, what can we do? This is a tough one, but what I'm going to do is say if some list dot count. Remember, count allows us to count how many times an item in a list exists. And I'm going to say value so that some list dot count, and I give it A, it's going to count for me how many times A happens in the list. Very, very useful. Again, if you didn't come up with that, there's many solutions to this problem. So there's no one right answer. I'm just showing you how I would have done it. Now here, I'm going to say if that's greater than 1, in that case, that means there's a duplicate. So I'm going to add it inside of the duplicates. So let's just go ahead and say dot append, because I want to append, and in here say value. And at the end of all this, let's just print duplicates. Now let's see if this works. I'm going to click run. And all right, I get both B and N. But I don't need this duplicates. I just need to know what are the duplicates. I just need one instance of B and one instance of N. So what we can do here is do another if statement and say if value is not in duplicates. And yes, this is a bit of a trick. You may remember that not is the opposite, right? So we're checking, hey, is value in duplicates? And not essentially says, hey, if value is not in duplicates, it reads like English. And this is going to evaluate to true and false. And then finally, make sure that we get the indentation right. We're going to append the value. So if I click run, I get B and N. Again, if you didn't get this right away, don't worry. It can get tricky, and this is one of those things that you just need to keep practicing. But you see here that I was able to use loops. I was able to use logical operators like not and conditionals like if statements to solve a problem in just a few lines of code. It's time to talk about functions. This is where things get really interesting. Because up until now, we've seen functions, right? Functions were things like print, like list, boolean. We even saw the input function to get the input of whatever the user types. And those allowed us to perform actions on our data types. But the true power comes when we can start creating our own functions. That's right, we're not limited to whatever Python gives us. We're able to create our own functions and use them in our programs. So let's learn how to do that. The way we create a function in Python, and functions, by the way, exist in all programming languages. They're very, very important. If we do def, that lets the Python interpreter know that we're about to define a function. Def is short for define. So the interpreter is going to say, all right, they're about to define a function. What's the function going to be? Well, we can create whatever we want. We use the same naming case as we do with variables to define our functions. So let's create a function. Again, we'll call it, say, hello. just a variable that I created, but this time it's a function because we use the def keyword. Now in here, in say hello, we also add the brackets to let the interpreter know that this is something that we're going to take action on, or this is going to perform an action on a data type. We use the colon, and then within this block of code, we can say print hello. And that is a function. If I click run, nothing happened. Why is that? Well, we've created the say hello function. We've defined it, and now it's living somewhere in memory on our machine. However, in order to use a function, remember, just like we use the print function, we have to call it with the brackets. So after we define a function, we say hello. And did you notice how my REPL, as soon as I said say, actually gives me the say hello command because I've created it. And you see this purple box, which shows that it's a function. Well, we now have it available for us to use, just like we had the print function available for us to use. So if I do say hello and run it with the brackets, and I click run, I get hello. How cool is that? By the way, what happens if I run it without the brackets and I click run? Nothing happens. Because remember, in order for us to take an action, we have to let the interpreter know, hey, I want to run say hello. Now, the reason functions are so powerful is because of the principle that we've talked about, right? The idea of DRY, which stands for do not repeat yourself. Functions are really, really useful when you have things that you want to do over and over. For example, the print function, we've used it a lot. Imagine if we had to code that ourselves every single time and say what print function does. Luckily, Python gives us print because it's such a useful tool. But if in our program we want to say hello multiple times, and you can imagine this actually being a lot more complicated, maybe 10 lines of code. Instead of writing those 10 lines of code over and over, I can just define it as a function and use it anywhere I want in my program. For example, remember this, where we had a picture and we printed a Christmas tree? Imagine if we wanted to run this multiple times. Well, in order to do that, I would copy and paste this code and then add it again. And if I click run, I now have 2 Christmas trees. But look at that, 26 lines of code. I just copy and pasted the same thing over and over. With a function, we can do something like this. I can say define show tree colon, and we now have a function. But remember the indentation in Python, right? Indentation is important. We have the semicolon, we're defining a function, so we have to create that code block inside saying, hey, whatever's indented here, that's part of this function. So now that we have the show tree, check this out. I can say show tree, run it again. Maybe let's run it 3 times. If I click run, how cool is that? I'm able to do the same thing over and over by just calling this function. And that's the power of functions. Functions allow us to keep our code dry, we don't repeat ourselves, and reuse things that our machines can do over and over. And the beauty is that this stays in memory for us. Show tree now means something to this program because we've created it. So we have our own custom action that we can take. Now, what happens if I move show tree here to the top? Well, if I run this, I'll get an error, name error. Name show tree is not defined. Why is that? Well, because our interpreter goes line by line. it first says, all right, picture equals to this value. And then it goes to line 11 and says, run show tree. But we haven't defined show tree yet. So the Python interpreter is going to error out and say, hey, I have no idea what show tree is. What are you talking about? Instead, with a function, we need to make sure that we define the functions at the beginning so that Python interpreter says, all right, show tree now means this. I'm not going to run it. I'm not going to use it yet. I'm just going to keep it in memory. And when I finally come across show tree, I'll know that it means something. I'm going to grab it from memory using show tree, and then I'm going to run it using the brackets. For example, if I do print show tree without anything, without the brackets, if I click run, you see that I get function show tree at this location. This is just the location in memory. This is the bookshelf where we store that show tree function. Very, very cool. And functions are an important, powerful concept in programming. And in the next video, we're going to extend this and explore this a little bit more. I'll see you in the next one. Bye-bye. Let's talk about arguments versus parameters, which is one of our key terms that we use when describing functions. Let's see what they mean. You see, right now, our say hello function is pretty generic. Very simple, right? We're just, well, printing hello. It's kind of useful, but not really. The power of functions, beyond just being able to call this multiple times, because it only lives in one location in memory, is this ability for us to make it dynamic. For example, in these brackets, I can give it what we call parameters. So in here, we give it parameters inside of the bracket. So for example, I can give it name, which is a variable that I just made up. I can call whatever I want. And I can leave it like that, or I can keep giving it parameters, as many as I want. I can keep adding 100 if I wanted to. So in this case, let's just say this is an emoji. So these are two variables or parameters that I've created. And this say hello function is able to receive these two parameters. What does that mean? It means that we're able to use these variables inside of this function. For example, I can create this as an F string and say hello and add the name, and then finally add the emoji. And because I have these as parameters, I can use them as variables inside of this code block. Now, these parameters allow us to give the function, when we call it, what we call arguments. And by the way, the confusion between parameters and arguments, people usually say one when they mean the other. It's a little tricky, so hang in there. Arguments are used as the actual values we provide to a function. So now in say hello, I can give it a name. In my case, let's just say hi to myself. And then I can give it an emoji. And you see how my editor is giving me the hint that I should give it an emoji because, well, I defined it here. Again, something that editors help us do. So let's just give it just a smiley face with the tongue out. Now, these are arguments. These are the actual value we provide to the function. And the name of the variables that we use, that we receive, are called parameters. So parameters are used when we define the function, and arguments are used when we call the function. Define and call. And by the way, some people also like saying call or invoking the function, or invoke the function. So if you ever hear those words, you know what they mean. So if I run this, I get hello, Andre, with that smiley face. And this is when functions get really powerful, because we're able to not just make generic functions that always do the same thing, but we can create functions that do things based on what parameters we give it, or what arguments we call it with. So that now I can use the say hello function to say hello to my friend Dan, and also my friend Emily. And if I click run, we've made our function more extensible. We can use it in multiple places. And if we're designing a game, well, we've just used this to greet our users. And based on the username, I can use the same function over and over. Again, we're keeping our code dry and clean by doing something like this. How cool is that? All right, let's take a break, and I'll see you in the next video. In the previous videos, I showed you how to define a function with parameters. Now, the way I've shown you this and these parameters is what we call positional parameters, or we might want to call them positional arguments. And they're called positional arguments because the position matters, right? If I change our arguments to, let's say, Andre as the second argument, and if I click run, you see that I get hello, smiley face, Andre, which maybe is not what we wanted to do. Positional arguments are arguments that require to be in the proper position. So if we defined name here first and then emoji second, you have to make sure that the first argument will be the name and the second argument will be the emoji. However, there's something called keyword arguments. And keyword arguments allow us to, well, now worry about the position. What do I mean? Well, I can do something like this. I can say hello, and in here, give it a keyword and a value. So I'm going to say emoji equals to, let's say, this smiley face, and then comma, name equals to BB. Now, if I run this, you'll see that I get hello, BB. Because I was able to use keyword arguments, I tell it explicitly, hey, I want emoji to be this and name to be this. So positional arguments, these matter, but keyword arguments, it doesn't. Now, I argue that this is bad practice because you're making the code more complicated than it needs to be. If the definition of the function is to give name and emoji, you should follow that practice and not confuse other developers, then just stick to that name and emoji. So you can still use keyword arguments, but make sure that they are in order, because why wouldn't you just follow what the function tells you? It's the same result, but at least this way you are following, well, the standard flow. And by the way, these keyword arguments can sometimes be confused with what we call default parameters. I know it can get really, really confusing, but this is something that will come naturally to you after you practice a little bit. So I'm going to just comment this out and show you how default parameters work. Default parameters allow us to give right in here, as we're defining the function, what we want as default. In our case, let's say Darth Vader is the default name, and the emoji will be this little angry Darth Vader. Well, it doesn't really look like Darth Vader, but this is the emoji that we're going to use. So what does this do? Well, if I run my program, everything works the same. If I do keyword arguments and run my program, nothing changes. Let's make this a little bit bigger. However, default parameters allow us to do something interesting. For example, if I run another function, say hello, but I forget to give it parameters or arguments in our case, well, if I run this, I get hello, Darth Vader. Because with default parameters, it says if you're not able to get name and emoji because you were called without any arguments, well, in that case, make default Darth Vader and make default emoji this little emoji. If I use, let's say, just one argument and I click run, then, well, it will fill that name variable, but anything that we don't give it, like emoji, will be predefined. So this is a great way to make sure that your function runs even if it's called the wrong way. So keyword arguments increases the readability of your code because you know exactly how we're calling say hello. And default parameters allow us to keep our functions a little bit more safe because we make sure that when we use a variable, we're going to have it no matter what, regardless of how it is being called. But positional arguments are also useful because it's nice and clean, right? We're just following what the function tells us to do, and it's easy to read. So there's pros and cons of using each, but I hope this demonstrates to you some of the ways that you can define functions and also call functions. I'll see you in the next one. Bye-bye. Welcome back. In this video, I want to talk about an important concept, which is return. It's a keyword in Python that we are going to see a lot when working with functions. So let's have a look. If I, let's say, want to create a function called sum, which, by the way, already exists in Python, but we're going to create our own. And I'm going to say num1 for number 1 and num2. Well, our sum function is going to add num1 plus num2. Nice and simple function. Now, if I run sum with number 4 and 5, guess what's about to happen? I'm going to hit run, and nothing happens, which, I mean, might not be surprising to you because we're not printing anything, right? But what if I run print here? Will this change? Let's see. I get none. Is that what you expected? And we've seen none before, right? I mean, remember when we had a list, let's say 1, 2, 3, and then we did something like clear on it? In our editor, it gave us this little arrow and said none. And we talked about this idea of on lists, something like clear changes the actual list and clears everything and empties the list, but it doesn't return a new list. It just modifies the existing list, but instead just returns none to us. Well, functions are just like that. They always have to return something. And when they don't return anything, like there's no return keyword here, it automatically returns none. So if we don't have something like return here, it's always going to return nothing. But if we add return, it's going to say, as soon as we get to line 2, hey, I want you to exit this function. And when you exit this function, I want you to return whatever this expression gives us. If I click run, I get 9. If we change this to 10 plus 5, we get 15. And this is a good general rule with functions because functions can do two things, right? One, it can return something. So at the end of the function, whatever after the function gets run, we return something, either none or some sort of a value, some sort of a data type. Or we can have a function that doesn't return anything, but perhaps modifies something. So for example, I could print hi, and if I hit run here, I return none because I don't have that return statement. However, my function does something. It modifies, well, the look of this text, right? It prints hi for us. So a function either modifies something in our program or returns something. And this is a topic that is quite advanced that we'll get into later on when we talk about functional programming. But a good rule of thumb with functions is this. A function should do one thing really well, and usually a function should return something. Now, this doesn't mean that any function that maybe does multiple things or any function that doesn't return something is bad. But it's generally good practice to make your code simple and readable to have these two rules. For example, here, if I have print and addition, well, this function is doing multiple things. It's worrying about printing and it's also worrying about summing. And the definition, this function, is called sum. I mean, if I didn't know or I didn't see this and all I did was run sum, I think having printing high would be surprising because the name doesn't really describe what it does. I mean, I'm expecting this to be summed. Why is my program saying high? So we want to make sure that our function does one thing and one thing only really well. Because as we'll see later on, we can combine and run different functions together. And then also, we want to make sure that we return something. Because this way, what we can do is we can actually assign this return value to a variable. For example, I can say total equals to sum 10, 5. And because this function returns something and when it's done running is going to have 15 as a value, that's the same thing as what we're doing here. And here's the cool part. Now I can run maybe sum 10 plus total. Now let's go through this one by one. I define my function. The Python interpreter is going to say, all right, I know what sum is now. You've defined it. I'm going to keep it in memory. It's going to keep going until line 7. And it's going to say, hey, I want a variable total. And I want that total variable to equal sum 10, 5. And before we even assign anything to total, Python interpreter is going to say, sum. What's sum again? Oh, I remember. Here, it's in memory. Okay, at sum, I'm going to give it arguments 10 and 5. So it's going to go run that function as soon as we end this closing bracket. It's going to go into the sum. It's going to say, hey, num1 is going to equal 10. Hey, num2 is going to equal 5. Now we go to line 2, and it's going to say, hey, I want you to add 10 plus 5 because I know what these variables are. And then once you're done with that, and this turns into 15, I want you to return. So the Python interpreter, finally, when it's done calling sum, is going to say, hey, assign the value of 15 to the variable total. And then it's going to go to the next line. Hey, I want to print something. What do you want to print? Well, I want to print this. It's going to say, hey, what's sum? I know what sum is. I have it in memory. And then again, it's going to say 10. And then the next argument is going to be total. Hey, what's total? Let me go in memory and find out. Oh, it's 15. So it's like saying 15. And this is the power of functions, right? I'm able to return things and assign them to variables and call them like this. And I can keep running them if I wanted to. If I want to make this even simpler, I can go sum instead of total will be right here. And look at that. Now I have it all in one line. And if I click run, again, it still works. Okay, but what if we do something like this? What if I say define sum, and then I'll say define inside of here another function. And this function takes num1 and num2. And in here, we finally return num1 and num2. Let's test this out. What do you think will happen? Well, first, let's say total equals sum 10 plus 20. And then I'm going to print total. If I click run, I get none. Now, why is that? And this should be obvious to you, because here I'm saying, hey, I want you to define sum. And what are we going to do with the function sum? Well, inside of here, I'm going to define another function. But this return statement is actually not run, right? Because all we're doing inside of this block, this code block, is this part. We're defining the function, but we're never calling another function. So this returns none. And we've lost the ability to call this function. So how can we solve this? One way is to return, right? So at the end here, we have to make sure that the indentation is right. And we're going to return another func. So let's add return and see what happens here. If I click run, all right, I get this function now. So total is going to equal this function that we returned. And it's in memory. Okay, but I'm not getting the result that I want, right? And why is that? Because, well, we're not calling this function. So there's a few ways that we can do this. We can either give it the parameters or the arguments in here. So let's say 10, 20, and if I click run, I get 30. Or if we want to keep whatever we give it here, I can just simply say another func. So if we give it num1 and num2, and I click run, hey, look at that, I get 30. Now, this video you might have to watch over and over because it does stretch your mind a little bit. And to be honest, this function is not very good because it's very confusing. Your function should be easy to understand. So we might want to change this up a bit. Maybe instead over here of having the same parameter names, just to clarify it, maybe we can say n1 and n2. And then here we do n1 plus n2 to clarify that when we return this other function, I'm using the parameters num1 and num2 that we called here. Because this definition of a function doesn't really care what these things are. It only cares when another function gets called. Now, if you need to pause the video and look at this and maybe practice this a little bit, that's completely understandable. But I wanted to show you the power of return. You can have nested functions, just like you could with conditionals. But you have to be careful that your function either returns something, otherwise it's going to return none. And most of the time, you're going to want to return something from a function. So we can do something like this where we assign it to a variable so we can use it later on in our programs. I'll see you in the next one. Bye-bye. One last thing. A return keyword automatically exits the function. So that in here, if I added another piece of code like print hello, or maybe even have return 5 in here, you see that it's still valid. But if I run this, I still get 30 because the interpreter never gets to line 5 and 6. Because as soon as we return something from a function, it exits that function. And the reason that this part doesn't exit the function is because, remember, inside of this function, we're defining. So we're not actually running this part. We're just saying, hey, when we see another function coming up in our code, we know what it is. But we're not going to run it. So it's going to look like this. And as soon as it sees the return statement, when it gets called, it's going to say, all right, I'm exiting out of this function with this value. Just a little heads up. Hey, long time no see. It's been a while, but I'm glad you're back, and I'm glad you're still hanging in there. Trust me, things are going to get a lot more fun once we actually start building applications, but we do have to go through the basics, so hang in there. Now, You may have heard me mention methods and functions before. And I briefly touched on the subject, right? We have functions like list, print. We have things like max, min. What else do we have? We have input. These are all built-in functions in Python. Python just comes with this and we're able to use them. And we also learned about functions that we can create ourselves. Custom functions like, well, some random stuff. And I just created a function that does absolutely nothing. I can just pass through. And these are all functions because the way we call them is, well, we say some random stuff, and then we call it with the brackets and give it some sort of data or leave it empty. But we also learned about methods. And methods were different because the way we used them was using the dot notation. We said dot something. For example, if we had a string, hello, and I do dot, I get a list of all these methods that the string data type can use. These aren't things that we can use like this, because if I do capitalize like this, well, it's going to give me an error. It's going to say, well, I'm going to get an error with max because it's expecting an argument here, but let's comment this out and click run again. I get name capitalize is not defined because it's not a function. It's a method. And a method has to be owned by something. And who owns a method? Well, whatever is to the left of the dot. In our case, the string owns the method capitalize. And that's what methods are. They're built-in objects that have methods such as strings, dictionaries, sets, tuples, all the things we've talked about, where as soon as we do dot, we have access to all these methods. They're owned by an object or a data type. And the fun thing is that there's ways to build your own methods. And I'll show you how to do that later on when we start talking about classes. But you can see here that our editors help us determine what type of methods that we can use. And again, these are built into Python. And you can also learn about these methods that we can use by going to the Python documentation, right? Python 3 documentation is going to have a ton of things for us. If we go to library reference, for example, we can see here that we can learn about built-in types. So let's go to the set types. And here you can see that we have set type and it shows us how we can use it. Now, Python doesn't have the easiest documentation to read for beginners, unfortunately. So sometimes it's better to actually just Google instead of going through the actual documentation. But you see here that the set type has clear, has pop, has remove if we want to use it. We have update, and these are the methods that we can use. But at the end of the day, both methods and functions allow us to take actions, right? To take actions on our data types, to have our programs do something. And although they have these different names and one has a dot in front of it and another one, well, we can just call it like this, the difference is very minimal. But keep that in mind when you hear people talking about methods and functions. There is that difference. And like I said before, we will get to methods when we talk about classes to show you how we can create our own. I'll see you in the next one. Bye-bye. There is a unique thing that we can do with functions that we haven't seen before, and they're called doc strings. Let me show you what I mean. If I had a function here, and we'll just call it test, and test, let's say, receives a parameter that is a, and in here it's going to print a. What a useless, completely useless function. Now, if I run this, well, nothing's going to happen because I have to call test and then say, well, exclamation marks. And you see that our function works. But we can actually, with functions in Python, use something called doc strings. And it looks something like this. You do single quote, single quote, single quote, so 3 of them, and then at the bottom, once again, single quote, single quote, single quote. So at the beginning of the function, like this, and in here, I can add some info about the function. For example, this function tests and prints param a. Now here's the interesting part. If I run test here and I do brackets, look at that. My editor tells me info. This function tests and prints param a. This is called a doc string. And what it allows us to do is to actually comment inside of our functions in a way that if another person, let's say, is using the test function, they can actually, let's say in the future, when we write large applications where it's not just 10 lines of code, or maybe we have different files, instead of just finding what test does, as I'm typing it, it's going to tell me, hey, test is going to return or print param a. So I find out information about this. And if we ever use something like length, for example, and run this, you see that this gives us information about the function by using doc strings, but it comes built in with Python. Another way to view this, mind you, when we talk about developer environments, our editors are going to do this automatically. But there's a few other ways that we can actually read this. For example, I can do the help function, which we haven't seen before, which comes pre-built with Python. And we don't want to call the function. I just want to call help on test. If I run this, look at that. I get test A info. This function tests and prints param A. So we can use help to find out what a function does, which is really, really useful. One other way to do this is to use what we call a magic method or a dunder method, which again, we'll get into later on in the course. I do double underscore, then I do doc, and then double underscore, like this. If I click run, well, we have to print something here. So let's print, click run, and look at that, I get the same thing. So these doc strings are really, really useful to add comments and definitions to your functions so that when other people on your, let's say, team or coworkers come across your function that you created, they're able to understand what it does right away without searching through your Python files or multiple files. Very useful feature. I want to talk quickly about the idea of clean code, something that we've talked about before. And this is a good example to do with something like a function. For example, let's say we had a function that perhaps checks if a number is even or odd. So let's say is odd or even as a function that takes in a number. And we're going to here say, well, how are we going to check? Well, we can use the modulo operator. I can say if number modulo 2, which remember gives us the remainder. And if it's an even number, the remainder is always going to be 0. So this is going to tell us if it's an even number. So if it's an even number, then I want you to return true. And if it's not an even number, so let's say num2 doesn't equal 0. So if this is an odd number, there's always a remainder. In that case, we return false. So maybe let's change this function to be more descriptive, is even. So it's going to return true if it's even, false if it's not even. So in here, if I do is even and give it 50, and I run, oh, I get an error because I have to make sure that I do an if statement here. We have to print here, so let's do print and click run. I get true. If I do 51 and click run, I get false. All right, it seems to be working, but how can we clean up this code? Well, here's the thing. We have some ways that we can actually make this a little bit tighter. For example, if we're only checking for is even, we don't really need to check this again, because if number modulo 2 doesn't equal 0, that is, if a number divided by 2 doesn't always have a remainder of 0, we always know that it's not going to be even. So we don't even need this statement. We can just say else, right? So that if I run this still works. So, all right, so we cleaned up our code a little bit. But here's the thing. Another thing we could do is we know that return exits the function automatically. So we don't even need the else statement. I can just say return here, because it's only going to get to line 5 if this statement is not correct. So if it's not even, well, I'm going to skip line 4 and go to line 5. So that if I run this still works. All right, but we can make this even cleaner, right? Because right now we're just returning true or false. And usually if you have something like this where we're returning true, false directly, there's usually a better way. And that's using an expression that evaluates to a Boolean. What we can actually do is simply say, hey, remove all of this. And I want you to just return like this. And if we run this still works. And if I do 50, this still works. Because what we're saying here is I want you to return whatever this value is. And this is an expression, right? That's going to evaluate true, false directly. So we get the exact same result as we had before, but look how much cleaner that is. That is just nice, simple code. And as a developer, I can come in here and right away see that, all right, is even is just performing this operation and returning true or false. So this is a good way to think about clean code. How can you clean up your code? And mind you, there's no perfect solution. You can always clean up code. But thinking like this really allows you to develop the way that advanced programmers think. I'll see you in the next one. Bye-bye. Let's talk about something called arguments and keyword arguments. I mean, we've already seen that before, right? With a function, we actually have the special characters that we can use called args and ** keyword args. How can we use these? Well, let's have a look. Let's try and have a function, let's say define, and we'll call this a superfunc for superfunction that receives some sort of arguments. And these arguments that we're going to receive, and remember, although I'm calling these args, this itself is a parameter, remember? But let's say that we want to just return some of the arguments. And you might be wondering, wait, sum, don't we have to define that function? Well, sum actually exists in Python, as you can see over here. So we can just return the sum of the arguments. So let's try this. Let's say superfunc and give it arguments 1, 2, 3, 4, 5. If I click run, I get an error. Superfunc takes 1 positional argument, but 5 were given. And that makes sense, right? Like, I only have 1 parameter here, which is a positional argument that it accepts, and I'm trying to sum this. So it only receives 1, but I'm giving it all these things that it doesn't know about. And this is where we can use something like this. By adding a star to here, we're saying, hey, this can accept any number of positional arguments like this, as many as I want. As a matter of fact, let's print this out. If I do print star args, and we run this function, we see that the print star args gives us 1, 2, 3, 4, 5. These are all the parameters or the arguments that we get. And if I actually remove the star here and click run, look at that. I actually get this as a tuple. So args inside of this function is a tuple of arguments that I give it. 1, 2, 3, 4, 5. So sum of the tuple 1, 2, 3, 4, 5 is going to give us the right answer. It's going to print for us the answer 15. Very, very cool. So this way we can extend and use our star args to have a function that can accept any number of arguments. So what is this one now? Well, this one allows us to use keyword arguments. For example, let's say I have the star star keyword args like this. And by the way, this can technically be anything. So this is a variable that we're creating. So I can name it whoo if I wanted to. But the standard is to name it args and keyword args because other developers are using it this way, and it's just the way it's done in the Python community. Now with the keyword args, as you might have guessed, I can add keywords like num1 equals 5, and then num2 equals 10. So that if I print the keyword args and I click run, I get a dictionary of num1 equals to 5 and num2 equals to 10. So I can actually do something like sum plus sum of items in the keyword args and grab the values, right? We've seen that before. And let's actually grab this and do a for loop and say items in keyword args dot values. Remember to grab the values over here. And in here, just add up the totals. So let's say that in here, total equals or plus equals items. And we'll add a total in here that is initially 0. So that sum will be sum args plus total. If I run this, I get 30, which looks about right. Now, this does look a little confusing, so let's go over it. We have the star args, which allow us to grab these positional arguments and just sum everything. And we also have keyword args, which allow us to grab any number of keyword arguments and get a dictionary, which comes as keyword args, and then use them however we want. In our case, we're looping over all the values, so items in keyword arg values, and then I'm just going to total all those items, have a total, and just return the sum. Now this is, again, extremely useful because our superfunc can now take as many arguments, as many positional and keyword arguments as we want. Now, one final thing. There is a rule of the ordering that we can do of our parameters here, right? So the order, the rule is this. First, in our parameters, we have, well, our actual params. Then we can do star args, then default parameters, then star star keyword args. Let me show you what I mean. If we want to define this function, we want to make sure that if we give it a parameter of, let's say, name, that should come before star args. And if we have default parameters, that should usually come after args, but before keyword args. So if I do, let's say, I equals hi, and make sure we add a comma here, we now have, following the rule, and by the way, you would never actually write a function like this because, well, frankly, it looks super confusing. Usually your only using 2 of these, or maybe just 1 of these. But this way, I can call this function with name, Andy, then my args, then my default parameter, which will be I equals to hi, which let's say we don't even pass in. And then we have this. So if we run here, this still works. We are just not using name and I, but you see that I'm following the rule of params, args, default parameters, and then keyword args. All right, hopefully your head doesn't hurt too much after this one. Take a break, and I'll see you in the next one. Bye-bye. All right, it's exercise time. Let's combine everything that we've learned into this challenge. What I want you to do is to create a function called highest even, and this function is going to take a list data type. And this function, for now, will just pass, but I want you to fill in this part with whatever you think is going to allow us to achieve this. If I do print highest even, and I give it a list of, let's say, 1, 2, 3, 4, 8, I want the highest even to be printed in this list. And actually, let's do 10 here. So the highest even number in this list is 10. Just for fun, let's add 11 as well. So the answer should be printed here as 10. So based on everything you've learned so far, try to fill this part so that you create your own function, highest even. Pause the video here, give it a try. Otherwise, I'm going to go with the answer. So what I want to do here, let's think about this, is I want to make sure that first of all, we only consider the numbers that are even in here. So maybe what I'll do is create a new list called evens. And evens is going to be an empty list for now, but I'm going to populate this with all of the even numbers. So I'm going to remove 3 and 11 from this. So let's do that. I'm going to say for item in li, if item modulo 2 equals 0, which means it's going to be even, then I'm going to even append the item. So I'm going to add it to this new list. And then finally, in here, once we have the evens list, I want to find the highest number. Now, you can do this manually and go through it one by one, or Python comes with a nice function called max. And as you can see, we give it an iterable, and it'll tell us what the max number is. In our case, we can just give it evens. And remember, we want to return something from this function. That is, what is the highest number? Well, we want to return whatever the max of the evens is. If I run this, I get 10. Awesome. Looks like it's working. Now, some of you may have gotten tricked and tried to return inside of the for loop. But if we do this, remember that this still works, but we actually return from the function when we hit our first item. If we had another item, let's say 2 in here, and I click run, we get 2. And why is that? Because I'm returning when we loop the first time through our item, which will be 2. Is 2 an even number? Yes, it is. So we're going to append. And then we're finally returning max evens, which only contains the item 2. So you want to make sure here that the indentation really matters. And if you're returning something from inside a loop, you want to make sure that that's your intended behavior. You usually want to loop through something and then return. So make sure you don't prematurely exit the loop. Nice and simple. Remember, your answer may be different than mine. There are many ways to go about this. But hopefully, by practicing this, you have a better idea of functions. We now have a great utility function, highest even, that we can use all over our program. Good job getting this far, and I'll see you in the next one. Bye-bye. Welcome back. Let's talk about the walrus operator. And this one is a fun one because, well, it looks like a walrus. It looks like this. See? Looks like, well, Google walrus. If you don't know what that is, it's an animal and it kind of looks like that. Just Google this. All right, we're getting distracted. So what is this new operator we're going to learn about? The reason I want to teach you this is because I also want to teach you how to learn about new features in Python. For example, this is a new feature. If I go to the Python documentation here, usually what Python does with each new version, they create a what's new in Python document. So you might see what's new in Python 3.9, what's new in Python 3.10. And it gives you a summary of some of the new features added to the language because remember, a language is constantly evolving. So let's say you want to learn about new 3.8 features because let's say the REPL you're on now has 3.8. So it's able to understand the new features like the walrus operator that we weren't able to write before this version. So I would go into the documents and see what's new in Python 3.8. And we see one of the first things is the assignment expression called the walrus operator. So what I would usually do is just read about the summary of what this does, and you can learn about all the new features added in this version. Now let's just focus on the walrus operator because it is useful and also kind of fun to learn about. What this new syntax does is it assigns value to variables as part of a larger expression. So usually you use it in an expression when something is being evaluated, like in an if statement, maybe a while statement. So let's play around with this and see what we can do. So let's say we have a string and we'll call this string hello. Now in here, let's say I want to do a conditional statement. I'm going to say if length of A is greater than 10, I want you to print a string that simply says too long, and we'll say length A elements. Oh, make sure I do that properly. Now if I click run here, I get too long 14 elements. And why is that? Well, because each character here, we have 14 elements because it's greater than 10. This conditional block runs and we print out too long. We have length of 14 elements. So where does the walrus operator come in? Well, we're writing code and we're repeating ourselves here because we're calculating a length twice. We're using this A variable and doing some sort of a calculation multiple times because we want to use it here and here. But with the walrus operator, I can do exactly that. Remember, if I go to the documentation, it says assigns values to variables as part of a larger expression. So what I can do here is I can create another variable like n, and that says, well, walrus operator. So colon and equals, little walrus there. And this n is going to equal length A. So I'm just going to wrap this in brackets. So we're evaluating this part of the expression, and we're assigning the variable n whatever the outcome of length A is. So now n is something that has the value of A. So I can replace this with n. And if I run this now, again, same thing. So again, what we can do is we can assign values to variables as part of a larger expression. For example, if I did n equals length A, well, this isn't going to run. It's invalid syntax, but because of the walrus operator, we can do this now. Let's do one more just to make sure we have it. So let's say in here, we're going to do a while loop. while loop is going to say n, walrus operator, length a. Again, we're going to do the same thing. If it's less than, this time let's do 1. And while this is true, I want to print the value of n, and we're going to reassign the value of a, the variable a, to have one less letter. So I can just do that with the -1 short form here. So we're going to remove the last letter every time we loop through here so that the a variable, the hello, becomes smaller and smaller and smaller until it equals to 1. And once it equals to 1, the while loop is going to stop. So let's just run this. All right, we're getting true, true, true. And we made a bit of an error here because remember the parentheses. We want to evaluate this first. So if I run this again, 14, 13, 12, 11, 10, this is the length of a that's being calculated every time. And at the very end, if I print a and run it, you see that we have h remaining. There you have it, the walrus operator. You might not see it very often. It's essentially a way for us to minimize doing calculations that are similar, let's say inside of an if statement or a while statement where we want to do something based on a condition and then calculate that value again. But this also hopefully teaches you how to look at new Python versions and learn about new features. There's only a handful of features that get added to the language. Most of the important ones have already been added, but it's also good to keep an eye out on things as the language evolves, so that whenever you see something like a walrus operator in the codebase, you now understand what it does and that it's part of the language. I'll see you in the next one. Bye-bye. In order to finalize our understanding of functions, we have to talk about scope, another one of our key terms. What is scope? Let's have a look. Scope is something present in a lot of programming languages. And scope simply means what variables do I have access to? That's it. So what do I mean by that? Well, we've seen this before, right? Where I do print and then let's say name. If I click run, I'll get an error, a name error. Name is not defined because, well, it doesn't exist, right? And up to this point, we haven't really discussed this, but this is because of scope. What variables do I have access to? The Python interpreter says, hey, what do I have access to? And when we use something that it doesn't understand or it doesn't have access to, it's going to throw a name error or variable is not defined error. And scope in Python has what we call functional scope or function scope. What does that mean? Well, up until now, when we create a variable like total equals to 100, this is part of what we call global scope. That means anybody on this file has access to this total variable. I can use this inside of a conditional block. I can use it inside of a function. It has global scope. But when I say Python has function scope, what I mean is that when we create a function, and let's say we create total as sum, or let's say sum func, and we create total inside of the function, if I print total here and I click run, I get the same thing. Name total is not defined. This is because of Python's function scope. Anytime we create a variable, if it's not inside of a function, then it is part of the global scope. We have access to it. But you see over here, we get that red underline, undefined name total. If, let's say, for example, I had a condition, if true, then x equals to 10. If I do this and I say x and I click run, I have 10. Because, well, although I have indentation, the only time I create a new scope, you can think of this as a new universe that we spawn. Well, we can only do that when we define a function like this. So think of scope as a new world that we create. In our case, when we create a function, we create a new world, that anything that's indented inside of the function is its own world that we don't really have access to. We can only use total if we indent print and it's part of this world. That's what scope is. Who has access to who? So let's take a break here, and I want to play a little game in the next video where we try and figure out who has access to who. I'll see you in that one. Bye-bye. All right, let's play a little game. Can you guess what the output of this program is going to be? I have over here a equals 1. Then we create a function called confusion, where we have a equals to 5, and we return a. My question is, when we print a, and when we print confusion, what do you expect to happen here? Take a second to figure out, pause if you need to, and let's find out. 1 and 5. Is that what you expected? Let's go line by line. First, we assign value of 1 to variable a. We then create a function called confusion, and Python interpreter is going to say, all right, confusion function, I know what it is. I'm going to put it in memory. When you need to use me, just let me know. And then it's going to go to line 8. And line 8 is going to say, hey, print a. What's a? Well, the only time that I've seen a is right here, a equals 1. So go into memory, what's a? A equals 1. But then when I run confusion like this, I'm going to say, hey, a is going to equal to 5. And now we return a, which is 5. Okay, what if I change the order of this? What if I go like this? What will happen? If I click run, is that what you expected? Once again, we have a equals 1, then we define the function, and then we print confusion. Now, confusion here is going to assign a equal to 5, and then return a. But why didn't this change? Why is a still equal to 1 by the time we get here? And this is because of scope, right? What the Python interpreter does is when it runs the confusion function, it's going to say, hey, a is going to equal to 5, but I'm creating a variable here called a in my own universe. I don't know anything about a equals 1 here. I have my own universe. And after we run this function, then, well, we're done. We've returned the function and it's completely gone. But we never left the universe into the global scope. So there's a set of rules that the Python interpreter goes through to check a variable. And the rules are this. First, it's going to check with the local. So start with local. And what we call is a local scope. A local scope is a scope that's part of this local function. So a is a local scope. It's going to check there. Hey, do I know the variable a? Well, yeah. When I return a, I have a variable defined here. So it starts there. But let's say a wasn't there. Let's say I remove a and I click run here. I get both ones because the second rule is if there's nothing in the local variable or local scope, then number 2, is there a parent local scope? In our case, what's the parent of this function? Well, it's the global scope. But we can also do another function. Let's say parent. And parent is a parent of the confusion function. And in here, let's say a equals to 10. Now in here, we'll return confusion just so we can use it again and actually run it. So let's call parent and click run. All right, let's go through this so it's not too confusing. We have the parent function that gets called. So when we call that, we assign a equals to 10, and then we also create a new function confusion. And then finally, we return confusion and actually run it. So we're going to return a, and then in here, print whatever the value of a is, which is 10. And why is that? Well, because we first start with the local scope. Hey, does confusion know what a is? Nope, I don't have it in my local scope. Okay, does my parent local scope have it? So it's going to go up a level and say, hey, does parent function know what a is? Yep, I have a equals to 10. So it's going to print that. The third rule, or the third order, is global. And global is what we call the indentation of nothing. It's this file, right? Whatever the file has, that is global. In our case, if a equals to 10 doesn't exist here, there's no local, there's no parent local, and I click run, it checks the global scope. And then finally, there's one other rule. And this is number 4, and it's a tricky one. And this is what we call built-in Python, or built-in Python functions. So Python comes with predefined functions, such as, well, the sum that we've talked about before. This sum, let's say just give it 5, is going to check, or actually, let's not give it anything. Let's just do sum here. When I run this, I get built-in function sum. Now, how did it know what this was? What this variable at the end of the day was? Well, because it said, hey, do I have sum inside of this universe? Nope, I don't. Okay, do I have sum in my parent scope? Nope, I don't. Okay, do I have sum in global? Nope, there's nothing sum in here. And then the final thing it's going to check is, hey, is sum some sort of a built-in Python function? Yep, Python actually gives us sum, so you can use it, so it doesn't error out. And this is the scope rules that the Python interpreter follows. Very, very cool. There's still a few more things that we need to learn, so I'll see you in the next video. Welcome back. Let's try and answer some questions that you may have. For example, what about parameters? If I do parameter, let's say b here, what is this parameter when I use b like this? So let's say print b, and in here I'll run confusion with, let's say, the number 300. If I run this, this works. And that is because b, the parameter, is part of the local scope. That is, it's part of this. So parameters are considered local variables. We're able to use it inside of the function, but we can't use it outside of those functions. Technically, when we define the function, we let the interpreter know, hey, b is going to be a local variable. Okay, what about this? What if we have this, a, but I want to make sure inside of my function that I'm actually referring to the global a. Is there a way for us to just use this value without creating a new variable? Well, let's use a better example for this. Let's say I wanted to create a counter. So we'll have total equals to 0. And then in here, I'm going to say define count. And this function is going to say total plus equals 1. So we're going to add every single time. When we add count, it's going to increment 0 by 1, and then 1 by 1, so on and so forth. So we're going to return total at the end of this. Okay, so if I run here print count, let's see what happens. I'm going to hit run, and I get an error. Local variable total referenced before assignment. And that is because, well, count doesn't know about total. You're trying to use total, but we haven't assigned anything yet. But we want the total from the outside world to run. Because if I just do total equals 0 here, and I run count, that's great, I get 1. But what if I wanted to run count multiple times? What if I wanted to run count, let's say 3 times, so that the count total will be 3? So let's do print on the last one here. And I click run. I still get 1. Because every time we run the function, we reset the total to 0. That's not very useful, is it? So one way that we can fix this is using what we call the global keyword in Python. And global says use the global total, if it exists, in here. So that instead of having to create a new variable, I can use the global variable total. Check this out. Well, I get an invalid syntax, and that is because we first have to say global total is going to be used in here, and then we can say total plus equals 1. If I run this, hey, look at that. We have a proper counter. So global is a way for us to access this global variable. However, I argue that this is actually not a good way of doing things, because it can get really confusing when you start adding globals and all these different universes are accessing each other's variables. A better way of doing this is something called dependency injection. And this is a simplified version of it. But the idea is that instead of accessing variables outside of the function like this, which can get really, really complicated as files get bigger and bigger, is to do instead this. Total. Like this. We create a parameter, and then we pass in that parameter or argument in here. But as you can see, it's still 1 because by the time we print the third total, well, this never changes. This is a global 0. So instead, we can do something like this. We can say count total, of which we're going to count again, and then count again. If I run this, I get 3. And I know what you're thinking. This is completely insane. It looks confusing. Look at all these brackets. But let me show you what we've actually done. We're able to detach the dependency or the effect that this count function had on the outside global scope, and instead just focus on its health. All we needed to do was say, hey, I want you to give a count with total of 0, and then after that, this is going to evaluate to 1, and then we do count total of 1 plus 1 is going to equal to 2, and then count 2 plus 1 is going to equal to 3. In this way, we're able to still do our count without having to use that global keyword, which I would argue is nicer. Mind you, if this is your first time seeing this, it can get a little bit tricky. But at least this way, you know that there's different ways of doing things. One other word I want to show you is something called non-local. But for that one, let's take a break and I'll see you in the next video. Oh boy, there's some code on the screen and it looks terribly confusing. This is an example of a really convoluted, complicated function that you would never write, but it'll be good for exercise purposes. And we're talking specifically about this right here, called non-local. It's actually a new keyword in Python 3. And as you can see, my REPL doesn't even notice it, so it doesn't even highlight it in blue because it is a new feature. But I do want to talk to you about it and let you know what it does. The non-local keyword is used to refer to this part, this parent local. It's a way for us to say, hey, I want to use a variable that is not a global variable, but is outside of the scope of my function. So based on that definition, try and pause the video and see what this function might do. I'll run it right now and then go through the code. If I click run, this is what we get. So let's talk about this. We have an outer function, and then we call the outer function. So the Python interpreter is going to go and say, all right, we have an x variable that is local to the outer function. And then inside of here, we're going to define an inner function, another function. And in here, before we even call that, we jump to line 9 and say, all right, call inner function. We come back and we say, hey, line 5, I want to use non-local x. What does that mean? Well, I want to use this x variable because it's non-local. That is, I don't want to create a new x variable. I want to jump up the scope to my parent scope, my parent local, and grab whatever you find in there. As long as it's not global variable, any parent will do. I want to grab that non-local. So now this x is referring to the outer function here. So when we say x equals non-local, we're assigning this new string and replacing this local so that when we print inner x, we get non-local. But also when we print the outer x, we've modified this outer scope with the non-local keyword, so that becomes non-local as well. If I remove this line and let's comment it out, and I click run, you see the difference now. We have the inner non-local, but then the outer local hasn't been modified because this is a new variable. Again, I argue that this actually makes your code more complicated than it needs to be. So there are special cases where you might want to use this, but if you can, try to make your code predictable where you can avoid using things like non-local and global. Mind you, they are there for a reason because they are useful in some situation. With that said, keep in mind, make your code predictable, make your code clean, and I'll see you in the next video. I want to address a question that you may or may not have, but it's something that's taken me years to understand. And that is, why not just have everything as global variables? I mean, all this confusion of who has access to who. How easy would it be if everything was just on the main page, all our information, all the data on our global scope so that everything has access to everything? Wouldn't that be easier? And you'd be kind of right. I mean, that would make all this headache go away, right? But you have to remember that machines don't have infinite power, don't have infinite CPU, don't have infinite memory. They all have limited resources. And as programmers, we have to be conscious of what resources we use because sometimes that can cost us money, sometimes that can crash our computers. And scope is a great demonstration of this. For example, this code right here, when this function is run, we're creating technically just one location in memory for the x variable. So we have that bookshelf in our computer that is x, that's pointing to local when we actually call this function. And then when we say non-local here, well, we're saying just don't create another bookshelf for us, just use the one that we already have and assign it non-local. If we didn't have this line, by the time we get to line 7, we've placed in memory x equals to local and x equals to non-local. So we have two locations now in memory. Now, this isn't a big deal because, well, in this day and age, we do have a lot of memory. But as programs get larger and larger, this does become a bit of a problem. Okay, but what about a function? I mean, we learned that functions allow us to not repeat ourselves and being able to call outer multiple times. But another good use of functions is that once we call this function and all of this is done, the computer and the Python interpreter specifically destroys all this memory. That is, once we finish with the outer function, I can't really call print x here. It's going to give me an error. It's going to say, I have no idea what x is. And why is that? It's because after we call this function, the Python, what we call the garbage collector, is going to say, hey, it looks like we're done with this function, and I see that this x variable, and this x variable, we're not going to use because we're done with this function. So I'm going to collect that garbage and then just throw it out. So I'm going to empty that memory cupboard so that other resources or other programs can use that. And that is a really nice feature where Python just automatically removes these for you so that you don't clog up the computer's memory. And that's why scope is useful. We don't have to think about it in such detail like I've mentioned it, but it's nice to know that it's there so that your programs don't hog up a lot of memory and they can run efficiently. This is a bit of an advanced topic, but I did want to include it in here so that you can think about why programs are designed the way they are. All right, I'm going to stop talking now. I'll see you in the next video. Bye-bye. It's happening. After all the suspense, all my talking, yes, we're finally going to download Python on our machines. Now, based on what device you're using, the installation may change, but I'll provide videos for each one of the operating systems. So I'm on a Mac right now, and if you're using a Mac or a Linux distribution, you might have Python already installed on your machine. What do I mean? Well, if you open something called your terminal, so if I'm on my Mac and do Command space and I type in terminal, press enter. Well, right over here, if I type in Python and press enter, you see that I enter something called a REPL or a read eval print loop, where I can type Python commands like print hello. And look at that. It's working. Just like we had our REPL browser or website, I can type Python here. And most Macs come pre-installed with Python. But you might notice something here. Yep, we're using Python version 2, 2.7 to be specific. Now, as we've talked about, that is an older version of Python. Ideally, we want to install Python 3. So we're going to go to python.org and install the latest version of Python, which is 3.7. By the time you watch this video, there might be a higher version, maybe 3.8, 3.9. Now, like I said, a language is always evolving. But what I'm going to teach you in this course is going to work for any future versions of Python. So it doesn't matter if the number's a little bit off. As long as you're installing Python version 3 or up, you should be all good to go. In our case, we're on a Mac, so we're going to just click install. And you can see over here that the package is being installed. I'm going to open it up and just simply run through the commands. Want to install, click through continue. Yes, I agree to the license. I definitely read all of that. Yes, let's agree. And we're going to just continue and install Python. If you want to add your password or your fingerprint, that works too. And you see that we're finally installing our Python interpreter. All right, there it is. We have Python 3.7 installed. Now, if everything worked as planned, if I go back to my terminal and I type Python, you'll see that you have Python version 3.7 or version 3 or higher. That's good. No more Python 2. Now, depending on your machine, again, this is why installations can get tricky. You might actually not have this work. For example, in order to exit out of here, we'll say exit and then curly brackets. You might have to type Python 3. And you'll see that you might have to specify exactly the version, because if you just do Python, it'll be version 2. Now, if you encounter any problems installing Python on your machine, I will provide resources that you can see attached to this video, or you can ask questions in our Discord channel or our Q&A forum. But it looks like we finally have our Python 3 installation on our computer. Remember, we just installed our interpreter and our virtual machine, our CPython VM, in order to write Python and then evaluate that Python code. Good job. Let's take a break, and I'll see you in the next video. Bye-bye. Welcome back. It's finally time to install Python, the Python interpreter that we've been talking about for so long. And if you're on Windows, this video is going to help you get set up. We're going to go to python.org, click on Downloads, and make sure that we're downloading for Windows. We're simply going to click, and I'm going to run the installer. All right. Now, this is really, really important. On Windows, you want to make sure that you click on Add Python to Path. What this is going to allow us to do is to actually open up Python and use Python from the command prompt. I'll show you that once we install this, how it works. But make sure you click on this. And also to install Launcher for all users, which is recommended. So I'm going to click Install Now. And yes, we'll say go ahead. Now you want to install based on your system. You might have an older version of Windows, a newer version. Usually the python.org website will detect your machine and know what to install, but obviously install according to what you have. In my case, it's a 32-bit system. All right, come on. All right. Setup was successful. Let's close. And then what I'm going to do is actually use the command prompt here. So I'm going to type into search command prompt. If I click here, and now if I type in Python, hey, check that out. We have Python working. Awesome. Now, on Windows, you can also use something called PowerShell. And PowerShell is actually, well, I prefer it over command prompt because the same commands that work on a Linux machine or a Mac will work on PowerShell. So again, if I do Python here and hit enter, look at that. Python is working as well. So if you have Windows and you have PowerShell available, I do recommend you use PowerShell because the commands that I use in the course will most likely work with PowerShell. Another option for Windows is something called git bash. So if I do git bash, so for git bash, if you go to git for Windows, you'll see here that it comes with git bash, which underneath the hood, what it is, it's an emulation, a bash emulation, which is a shell to allow us to use Unix commands that can be used in Mac or on Linux on the Windows machine. So that if you ever watch a tutorial where the instructor is using a Mac, for example, you can use those same commands. So to review, we have the option of using git bash if you want, or you have the option of using command prompt, or my personal favorite, PowerShell. So if you have PowerShell on your device, then I recommend using that, if not git bash. But because during our install, clicked on that checkbox that says, hey, add Python to our path variable, we're able to run this Python command and actually enter the Python REPL. Something that will become useful, and you'll see why it's useful as we go through the course. But for now, let's take a break, and I'll see you in the next video. Bye-bye. Welcome back. Remember this slide? I told you that we're going to wait until we set up our developer environment. And up until now, we've been using a browser to run our Python code. But we want to be professional developers. And professional developers use professional tools. In our case, these are the main ones in the Python community right now. We have the terminal or command prompt if you're on Windows. to run quick Python scripts. And we've seen this before. I can go into my terminal, type in Python or Python 3, make sure that we have that version. And then in here, I can just write any Python script that I want. I enter it and I just run these simple scripts and I can just exit like this. This is used for just quick testing, but most of the time you're not going to see professional programmers use this method very often. Instead, most of the time we use something like code editors or IDEs. Now, nothing's preventing me from writing Python code in, let's say, a Word document, a Google Docs, or a text file. But the problem with that is that, well, it just looks like text. And when you make a spelling error, when you write improper syntax where it's not Python code, if I just write it in a Word document, it's not going to tell me any information. A professional developer needs some extra tools that code editors and IDEs provide that help us be more efficient with our code. And we're going to be exploring that over the next couple of videos. But what is a code editor and an IDE, and what's the difference? We're actually going to show you how each of these work, but a simple rule is that code editors are lightweight. They give you some really nice features like auto-completion, linting, which we're going to talk about, while IDEs are full-fledged environments. That is, they provide a ton of extra stuff in order for us to just write really good code. Because of that, they tend to be bigger. You have to download a large file size, but they come with a lot of things like auto-completion, debugging, code formatting, unit testing, code snippets, so on and so forth, versus code editors where you have to just install bits and pieces and kind of create your own environment. But enough talk, let's actually install some of these, and don't worry, at the end, we'll also introduce you to this idea of a Jupyter notebook, which is one of my favorites. Let's install some developer tools. First one, and personally, this is my favorite code editor. It's Sublime Text. You can download based on whatever operating system you have. In my case, it's a Mac, so it's OS X. So I'll simply click on here and just open this up. And it's going to install Sublime Text for me. Now, Sublime Text has this model where it is free. But every time you save, maybe like every 20th time that you save, it'll have a prompt that says, hey, you should purchase Sublime Text. So if you really, really like it, it's good to contribute and actually buy it. And most of the time, the workplace that you work at will actually cover the cost. But you can also use it for free. You'll just get that annoying prompt every once in a while when you save saying, hey, buy. But you can still have all the features that you want with the free version. In my Mac, I'm going to drag it into applications. And, well, I already have Sublime Text actually installed. So I'm just going to say stop because, well, it's already installed. All right, so that's Sublime Text. And once we open it up, it'll look something like this. It's a code editor that allows me to write just like a Word document, but it has this ability to format my code and make my code look better when I'm actually coding. If I go down to the bottom here and click, you see that we have different languages that we can use. In my case, I want to use Python. So that now if I do print, look at that. I have some color completion. It gives me some hints. And let's say I make a mistake here. Well, there you go. I get some highlighting saying, hey, matching bracket could not be found. Make sure that you close this out. So immediately you can see the usefulness of this. It tells me as I'm coding along what errors I'm making. It makes the color pretty and generally is just a better experience to code. Now, with Sublime Text, this Python is actually version 2 of Python. So if I remove the brackets, it doesn't give me an error because Python 2, well, this is valid syntax. So in order to upgrade this to Python 3, we have to install a few packages. On a Mac, it's Command-Shift-P, and you'll get this drop-down menu. On Windows, it'll be Control-Shift-P. But you can also just do it this way by hitting Tools and just hitting Command Palette. And here we're going to say Install Packages. And for installing packages, we're going to say Python 3. And there's lots of packages that you can install to customize it, and there's tons of resources online of customizing your code editor. So everybody has their own preference. Now, if I click over here, I see that I now have Python 3. And if I click here, all right, everything is good. And now we can just save this file. We can call it hi.py on our desktop. And when we save this, sometimes this will switch over to Python. Now, this shouldn't matter too much. We could also do Tools, Command Palette, and just set syntax with Python 3. And another interesting thing we can do is if we go to the Command Palette once again, I can say build with Python 3. When I click that, look at that. It's going to run this file for me, and it's going to say, whoa, there's an issue on line 1. It says missing parentheses in call to print. Did you mean print hello? How nice is that? So we get to fix our errors. And now if we do Command Palette, or if you're on a Mac, you can do Command-Shift-P, as you can see here, or Control-Shift-P if you're on Windows. I can just say build with Python 3. And now look at that. Everything is running smoothly and it prints hello. Awesome. For now, we have a basic setup for Sublime Text. We can do a lot of things, and you can Google of how you might want to customize Sublime Text. Maybe you want to change some colors. So you go to color schemes and maybe, I don't know, let's change it to Mariana. And look at that. It looks pretty good. So lots of options here. This is one of my favorite code editors, but I recommend finding your own, testing different things out and finding what you like. Usually though, the tool, like a code editor, doesn't make the programmer. You just want to get comfortable with one of them, and from there, you'll just write good code. So don't spend too much time customizing it and making it perfect, because to me personally, that's just a waste of time. Your time is better spent learning to code, actually coding, instead of finding just the best color scheme to have on your code editor. A big part of being a developer is being able to use the terminal or the command line. Well, what is it? In this video, we're going to tackle this question and teach you a couple of very useful commands. Now, on a Mac, you simply do command space and type in terminal, press enter, and then the terminal will open for you. It's one of your applications and it's on every computer. If you're on a Windows machine, then it is the command prompt. But what is it? Well, it's how humans originally communicated with computers. Up until the 1980s, it was the main way humans gave instructions to computers and computers gave output to the humans. We didn't have something called the GUI, or the graphical user interface, such as me opening up a new folder and changing the name of this folder or opening up Google Chrome. I don't really need to know how this is done behind the scenes. I just click on an icon and it opens it up magically for me. But command lines are really useful because you can do the exact same thing that you do visually on a graphical user interface, like I have here, on the command line. But they tend to be much faster to do, as I'm going to show you in this video. And there are also common ways to access different computers around the world. Like if you needed to access a server in another country where your web app is hosted, well, you would use the command line. And I'll show you how to do that later on in the course. Now, in your day-to-day job, you'll be using the terminal a lot because you'll have to access servers, the database, your front-end application, but you can do all of that in one from the terminal. You can also download scripts that other people have written from the internet so you can use in your projects. Now, these are all things I'm going to show you in the later sections. The commands that I'm about to show you work on a Mac or a Linux. For Windows, I'll have the Windows version command at the bottom of the video as we progress. Most of them are the same, but there are a few differences. So let's get started. The first command I'm going to show you is the ls command. I simply type in and press enter, and it lists everything that is in my current directory. What is my current directory? Well, I do pwd for present working directory, and I see that I'm in the users. That's my username. So I'm in my username folder, and these are all the things available to me. If I do cd, then I can go into this. If I wanted to go to, let's say, desktop, I do cd desktop. And now, if I do ls, I see that I have untitled folder because that's the only thing on my desktop right now. I can also do cd ... and this brings me back to one directory up. I can also do clear to clear up my terminal and have a nice fresh slate. There's a short command cd/, and this takes me to the root directory. If I do ls, I see that I have applications, library, system, users. That's the root directory of my Mac, essentially my Macintosh HD. I can also do cd squiggly line, and this takes me to the user directory. Let's clear this again. And if we check where we are, all right, let's change this untitled folder to something like test. Okay, let's say I'm in the user directory right now. I wanted to access desktop and then the test folder. I would simply do cd desktop and then test. And now I'm in the test folder, but there's nothing in there. So one thing we can do is I can say open dot, and it opens the folder that we're currently in. Okay, we're in the test folder. Now, if I just put this to the side over here so you can see, I can say make directory, which is make a folder, name. So name here will be whatever I want the folder to be titled. Let's just say this folder would be called web app. Did you see that? Now web app shows up in my folder. Let's change the view here so you can see it better. There you go. If I do ls now, I see that we have the web app folder, and as we know, we can go into it. And let's double click here to see what we have. We have absolutely nothing. Well, we can create a file in here by saying touch and the name of the file. So let's just do index.html. There you go, index.html. Now, what if we wanted to open this index.html? Again, we just do open, and the dot means we open the folder we're currently in, which is here. But if I do open index.html, it opens the file for us. How cool is that? But index.html is pretty empty right now. Wouldn't it be nice if we can open Sublime Text from here and add something? Again, you can do that with open. You put in A, so line A for application, and the name of the application. So Sublime Text. Close the double quotes, press enter, and look at that. I have Sublime Text. But if we wanted to do application Sublime Text and open the index.html file, we just do this. And now I can say HTML, and we'll just say, hello world. Save that. And if I do open index.html, we have our index.html file loaded. Wasn't that a lot faster than right-clicking, creating a folder, then dragging everything to Sublime text, and as you can see, you can do things really, really fast here. Okay, let's change something. I'm going to close Google Chrome and Sublime. And in the web app, let's say I wanted to change the name of index.html to about.html. Well, I'll do the mv command, which stands for move, but it just moves the index.html file to about.html file. So it's a little trick. You're essentially just moving one file to another, but by changing the name, you create a new file and you replace it with the old one. So now I have about.html. Very cool. Now, these commands, typing them can get pretty tiring. I can press the up arrow and it goes through my entire history, which is very cool. I can also press the tab key and it will bring up my most recent command or completes what I'm about to write. So you can do it really, really fast. And when your commands get longer and longer, it's a very useful thing to do. Okay, I don't really need the about.html file anymore. Let's remove it. We do rm for remove and the name of the file, about.html. It's been removed. Perfect. Now, what about the web app file? We can remove that as well, but if I just do remove web app, well, it's not going to work. First of all, if I do ls or present working directory, I'm in the web app folder, so I need to move back to the test folder. Let's clear here, do cd. Now my present working directory is, I'm in the test, so I can remove web app by doing remove web app. But rm only works for files. To remove a directory, a folder, you need to do rm and then use the r option and then the folder name. In our case, it's the web app. There you go. It's gone. And with that, you know what? We can remove the test folder as well. We can go back to our desktop and then do remove our test. There you go. It's gone. And one last trick. On a Mac, you can do this.
This is so cool.
Right? Very, very cool. Okay, as you can see, you can have a lot of power with the terminal, and I want you to get used to writing commands on here. And from now on, try creating files and folders this way. Eventually, you'll get more and more comfortable with it, and things will be much faster than just using the GUI. In the developer environment section, I'll show you how you can change this boring black and white terminal to something like this. That's it for now.
See you in the next video. Bye-bye.
By the way, remember this exercise that we did where we pretended to have a picture that was stored on our computer and we had to create this script to read through our data and add a space or a blank if there's a 0, and if there's a 1 to add a star, which gave us a little Christmas tree. And although we've been using the REPL up until now, at the end of the day, all Python code, whether you're writing Python for games, whether you're writing Python for scripts to read your Excel spreadsheets, or maybe you're using Python to do some machine learning, at the end of the day, all we're doing is, well, we're writing a program, and then this program gets run by a machine. Something like this. Here I have a 1.py file that I've just created. And in here, as you can see, we have our script that we had in our REPL. But I've just created it on my computer. It's 1.py. I can name it whatever I want. And usually a way a program runs, again, any type of Python program, any type of programming language. We can use something like our terminal. If you're on a Mac, you can use the terminal. Or if you have a Linux-based machine, you can use the terminal as well. Or if you're on a Windows computer, using the command prompt or the PowerShell. So that here, If I wanted to run the one.py file, I make sure that my present working directory is where my file exists, which is on my desktop. Remember that on Windows, you'd say directory or dir to find out what your present working directory is. Once you're in the same directory, remember, if you're not, you can cd into different locations to get to where the file is. And then we run the file by saying Python, in our case 3, again, based on whatever interpreter you want to use, and just say 1.py. And there you go. Our graphical user interface of displaying a tree is working. And although this is a simple example, that's all code is. Code is being run by a machine like this. We just say, hey, run this Python file or multiple files through the Python interpreter. And the machine is going to do something. We created a Christmas tree generator, so that's what the machine does. But the machine can do anything. It can build games and run games. It can do machine learning models. It can do visuals. It can simply send emails to your friends. The possibilities are endless, and we'll explore those topics in our projects coming up in the course. Welcome back. The next code editor we're going to look at is a very, very popular one. It's completely free. So I think right now it's probably the most popular code editor out there in the community, and I think you'll see why. We can download it based on your machine, so you can pick whatever computer you have. In my case, we'll download it for Mac, and it has a really, really good Get Started guide. Again, all these tools have a lot of information online for them. So again, if you get stuck with downloads, there's always a way for you to figure out how to solve these. Now, keep in mind with code editors, it doesn't just mean these are for Python. Both Sublime Text and Visual Studio Code can write any sort of language, programming language that you want. Like myself, I usually like writing JavaScript as well. So I can go back and forth between different languages, but still use the same tools. So let's open up VS Code. We're going to install this. And again, on Windows, it'll be very similar. You'll go through an installer. In my case, I'll add it to my applications. In my case, it should appear somewhere around here. Click on that. And there you go. We have Visual Studio Code. There's a lot more going on than Sublime Text. It's why I actually prefer Sublime Text. There's just less things happening on the screen. But you can see over here that has some really nice features. For example, we can create a new file here, and we can just create, let's say, a Python file. So I'm going to Command S and save and just call it hello.py because we want to create a Python file. You'll see right away when I do that, it's going to tell me, hey, there's no Python interpreter selected. You need to select a Python interpreter. And luckily, we actually learned what that means, right? So let's select a Python interpreter and look at that. It tells me that I have a choice because we've downloaded version 3.7, but on my Mac, I also have the pre-installed 2.7. So luckily, Visual Studio Code tells me, hey, which one do you want to use? And I'm going to say, I want to use Python 3. There you go. And I get another hint. It says, hey, we also have a linter available for Python. Do you want to install that extension as well? We'll get to that in a bit. But for now, let's focus on this. If I do print hello, getting really creative with my code here, you see that, again, I have syntax highlighting. Everything looks good. If I miss a bracket, what happens? Do I get any errors? What if I just write some gibberish here? I'm not getting anything because, well, I don't have this pylint installed. But again, we'll get to linting in a bit. The cool thing about Visual Studio Code is that you also have the terminal right here. You can actually, if this isn't open for you, you can just click Terminal and just say New Terminal. Now in here, I'm going to close this for now. I can run my Python code And let's make sure it's just a print. I can say Python hello.py. If I click run, oh, I didn't save this, so make sure I save it so it's the new version. And run this again. Python hello.py. And look at that, it's all working. Now, up to this point, we have this print hello. We also know that we're running Python version 3.7. You can see here, if I click on here, I can select what interpreter I want to use. And it also gives us a few tips, such as, hey, linter pylint is not installed. So let's install pylint. Pylint is a linter. That is, it's almost as a spell checker for our code, letting us know, is this syntax right? And there are many versions of linters available for Python. Pylint just happens to be one of the most popular. And VS Code by default suggests Pylint, so let's install that. Once that's installed, you see over here that everything is going through. And now let's see if this works. So let's save this file. I'm going to say File, Save. And if I click on Problems here, there are no problems detected so far, but we know that the print should have brackets around it. So what we want to do here is go to View, Command Palette, and we see right away that it says Python enabled linting. If I type Python here, the Python installer that we had at the beginning when we installed VS Code installed a whole bunch of shortcuts and tools for us to use, such as enable linting. So let's click on that, and I'm going to say on. If I save, look at that. In my problems, it says missing parentheses in call to print. Did you mean print hello? I also get this little underline, and it tells me exactly what print does, but also telling me what errors I need to fix. And you see that it's a pylint syntax error. So again, I can just fix that, nice and easy. And now if I save, there's no problems. Everything is running fine. If I go to my terminal and do Python hello.py, look at that. Everything is working nicely. So this problems panel is really nice for your code to be told, hey, something's wrong. For example, if I miss a bracket here and I save, the problems is going to tell me, hey, there's something going on. There's a syntax error. And Pylint is helping me solve that issue. By the way, you might be asking yourself, how come my editor, VS Code, doesn't look like this? For example, if I go to extensions, I have the Dracula official theme enabled now, which is a color theme that I have for Visual Studio Code. And let's click on this over here and just say disable all installed extensions. You'll see that I just have a few extensions that allow my Visual Studio Code to be customized. But in your case, if you're just installing Visual Studio Code, it'll look something like this. But by installing the Python package with the Pylint, we now have a fully enabled IDE, in a sense, for us to write Python code. I'll see you in the next one. Bye-bye. Welcome back. Up until now, we've talked about Sublime Text and Visual Studio Code. Code editors that we had to install a bunch of plugins and extensions in order to customize it to what we want. And they work really well with a ton of different programming languages. The next one, though, is an IDE, and it's called PyCharm. And it's probably the most popular tool for Python developers. So I really, really like it. But it's an IDE. That is, unlike a code editor, it already comes pre-built with a lot of things. This company, JetBrains, makes it, and they focus purely on Python developers. So that is, if you're a Python developer, they really focus and make sure that all the tools you need to succeed are in here. Now, when you click on Download Now, you have two versions. The professional one, which you have to pay for, and the community one. So just download the community one. The professional one just comes with a few extra features that we don't really need. So download the community one. Just a heads up, it's a lot bigger. It's 315 megabytes. So again, it comes with a lot more tools for us to use. So it is a little bit heavier than Visual Studio Code or Sublime Text. But if you're a Python developer and you just want an environment where you can do everything in one place, PyCharm is the way to go. Now let's fast forward through this so that we're not waiting around for the download. Whew. All right. That was a long pause for me, but for you, with some editing, this should have been quick. All right. If I open this up now, again, if you're on Windows or if you're on Mac, installation process will be different. In our case, because we are on a Mac, I just drag this to application. With Windows, you'll probably go through an installer. All right, it's all installed. Now, if I double click, PyCharm is going to open up for me. And we'll just make sure we allow it. Now, in my case, I had already a previous version of PyCharm that I've been using. And you might want to import your previous setting. But in our case, we've never used PyCharm before. And also, most likely you want a fresh install. So even if you get this type of pop-up, you can just click on Do Not Import Settings so you get a fresh slate. We're going to click OK. And there we have it. And right away, you can see that, well, it gives us a lot of options. Let's just say I've never used PyCharm before. And next, we get to choose our UI. Do we want Dracula, which is dark, or do we want light? Let's go with dark for now. So I'm going to skip the remaining and set defaults. So in PyCharm now, we can create a new project. Now in here, it asks us where we want to create our project. In my case, we can just leave it over here. We'll call it my project. And before we click create, make sure that you click on this project interpreter and double check that our base interpreter is using Python 3. Remember, if you're on a Mac or Linux, you might have Python 2 already installed. In our case, we installed our Python version 3.7 right here. So we make sure that this latest version of Python is what's being used as the interpreter. Now we can just click create, and our project is going to start for us. We can close these tips. Every once in a while you get tip of the day. Because this is an IDE, you get a lot of features that you can read about online. So it might take you a while to get used to PyCharm, but it is a very powerful tool. Let's make this a little bit bigger. Now, with my project here, I can right-click, say New, and then select File. Our file, we'll just call it hi.py. Click OK. And there we go. We have our first file opened up, and we can just, once again, say print. Now, this is definitely way too small. So I'm going to go to PyCharm, Preferences, and here it gives you a ton of options to customize PyCharm to your liking. In my case, I want to make sure that I use, let's say, a custom font, but definitely increase the size to, let's go with 18. How's that? Let's apply. That's better. You know what? I want to even bigger. Let's do 20. I'm going to hit OK. All right, this side is now bigger. That's great. We can see it, but this is still tiny. I want this a little bit bigger, so let's fix that as well. We can fix this easily by pressing Command and then using the mouse wheel if you have a mouse, or using 2 fingers and zooming in. Like so. If you're on a Windows machine, it'll be Control instead of Command, and just zooming in and out as you like. Now, the interesting thing here with PyCharm, I know we have a ton of things that we might not be familiar with right now, but the key thing is that Python 3.7 is running our project, And if we type something like print, hey, we get a ton of interesting things. First, we get a typo saying, hey, this whole hey is not an English word. If I add spaces, look at that. It even gives me typos of English words. But then I also have this yellow curly bracket or squiggly line. And it tells me pep8, no new line at the end of the file. This is something that we're going to talk about shortly when we talk about formatting our code. But if I add a new line, look at that. Everything is working smoothly. I get a nice little check mark. Now I can run this code by going to run and then clicking run. And you can see the shortcut command here as well. If I run this, ask me, hey, what do you want to run? Well, I want to run the new hi Python file. I click on this and look at that. Let's make this a little bit bigger. That's better. We see that our file is being run. The process finished with exit code 0. 0 is a good sign. It means there were no errors and everything is great. Now, if we make an error here, and let's say I miss my brackets and I hit run, or I can just click on run here. Look at that. It gives me an error saying, hey, syntax error. Unexpected EOF while parsing, and tells you something went wrong. So once again, I can fix it, run my code, and everything is good. There are a lot of features here that you can explore on your own, get comfortable with it. PyCharm is definitely a great IDE. And the beauty is that unlike Sublime Text or Visual Studio Code, where we had to install all these packages, PyCharm comes, well, with everything built in. It's an IDE. We don't have to install any of these packages. This environment is already set up for us to work professionally with Python because it is made for Python developers. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about formatting. That is code formatting. A very important tool that comes with a lot of IDEs, and you can also add extensions to code editors like Visual Studio Code to format code. Now, in order for us to talk about that, we have to talk about Python pep. And if you Google Python pep, you'll get something like this. PEP stands for Python Enhancement Proposals. These are proposals that the community, the Python developer community, gives in order for us to have a standardized way to write code. And one of the more popular ones, if you scroll down, is what we call the PEP8. You can see that there's a lot of PEP numbers. Well, PEP8 is the most popular one, and it's a style guide for Python code. It tells us this is what good, clean Python code should look like. But luckily for you, you don't have to click through here and read every single thing. I mean, it is a lot. Code editors and IDEs help us with this. Let's have a look. I have a piece of code here in my hello.py file. I mean, it doesn't look that bad, but how do we know if we're formatting the code according to PEP8? Well, very easily. We can run our command palette, or we can use the shortcut here, Command-Shift-P, or Control-Shift-P if you're on Windows. And then if we type in format, document, and click here, we'll get, hey, formatter AutoPip8 is not installed. Do you want to install it? And AutoPip8 is a popular package with VS Code or extension that gives us the PEP8 formatter. So let's install this. Now, let's once again run the format document. And did you see that? Our code changed quite a bit. We have some spaces, some formatting that went on. And it did that automatically because of PEP8. As soon as I change something, let's add some spaces here, like that, make our code just formatted really strange. I click save, and let's once again Command-Shift-V, format document. Now let's save this. And here, PEP8 formatting style was added. For example, with PEP8, it recommends that when you write functions that you have 2 spaces following it. So 2 spaces after every function. Once again, if I remove this and do format document, you see that a space is added because of our auto PEP8 package. Very, very cool. And you can also set this up so it does this automatically on save. I'll leave that one to you to customize your editor in the way that you want. Now, if we go to PyCharm, again, we have the same code over here, just larger text, already has this installed for us. As a matter of fact, you can see the underline here and says PEP8. Hey, I expected 2 blank lines after class or function definition. So it actually tells you that, all right, this is not good according to PEP8. Or maybe we can add extra spaces here. And right away, look at that, PEP8. Multiple spaces after keyword. We don't want that. Now, all we have to do here is simply go to Code and reformat code. And you can also see this shortcut available. If I do this, look at that. The code was reformatted. Let's make this a little smaller. And everything seems to be working. And I also get a little error. This is not PEP8. Again, it's another suggestion by the editor telling me that you've created a new function sum, but sum actually exists in Python. So you're almost overwriting this. Again, a really, really neat feature of PyCharm. And you know what? Just because we have a little bit of time, just to show you how you can use VS Code to just save or format on save, I can simply go to Preferences, Settings, and type in Format. And if I scroll to Format on Save, I can click on that. You can see that changes have been automatically implemented. So now every time I do Command S and save, look at that. It formats it for me so that we can make sure that we write clean Python code according to the standards. Let's take a break and I'll see you in the next one. Bye-bye. Let's talk about the very last one, the Jupyter notebooks. Now, this one is really, really interesting. And it's very popular with data scientists and machine learning people because, well, let me show you instead of explaining it. In order for us to use Jupyter notebooks, we can actually go to anaconda.com. No, this isn't a snake website. This is a distribution, a platform that allows us to download a ton of tools that Python engineers use. And like I said before, a lot of data scientists, a lot of people who are working with machine learning would download Anaconda because it comes with all these tools that we need to be productive instead of downloading them one by one. And here's the thing. You can actually just download Python with Anaconda. So if we didn't go to python.org initially and just went to Anaconda and clicked download, well, that was going to install Python for us as well. But I wanted us to go through the official way of downloading it instead of Anaconda because we want to understand how things work. So in here, all we have to do is click download and you'll be able to download the Anaconda distribution. And you can see that it's the most popular Python in our data science platform. And you can see that when you download Anaconda, it comes with a lot of things that we're going to use throughout the course, such as Jupyter Notebooks. It comes with different plugins like NumPy, or Bokeh, or Pandas, or even TensorFlow. A lot of things that data scientists use. Now, if you scroll down, it will detect whatever machine you're on. So you can download based on your version. So if you're on a Windows, you might have to click Windows and make sure you download version 3.7 or higher, and based on whatever computer you have. Most of you will probably have 64-bit. That's something dependent on your machine. If you're on Linux, again, you'll have different options as well. Now, You can click on download here, or you can even click on documentation, read more, and go to installation. Here we'll have a step-by-step guide on how to install Anaconda. Now I want to give you a warning, you don't have to do this optional number 2 step, which is to verify data integrity. This is something that you do for security reasons to make sure that you're downloading the right package. So that is completely optional. You can skip it over and you can walk through the steps to make sure that you install it properly. Now, one of the things that you'll get is this option, especially on Windows, to add Anaconda to my path environment variable. I recommend, and they do as well, to not click here. Because remember, we've installed Python initially already. So by clicking that and adding it to the path, it's going to conflict with an older version of Python that you may have installed a couple of lessons ago. So make sure you follow this guide, and you see that Anaconda recently announced that they're going to include PyCharm for Anaconda as well. So again, if in the previous video you've already downloaded PyCharm, you can skip over this step as well. So that's the thing with Windows. With Mac, again, it's very self-explanatory. You just click through the process, install, and everything will be done for you. And if you're on a Linux machine, you will have to use your terminal and essentially have to run this command that they'll give you in order to run Anaconda. And remember, we want to use Anaconda 3 because we want to use Python version 3. Now, once you have installed Anaconda, I'm going to give you a warning. It's a pretty big distribution. It is quite big. So if your computer doesn't have enough memory, doesn't have enough storage, there is another option, which is Miniconda, which is a smaller version of Anaconda that doesn't come with all these packages. And most likely in this course, you can get away with just running Miniconda as an option. Now, let's say you've installed Anaconda. You should have it in your applications right here. All you need to do is simply click on it, and it's going to launch Anaconda for you. Now, it might take a little while just to get everything set up, but once it's on, look at that. You have the Anaconda Navigator, and you have a few things here that you might recognize, such as VS Code. You can actually install it through here. You can use things like Spider, another IDE like PyCharm. You can also have things like RStudio if you want to get into R programming and really focus on data science. But the one we're really interested in is the Jupyter Notebook. Jupyter Notebooks are extremely popular notebooks that if you're doing any sort of data science or machine learning with Python, you're for sure using. I love them, and you'll see why in just a second. Now, you might have to install this if it wasn't installed, but otherwise, once installed, you can just click on Launch, and let's see what happens. Did you see that? It opened up my browser, my default browser, and it took me to localhost 8888. Now, if this doesn't happen for you automatically, you might have to just type in manually into the browser, localhost 8888. But otherwise, it's going to open up this for me, which right now, if you look at it, we're in our desktop. I can open my Python files if I want to. If I click on them, look at that. I get my Python files that I can edit and type things into. But this isn't really why we want to use Jupyter Notebooks. Instead, we want to create a new Jupyter Notebook. I'm going to click on New and make sure that we select Python 3. Once I click on Python 3, we get a new Jupyter Notebook. And this notebook, which is untitled, we can just name it My First Notebook. I'm going to rename and check this out. If I go to my desktop, I have some folders here. I have a hidden folder, which is the checkpoints folder, which is Jupyter Notebooks keeping track of my files. And then I also have my first notebook.ipynb. This stands for IPython Notebooks, which is what Jupyter Notebooks used to be called. As you notice, they are not .py Python files. there's a special type of file, the IPython notebook file, which can be opened with Jupyter Notebooks. Now, the reason we have a browser here is that Jupyter Notebooks needs a GUI, or graphical user interface, for us to write this. It's not a code editor where we had the code editor screens. Instead, it's using the browser to allow us to run this program. Even though it's using the browser though, you're able to run this offline. So if you're on an airplane, you can still run your Jupyter Notebooks and practice coding. Now, the way Jupyter Notebook works is using these cells. So these cells I can print, or I can write different code in Python. So if I do this, I can click run, and look at that. Right away, it gives me the output. And now I have a second cell where I can say, let's say 4 plus 5. If I run this, look at that. I run a different cell with a different output. Now, instead of us always constantly running run, we can also just use the shortcut Shift and Enter to actually run the code. So let's say, for example, we're doing is 5 greater than 4. I can run Shift Enter, and it gives me the answer right away. Now, the beauty here is that it's almost like creating notes for yourself, right? I'm able to run different cells, see different outputs, get immediate response to my code instead of in a code editor or an IDE where I had to write everything in one file and everything ran at once. And as we get into machine learning and data science and data visualization, we'll actually see that we use Jupyter Notebooks because they're so easy to visualize these results. Now, one other thing with Jupyter Notebooks that is really, really nice is this idea of the notebook, where instead of just always having code, which you can see over here, if I click on the drop-down menu and click Markdown, I can now type text like, this is my first Python or Jupyter notebook. And I can write different sort of notes here. And once done, I can do Shift Enter. And look at that. I have my notes in this book. So that maybe as you're learning for the rest of the course, you can have different Jupyter notebooks to take notes, run code, verify it, and, well, be extremely organized. And you can even post these on GitHub and share them with other community members. And all we have to do now is, well, it automatically saves. So you can see over here that anytime we open Jupyter Notebooks, let's actually do that. I'm going to close this as well. Yes, let's quit. I'm going to open Jupyter Notebooks one more time by clicking on Anaconda. It's initializing, takes a bit of time, but eventually I can launch my Jupyter Notebook. Again, it's going to open up my Jupyter Notebook on localhost. You'll see over here that the localhost has changed to 8889. So that may happen if, for example, localhost 888 is already taken. But if I click here on the Jupyter Notebook, remember the IPython notebook, I go back to my Jupyter Notebook with all my text, all my files. How cool is that? And by the way, going back to this localhost, the reason that this is actually still taken is, well, if you look over here, I have 2 terminal windows because I technically didn't close the session or the server from last time. So because I did that, Anaconda automatically said, oh yeah, localhost 8888 is already taken, so let's just increase the number to 8889. So you want to make sure that you close these once you are done. And when I do that, it tells me connection failed because we've stopped the server. It no longer works. So if I type something here, you see that I get a star and it's not doing anything. If I do 4 plus 5, again, it's not running because the server is no longer running. All right, let's take a break and I'll see you in the next one. There we have it. We went over a professional Python developer setup. Now you must be asking yourself, there's so many things that I want to do. I want to optimize my code editors, my terminal to have a certain look and feel. I want to have different extensions. There's so many extensions and plugins that you can take. But the beauty is that what you want and what you like evolves over time. And you'll have to customize your terminal or command prompt to different ways, different color schemes, having different tools available to you. You might prefer the lightness of code editors and keep things simple without having all that weight of something like an IDE, PyCharm, that takes a bit of time to get used to. That's why I personally like Sublime Text. Nice, really lightweight, and whenever I need a plugin or extension, I can install it and just use that. Or you might prefer using Jupyter Notebooks because it's a really great way to stay organized, take notes, and also run your small little code snippets, multiple code snippets in different cells. What you pick is up to you. My job was to show you the tools that are available and the tools that are being used by professional developers. But everybody's different. There's no right way, no right tool that is better than all the rest. So what I recommend is have your terminal or command prompt or PowerShell set up properly to your liking, and make sure that you get Jupyter Notebooks. But when it comes to code editors or IDEs, just pick one that you like, maybe even try Spider if you want, and stick with that. Because as you spend more time coding in one environment, you'll get better and better and more used to it. So as a final exercise for this section, pick one of these code editors or IDEs and customize it to your liking. Make it just right. And once you do that, trust me, it's like every time you code, you enter your home with all your favorite tools, furnitures, and things. I'll see you in the next one. Bye-bye. Everything in Python is an object. And in the next couple of videos, we're going to talk about this idea of OOP, or object-oriented programming. What it is, what it's useful for, and why it's such an important topic for us to become great developers. Now, when I say everything in Python is an object, what do I mean by this? Well, remember our data types that we've talked about? If I click Run here, you'll see that we have all our data types, but we have this class keyword in front of it. And I mentioned previously that this is something that we're going to get into. Now, everything here is an object because in Python, everything is built by this class keyword. And we're able to use different methods on our objects like this to perform some actions on them. So what is an object? Objects have methods like these and attributes that you can access with the dot method. Now, object-oriented programming allows us to go beyond what Python just gives us, which are these data types. But wouldn't it be amazing if we can create our own and make Python even more powerful? And using object-oriented programming and what we're going to learn, the class keyword, we're going to be able to do just that, so that the list over here can grow to our own custom objects. Now we're going to explore this topic of object-oriented programming, what objects exactly are, and what this class keyword is over the next couple of videos. But the key takeaway is that we're able to create our own types, our own data types, with different attributes and methods. Now, why is this useful? Let's have a look at an example. Let's say we're working for Amazon. And Amazon recently decides that, hey, you know what? We're going to have delivery drones that are going to deliver our customers' packages a lot faster. But we need to code this drone, right? And up to this point, we've learned that we can do that with basic functions, conditional logic, and just writing our code on a .py file. But the problem is, as code gets bigger and bigger and bigger, it's not just one file. It's not just 10 lines of code. It becomes hundreds and thousands and millions of lines of code divided into different files. Code gets more and more complicated because we live in a world where technology is everywhere. And programming something like a drone is quite complicated, especially when it's a delivery drone. So how can we use object-oriented programming to make this code more manageable? Well, OOP is what we call a paradigm. That is, it's a way for us to think about our code and structure our code in a way that is easier to maintain, extend, and write. So if we're writing a program about, let's say, that does drone delivery, well, we break it up into small pieces, into little objects that represents the real world. For example, I might code an object, my own data type, which is the propellers that allow the drone to fly. And maybe another developer works on the camera and the vision part of the drone. Another developer can perhaps create the claws that hold the package. And then another developer might be able to work on the signaling so that we're able to send signals from our drone to, let's say, Amazon headquarters and know where all our drones are. What we're doing here is we're breaking up functionality and data into different pieces that model the real world, into separate objects, so that different people can work on different parts and then we can just combine them afterwards. And the beauty is when we want to, let's say, create a delivery system that's not a drone this time, well, it's a tank-like delivery robot. We can use the same pieces, such as the camera and the claw and maybe the signaling, but we can just remove, instead of the propellers, and use the tracks that, let's say, tanks use. And somebody else can code this part. But we're able to use different pieces, extend functionality from our drone into different objects. Now, if you still don't understand 100%, don't worry. We're going to go over this over and over throughout the next couple of videos. The main takeaway is that OOP is a paradigm, a way to think about our code, a way for us to structure our code so that as it gets bigger and bigger, we're able to be organized. Because we're not writing silly 10-line codes. We're writing millions and lines of codes. Companies like Netflix have thousands of developers that are writing code every single day. They need a way to structure and organize this code so that, well, it just doesn't turn into complete chaos and complete spaghetti code. Let's take a break and learn more about OOP in the next video. In the previous video, we learned that OOP is what we call a paradigm, a way to think about our code and structure our code. And I'm going to link to this excellent article from Wikipedia about the history of programming languages. You see, we started with basic programming languages. We had things like assembly language that was really low level, really close to machine code. We had things like COBOL. And then we slowly, as we started writing more and more code in the 60s and 70s, we started establishing some of these fundamental paradigms. And one of the big paradigms that came to be, especially with the Smalltalk programming language, was this idea of object-oriented programming, or an object-oriented language. You see, up until that point, we wrote what we call procedural code. What that means is that if we look at a Python file, for example, a procedural code was just like a procedure. We simply had lines 1 through, let's say, 100, and we just went from the top of the line to the bottom of the line. We had conditionals, maybe loops, but everything was do this, do that. It was us telling the machine, hey, just do exactly this, what I'm about to tell you. With the introduction of object-oriented paradigms, this changed a bit. We started saying, hey, let's model something in our code that represents a real-world object. For example, if I'm about to code a car, I would create a car object that has data on what color it is, what type of engine it has, how many seats it has, but also actions like methods that we can take on it, such as the car can go forward, it can go backward, it can open the door. And instead of having these line-by-line procedural code, we can think in terms of models, real-world blueprints. Because as humans, we organize things. Think of a room. Think of a factory. By organizing things and having different groups in a specific location working together, that's a better way to think as well as to run things. So how would this look in Python? Well, Python is an object-oriented language, or can be, which means that it's able to support OOP ideas, this idea of objects and modeling. And we've seen this when we use the type. We see that everything is an object because we use this class keyword. But what is this class keyword? In Python, I can create my own data type, my own class, by simply saying class. And then afterwards, I can name it whatever I want. Let's say class big object. Now, right away, you see here that the naming convention is different than what we've seen before. We're going to make sure that it's capitalized, which is the standard. We want to let programmers know that this is going to be a class. And we're not using the snake case, we're using what we call camel case, which is every new word is a capital letter. And then here, we use the colon, and then in here, we write our code. Now, I'm not going to write the code right now. I'm just going to pass. But right there, I've just created a new class. So that if I do, let's say, for example, type big object, and I click run, well, I still get type. Because right now, what we've created is this class, which is a blueprint, but we haven't actually created the object. I know the wording can get confusing, but bear with me. I will explain this. We can now create, let's say, object1 equals to big object, and then run this class. So that if I do type object here, object1, and I click run, I get class big object. You can ignore the main here for now because we're going to talk about it later. But you see here that I've just created my own object. Now, let's think about what just happened here because it is a lot to understand. You see, in object-oriented programming, there's this idea of a class and an object. Now, a class is this. It's the blueprint of what we want to create. What are the basic attributes, that is properties, that our class has? What are some basic methods or actions that our class can take? And then from this blueprint, I'm able to create different objects over and over using this as the building block. So this blueprint is what we call a class, which we define with the class keyword. And this class can be instantiated, that is the action of creating different instances. And what are these instances? These are all objects. Now, the naming here is something that you're going to have to get used to, and all object-oriented programming languages have this language. So you'll just have to understand what somebody says, hey, I just instantiated a class. It means, hey, I just created a new instance, a new object. So looking at this diagram, let's go back to the code that we just wrote. We've created here a class or a blueprint. And then here, this double bracket is us instantiating the class and saying, hey, class, use whatever you have code in here and instantiate it and create a new object. So we're creating a new object by instantiating this class. And this is exactly what we're doing with something like a list, right? I can create multiple lists over and over and over. And every time I create a list, I have access to all of these methods and sometimes even attributes that I can use. And this way, I save a lot of time instead of coding it myself. And in the same way, I can create multiple objects here. Object 2, Object 3, just like that. And now I have 3 different objects that I can use based on this blueprint. Now, the blueprint right now doesn't have anything because, well, I can add code here later, and we're going to do that in the next video. But the beauty is, let's think about efficiency here. You see, the blueprint itself, the class, is going to be stored in memory. So Python interpreter is going to say, hey, big object, it's going to be the blueprint for this. So I'm going to store all that code in memory. But every time I create an object, I don't have to rewrite the code or do anything like that. I can simply say, hey, go in memory to where big object is and just run that code. So that, again, we're keeping our code dry. We have one place that allows us to instantiate our code into objects. Let's take a break and expand on this class in the next video. Now, the best way to learn is to actually see code in action. So enough theory, let's actually code our own class. I'm going to just delete everything and start from scratch. And let's say that we're working for a gaming company. And this gaming company has, well, this wizard game that they want to create, almost like Harry Potter. Now, how can we think about it in object-oriented programming? Well, the first thing that we're going to need is we're going to have players, right? Each player has a character that they need to play. So let's create a class here and call it player character. Again, notice the naming convention because it's a class. And another rule is that usually you want it to be singular, not plural. So you can't say player characters because, it's a blueprint. From this blueprint, we're going to create many characters, but those are going to be objects. So player character, single, in singular. Now in here, I'm going to do a few things. And I'm going to warn you, this is going to look confusing at first, but bear with me. I will explain it. We're going to define a underscore underscore init underscore underscore. Now in here, we're going to say self and then give it a name, the name of the character. From here, we're going to do colon once again and simply say self.name equals to name. Oh boy, what just happened here? Again, I'm going to hold off explaining what this does and just write a few more lines of code so that it makes a little bit more sense. I'm going to write another method in here, and I'm going to define, let's say, a run method that each player can run. And in here, I'm going to, once again, have this weird self word, and then simply inside of here, say print run. All right. So I've just created this class. It's still kind of confusing. We don't really know what this init is, what the self is, and this whole new look. But let's ignore that for a second and simply say player 1 is going to equal player character and instantiate that player so that we can print player and see what's up with this player. If I click run, all right, I get an error. It's a type error. It says init missing one required positional argument name. All right, let's take a break here and see what is happening here. You see, this init method is a special method. You see the 2 underlines here? This is called a dunder method or a magic method, and we're going to have a video specifically about this. But when we're building a class, you usually see this at the top. And this is what's often called a constructor method or an init method. And this is automatically called anytime we instantiate. Remember, instantiate means is we're calling the class to create an object. So when I do this, it's going to automatically run whatever is in this code block. So when I run this, you see that I'm getting the error on line 9 right here. On line 9, when I try to instantiate the player character, it runs init, and then it tries to do self.name equals to name. But the problem is that I'm not giving it an argument name. And that is because when we call init, we accept whatever is after self as the parameter name. So we need to give it a name of this character. So let's say the name is Cindy. If I click run here, all right, it looks like I have a player character. And as a matter of fact, it even shows me that it's an object at this memory location. So on our computers, this is where the player character, player 1, is located now. Very cool. But what is this self keyword? And what is this code on line 4? This is a way for us to define, well, self. Self refers to the player character. It's saying, hey, this is going to refer to this player character that we're going to create, player 1, and I want self.name to equal whatever the parameter name is. So that if I do player.name here and I click run, I get Cindy. And why is it Cindy? Well, because I gave it the parameter, player character, and when I instantiated it, I passed the name parameter. The default parameter is self when I do init. And in classes, you see here that the default, always the first parameter when we're defining a method, is self. And now I give name to self.name. What if I remove this here and I click run? You see that it says object has no attribute name. Because in order for me to say, hey, I want player to have a name, I need to say self dot. Because self refers to player 1. So if you remember, when we had a list, we had to do dot and then we would say append. Well, somebody wrote this append code. And in the append code, it's going to say self dot, let's say, add to the list. And self refers to whatever's to the left of the dot. So this way, it allows us to have a reference to something that hasn't been created yet. In this case, player 1, and let them know that, hey, when it's created, when we instantiate, then I want you to make sure that player 1 has this name attribute. So that if I create another player, and player Tom is going to be player 2, if I print player2.name and I click run, I have two different players with two different names. I was able to use the same piece of code, but have different values because the self, every time I instantiate this, refers to first time player 1, then second time player 2. Now, self is one of those things that gets really, really tricky to understand. And you might need to watch this video a couple of times. But the key here should be evident to you. That is, I'm able to write code only once. Remember our principle, dry, do not repeat yourself. And I'm able to make it dynamic by saying this data that we're going to create for the object is going to be dynamic and it's going to change based on what we give it. So that I can create different players with different attributes, but still use the same code. Now, I can have multiple things here. I can have age, for example, and once again, I can say self.age equals age. And then Cindy will have to pass, let's say 44, and Thomas 21. So that here, once again, if I do age, they'll have different attributes. So remember, these are attributes or properties that these objects have. And you can access them by doing the dot notation and then accessing the property itself. You see that I don't have any brackets here because it's not a method. It's not taking action. It's simply saying, hey, I want to access this attribute. If I do dot here, my editor will actually tell me and will have the symbol for, hey, you have access to the attribute age and name. And as a matter of fact, I also have access to run the method. So that if I click run, well, remember, a run is a method. So I get this bound method, but it's not printing anything. It's not taking the action. So we have to, once again, add the brackets, hit run, and look at that. I'm able to do run, then I get none, then 21. Why do we get this none? Because remember, this is a function that doesn't return anything. When a function doesn't return anything, what do we get? We get none. So maybe I can just say return done. If I click run, there you go. We have run, done, 21. Now, one last thing before I end this video. The interesting thing here is if I do player 1 and then player 2, and I print this and I click run, you'll see that I get the player character, but the object, each of these objects, player 1 and player 2, are at different memory location. So I'm able to use one piece of code, one blueprint, to create multiple players, but these players are not the same. They're created from the same blueprint, but they live in different places in memory. And that makes sense, right? We don't want Tom and Cindy to be the same player. They're two different players. So this way, we're able to keep things safe. And anything I add to player 2, for example, let's say player 2 can now attack, and attack will just be a property that will be 50. Now, if I do dot attack here, you see that player 2 has attack, but if I do player 1 dot attack, I'll get an error. Object has no attribute attack. I hope you're starting to see the power of classes. Although it may be difficult to understand at first, the power becomes evident when we are able to create this blueprint that we can now use over and over and over to create our own objects. Let's explore more in the next video. Object-oriented programming allows us to create objects that have their own methods, like run, and attributes, properties. It's a great way to add more functionality to a language and mimic the real world. For example, we use the idea of working for a gaming company. Although Python only gave us a few data types, I was able to create a player character. And now my boss is happy because this player character can be used all over the game. And all other coders have to do is run this line with the custom name and age of the character. So OOP allows us to write code that is repeatable, well organized, and also memory efficient, right? Because we only write this once. So if you want to be a great developer, OOP is something that you need to know and you need to understand because, well, this is how you want to organize your code. Thinking less procedural and thinking more in terms of functionality. Grouping data, like attributes, together with methods to create this class that is able to mimic something from the real world. Now I want to show you a useful tool here. We saw that when I do player dot, my editor shows me what I have available, the properties, as well as these purple boxes, which are the methods that I have available. And right off the bat, you see that I have age, name, and run, but then I have all these other ones that I got by default. Now, these are all dunder or magic methods, which we're going to get into. But the key here is that if I do something like help, which is a new function that you may have not seen before, and let's comment this out. If I click run, I actually get, well, the entire blueprint of the object. If I do something like a list, and I click run, again, it shows the blueprint that it has. And this is a great way to see what class blueprint some of the Python data types have. Now, this is something we'll revisit later. But I want to go back to this player character. Now, in here, we saw that we're able to create attributes. And attributes are pieces of data that are dynamic. That is, when we instantiate an object, they are going to be unique to that specific object, like name and age. And we had to use this self keyword to make sure that it was dynamic. However, there's another thing called the class object attribute. And it might look like this. Let's say we had the player character and they had to, let's say, be a paying member. In order to play this game, you have to have played, or you have to have gotten a membership. So let's have a membership equals true attribute. Now, unlike this one, you see that it's on the same line as our methods, and this is called a class object attribute. And a class object attribute, unlike these regular class attributes, is different because, well, it's not dynamic, it's static. So if I click run here, and we want to make sure that we print something, so let's print player2, and I click run. Well, I get the player, that's great. But if I do .membership and I click run, look at that. I get that equal to true. If I do player1 here as well, and I click run, I get true again. So all the players have membership set to true. But this is not dynamic. It's a class object attribute, which means it's an actual attribute on this class. And this is something we use when there's no change. This is going to be true and exist for all objects. So you can't really modify it. It's just all the objects that we instantiate will have access to it. So this doesn't change across instances. And we can use this down here as well, or anywhere in this class blueprint, as a matter of fact. For example, let's say we wanted to check if membership exists. So we're checking if membership is true, which, I mean, it always is, so this is a little bit redundant. But in here, I can say only if membership is true, then I'm going to assign name and age. But in order for us to access membership, I'll have to do self.membership, because remember, self refers to this player character, so that if I run this, everything still works. And if I do player1.name, this still works. Or I can refer to this by the actual player character. So player character.membership. So if I click run here, this also works because it's a class object attribute. If I were to, perhaps in the run, let's change this to shout. And in shout, it's going to want to run. Let's remove this line. It's going to print an F string that says, my name is, and give it a name. Do you think this will work? Let's give it a try. Let's say shout and make sure we run that method and then click shout again. If I click run, I get an error. Name is not defined on line 11. If I go to line 11 here, name is not defined. Why is that? Well, because we haven't used self. So let's do self.name. And if I click run, there you go. My name is Tom. My name is Cindy. Okay, awesome. And I'm able to use self because I pass it into here as the first parameter. And all methods receive the first parameter as self so that we can use them. But could I just do player character.name? If I click run, I get an error. Player character has no attribute name. Now, why is that? Because name is not a class object attribute. It's not actually a property or an attribute of player character. No, it's defined in our constructor function, our init function. So that's a bit of a gotcha here, and something that you'll have to get used to. A class object attribute is something that doesn't change across different instances, versus an attribute or a class attribute is something that is dynamic and specific to each class object. The way we access them is different, where we can actually access membership like this, but in order for us to access a name or age anywhere inside of our class, we have to use the self.name, which is why anytime we create a method in a class, even if I create a new one over here, and let's say this new one is going to be run, well, once again, I have to use self as a parameter, and then anything else that I want to add in here as the second parameter, so that when I click, let's say, run, I pass in the hello argument like this. I know this is a lot, but hopefully you're starting to follow the rules of classes. Once you remember these rules, then it becomes easier and easier. But we'll practice this a little bit more in the next video. I want to add a quick note about this constructor function. Remember, this gets called every time we instantiate an object. And this is how we create custom objects, right? But an interesting thing that you can do here, because you have control over how the instantiation happens, you can do different safeguards. For example, let's remove this for now because we don't need it. Or actually, let's change this to, let's do age. We want to check if the user is over 18. Then we're going to run this. Otherwise, well, the program is going to error out because we only let people age 18 and over to play the game because let's say it's rated R. So we can do different things in the constructor to make sure that we are instantiating the object the proper way. We can also give default parameters, like name can be anonymous if we wanted to, if they don't provide a name. And then age will be, let's say, 0 if they don't provide an age. So that here, let's say I forget to instantiate player 1 and player 2. If I click run, I get an error. Player object has no attribute name. And this is on line 11. Now, why do we not have self.name? Well, because on line 17, we're trying to call shout, but unfortunately, we never instantiated this because when we don't provide anything, the age is going to be 0. So we're never going to instantiate with these properties. Okay, so let's just give it Tom, and then age is going to be 10. And let's just remove player 2 for now. If I do player 1 dot shout and I click run, once again, I get an error because, well, Tom is only 10 years old. We're not going to create this character. Now, we're going to talk about errors, and maybe instead of just having this error out, we can send a message saying, hey, player is not old enough. But for now, I hope you see the power that comes with this idea of constructor and the instantiation of an object, where we're able to add these different controls and safeguards to perhaps make sure that we receive the right data type in order to create the object, or maybe the age is over 18, in order to make sure that when we actually instantiate this player 1 object, we're doing it the right way. So this init gives you a lot of control. Welcome back. we learned that we're able to create an actual attribute for the class. But what about a method? Is there a way to do something like here what we do with attributes, but for methods? Well, there is. And we use a decorator, which is a topic that we'll cover later on, and you'll understand how these work underneath the hood in a bit. But for now, the syntax that we're going to use is the @ sign, and then we call a class method, like this. And now, with this decorator, we can now write a function. For example, let's create a function, and we'll call it adding things that will take num1 and num2. And in here, make sure we add the define for the function. And in here, we'll just return num1 plus num2. Okay, so what does this class method do? Let me minimize this just so we can see a little bit better. Now in here, let's see if player 1 has access to adding things. So let's just say adding things 2 and 3. If I click run, it takes 2 position arguments, but 3 were given. That's on line 17. So when we call this, we gave it 2 parameters, but then it says that we actually got 3. And that is because adding things, the first parameter, just like we have here, is the CLS. And CLS stands for class. So this player character, that's the class that we're referring to. So similar to what we've seen before, but the standard is to use CLS. Now if I run this, you'll see that we get 5. Okay, but looking at this, it looks like it's pretty much the same as the above, except instead of using self, we use CLS. But how is this a class method? Well, it's because we can actually use this without even instantiating a class. Let me show you. Let's say that we don't instantiate player 1. And now I just simply call in here player character dot adding things. If I click run, look at that, I get 5. It's a method on the actual class. It's a class method. So you can do some interesting things. And by the way, class methods aren't used as often. So if you're thinking, why do we even need this? Well, I would say 95% of your classes aren't going to use something like a class method, but there are cases where this might be useful. For example, we can use the CLS to actually instantiate an object in here. So for example, I can say that CLS, which is the class, which is the player character, and I'm going to instantiate it, remember, just like we did here with the brackets, with num1 plus num2 as the second parameter, and we'll give it name Teddy. If I hit run here, look at that. I've instantiated an object, Teddy, with the age of what should be 5. So let's take this, make this equal to player 3. And if I do player 3 right here, dot age, and I click run, I get 5. So I have a whole new player here that was created by using this class method. So I was able to create, just like I created a class object attribute, a class method using this @ sign. There's also one other way of doing something like this, which is the static method. And the static method works the exact same way as here, except you do not have access to the CLS or the class. So you can't do something like we did above. Instead, we just perform some sort of method, like adding things to like this. So the only difference between the two is the idea that we don't have access in our parameters to this CLS. So we would use something like static method where we don't care anything about the class state. A class state is something like these. We don't care about the attributes, really. We use something like a class method when we do care about these attributes and maybe we want to modify them or change them. Now, these class method and static method is something that you won't see very often, but I wanted to show it to you just because you might encounter it through your Python career. Hopefully this wasn't too confusing. In the next video, I want to review what we've just learned up until now. Welcome back. Up until this point, we learned that OOP, or object-oriented programming, is a paradigm, a way for us to think about structuring our code. We went from procedural to writing functions to now using things like object-oriented programming. Now, what we've seen is what we call a classical OOP. That is, we use classes to incorporate object-oriented programming paradigms. We learned that we can create a class in Python with a class keyword using this naming convention, which is camel case with capital letter, which tells other programmers that this is a class that needs to get instantiated. We learned about class object attributes. We learned about how we can instantiate an object and how we have this init function that runs on every instantiation to customize our objects. We learned about how to add methods to our class so that each object that we create and instantiate has access to these methods. We also learned that there's things like class method and static methods, which are methods that can be called on the class without actually instantiating it into an object. And all of this was that so we can create our own data type that models the real world. Now, there's still lots more to learn in object-oriented programming. But if you follow these guidelines and look at this overall structure, that's pretty much it. That's how classes work in Python. And we actually have gained a really powerful tool now to really make our code better. Now, the idea of object-oriented programming requires some practice, and it's really hard to grasp when you're just starting out. We're going to try and do some exercises and learn a few more things about object-oriented programming so that we can really grasp this concept and use it in our everyday programs. I'll see you in the next one. Bye-bye. Welcome back to another developer fundamental. What is it? It's to test your assumptions. What do I mean by this? Well, anytime you learn something new, maybe something I'm teaching you or something other instructor or book or resource is teaching you, you want to test your understanding and your assumptions. Because you don't want to have any magic black box that things are happening that you don't understand. You want to know how things are working so you can explain it to people. For example, remember how I said that self is referring to this player character class? How can we test this assumption with code? Well, if I had just learned what self is, what I would do is to say to myself, well, I want to see self. I want to know what it is. You know what? I'm going to return here self and actually see what's going to give me, right? It's code. I can return self if I want to. Well, let's do that. Let's create this player character. Yes, I'm 100 years old. And then here we'll do player.run. Let's do a print here and click run. All right. So the self is the player character that I created, which is player1, which is located here. Okay. So although this is a simple example, what I'm doing as I'm learning is to test my assumption. Is that what I expected? Before I even run this code, I like to think in my head, what do you think is going to happen? And if there's a mismatch and I get something returned that I don't understand, well, then maybe I look into it. For example, this __ main. I still don't really know what this is. Why is this here? I mean, it has to be there for a reason, right? And that's something that we're actually going to talk about later on in the course when we talk about modules. So hang in there. But the way that learning happens in an accelerated fashion is when you don't just take my word for it. Because if you do that, you don't fully grasp the concept. The idea is to test and test yourself as well and your understanding. And say, if my assumption is that self is referring to the object that we create, how can we test it? And this is a great skill that a great programmer has. So hopefully, in future lessons, when I'm teaching you something, you test those assumptions. You test your learning through methods like this. I'll see you in the next one. Bye-bye. Welcome back. What I haven't told you is that when learning about object-oriented programming, again, and not just in Python, but in any programming language that supports OOP paradigm, is this idea of 4 pillars of OOP. The 4 things that object-oriented programming does really, really well. And as a matter of fact, we've actually learned the first one. And that is the idea of encapsulation. What is encapsulation? Encapsulation is the binding of data and functions that manipulate that data. And we encapsulate into one big object so that we keep everything in this box that users or code or other machines can interact with. And this data and functions are what we call attributes and methods, right? We're able to encapsulate the functionality of a player character by having name and age data or attributes, and also have functions that can act upon this name and age. So for example, I can have a method in here that says shout or speak. And this speak method can now use the name and age. I can say, my name is self.name and I am self.age years old. So that if I do player1.speak and I run this, my name is Andre and I am 100 years old. I'm encapsulating the functionality. If I didn't have this class, I would have, well, some variables and then 2 functions. But by using encapsulation, I've packaged this up into a blueprint that I can create multiple objects of so that when other people see my code, they know, hey, this is an entire object that I can interact with. I can use in certain ways that player character describes. And we've also seen this in our built-in Python data types, right? When I create a string like this, because of encapsulation, I have all this functionality available to me, all these methods that I can access. So that if I do, let's say, capitalize, it will capitalize all my strings. I have all this functionality encapsulated for me to use. Now, why do we want to package data and functions into attributes and methods? Well, because this gives us extra power, right? If, for example, this player character doesn't have any actions, any methods, and just had attributes, well, in that case, this is kind of like a dictionary, right? It's kind of useless. If I print player1 here, and I click run, I have this player object, but I can access name like this, and I can also access age like this. But I can't really do anything to it. I could have the same dictionary here, let's say player2, that is going to equal a dictionary that has name of Andre, and then age of 100. And the only real difference between the two is the way I access this information. Instead of the dot notation, I use the bracket notation to access the keys. So that when I click run, I have to make sure that I do 2 here for player 2. If I click run, again, it's the same thing. Sure, I can do it this way, but it's kind of useless. Why not just create a dictionary if all I want is data? But using this way, I'm combining things, packaging things up into those instances, into those boxes that can be useful. And also things that have meaning, right? Because our world is full of data and actions, right? Even a tree. For example, if we had a tree class in our real world, the tree would have maybe whether it was an evergreen or a perennial. It'll have whether it has leaves or it doesn't, how tall it is. It'll have all that information, but also actions, right? I can cut down a tree, the tree can grow, the tree can extend its roots. So this way, we're able to mimic what happens in the real world with our code. So that is encapsulation, and we've seen it. But let's talk about our second pillar in the next video. We know that there's 4 pillars of OOP, and we learned about encapsulation. What's the second one? Well, it's called abstraction. And abstraction means hiding of information or abstracting away information and giving access to only what's necessary. So whatever the user or the programmer or the machine is interested in, that's the only thing we give access to. Everything else, we kind of hide it in a blanket underneath the hood because our users don't have to worry about it. Let me show you what I mean. If I go back to our old example here, so instead of having a dictionary, we actually have a player character with a bunch of methods. Now, abstraction can actually be seen here, right? When I do player1.speak, you're seeing abstraction in action. Because when I click run, I get this string, but when I call speak, I don't really care how speak is implemented. All I know is that player1 has access to the speak method, and I can use it. Same with when I'm using something like a tuple, right? If I have 1, 2, 3, and I do dot here, I can do count to count how many items are in the tuple. So if I do print and click run, well, I have to give it a thing that we're looking for. In our case, let's look at 1, and let's add another 1 in here. If I click run, I get 2. Now, do I need to know how the count method was implemented? No. I mean, I can go look into it. I can look at the Python documentation, maybe the Python code, and understand how it's actually counting this, but I don't really need to, right? If we try to understand every single little piece, our head's going to explode. Sometimes all we need is a method or an attribute and just get access to it without having to worry about how it's being implemented, which is really, really nice. The same goes with built-in functions, right? If I do length here and I click run, I get a length of 4, but I don't really need to know how length was implemented in Python. It's abstracted away from us. And this is the power of OOP. It abstracts away things that we don't need to care about, or at least it makes us more efficient so that we know that it works a certain way and we're not wasting our time learning or coding from scratch. If we had our iPhone, for example, well, the camera feature on an iPhone, it'll be nice for an app that we build to use it, but we don't need to actually know exactly how the iPhone camera is coded on an iPhone. No. Instead, the iPhone usually gives us a way to say camera.take picture to actually allow us to take a picture without knowing how the Apple engineers actually coded the camera. So it's a very powerful concept. Okay, so you're thinking, I think I get abstraction, but let me ask you this. Could I just do player1.name equals to, let's say, exclamation marks, and then player.run? Or you know what? Let's do speak equals to boo. Make sure it's player1. Well, if I now print and do player1.speak, and I try to run this function, let's see. I get string object is not callable because speak has been modified. Speak has been modified to a string value instead of this actual function that we would have needed. So that if I run just checking the speak attribute, I get boo. I mean, abstraction is good, but hold on a second here. This is bad. If I have a class that I've abstracted away, but anybody can come along, any programmer can come along and just remove all my hard work and overwrite it like that, isn't that bad? Let's take a break and explore this topic a little bit more in the next video. Welcome back. In the previous video, we saw that we did some big boo-boo. That is, we overwrote name and speak, and now all that hard work that we put into our class has been overridden by this. I mean, sure, if we instantiate a new object, we will have our run and speak, but player1 now is completely useless. It has no name and speak, well, it just says boo. Completely useless. Now in Python, there's this idea of public and private, and this is related to our discussion of abstraction. The idea behind abstraction is that we hide away information and only give access to things that a user is concerned about, right? So ideally, we shouldn't have access to init. Ideally, we shouldn't be able to, let's say, modify run or modify name and age, because when we create a player character in our game, hopefully the player can just randomly change their name or their age and sneak into our game that perhaps is only 18 and over. So can we make a private variable in our class? Well, here's the thing. Some languages allow us to have private variables. For example, in a language like Java, I can actually say that an attribute is private like this, and I won't be able to access it and modify it like I have this way. But in Python, there's no true privacy, no true private variables. So how do we get around this? Well, what we would do is do underscore name or underscore age. Now, does this give any special power? No, this is just a convention. That is, as programmers, as Python programmers, we determine that, hey, if we see underscore in our code, that most likely means that this should be a private variable. So that when I use it in speak, let's say underscore name, underscore age, and let's comment this out. If I click run, well, I have to run this because now it's a method. Let's click run. And I get my name is Andre and I'm 100 years old. It all works. But if I try to overwrite these and click run, oh, and now because it's no longer a method, let's remove speak, and I click run, this still works. And that's because, like I said, there's no true private variables. As programmers, we've decided that underscore means that you shouldn't touch this. Please don't touch this. You could still be bad and do something like this, but I'm letting you know ahead of time. If you see underscore, this shouldn't be modified. This should be private. And that's how we achieve privacy in Python. We all kind of agreed to say, hey, let's keep this little thing private. So if you ever want to keep a method or an attribute private, you just put an underscore in front of it, but it's no guarantee. What about this double underscore init? Again, this is something we're going to be speaking about very shortly, but it's called a dunder method. That is, it's built into Python. And we usually never write our own dunder methods. We would never write double underscore like this. These double underscores, and there's lots of them, have special meaning in Python. And the reason that they're named like this is because they're saying, hey, if you're writing double underscore for your variable, you're doing something very wrong. You're about to overwrite something. So once again, this double underscore is also a convention to let people know you shouldn't really touch this or modify this. With each data type, let's say a list, if I do dot, you'll see that as you scroll down, you have a lot of these dunder methods. Again, something that we're going to talk about. But these are here to let you know, don't overwrite these. If you're doing something like underscore, I don't know, doc, like this, that's bad. Don't try and modify it and assign it to 5. So this idea of a private field is important to Python. And although we can overwrite a lot of things, it's bad practice. But let's bring it back to abstraction. The idea is to abstract away this code. And although it can be modified and overwritten, by using these proper conventions like private attributes, we're able to abstract things away but still make sure that whatever the user might be using isn't going to break our code. I'll see you in the next one. Bye-bye. So we've talked about encapsulation, about abstraction. What about the third pillar of OOP? It's called inheritance. An inheritance allows new objects to take on the properties of existing objects. So you can inherit classes. Let's have a look at an example. Let's remove the previous code that we've had and go back to our game example. We want to create a new game, and we have different types of users. So we have users that can be wizards, that can be elves, that can be, I don't know, archers. But all these users have some common functionality, and each one of the sub-users, like wizards, elves, archers, have some common shared functionality, but then again, different maybe attacks. So using OOP, we can actually do inheritance. For example, let's say we have a class user here, and this user will have, let's say, a sign-in function or sign-in method. Once again, it's going to receive self, and then we'll just, for now, assume that we have some sort of a sign-in here. So let's just say for now, print logged in. Because in order to play a game, they have to be logged in. Okay. Now, you might be wondering, where is the init method here? Shouldn't we have that init method that gets run first? Well, we could. But if we don't have any variables or attributes that we want to assign to the user, well, in that case, we wouldn't need an init method. So for now, we'll just say that we don't need, there's nothing that the user has other than this sign-in method. Now, let's say we want to create a bunch of subclasses so that we have a class wizard. And for now, we'll just do a pass here so that we don't have an empty class, but it will still allow us to build it. And then let's say we also have a class archer that will pass through as well. Oh, and make sure we have brackets here. Now here's the thing. Ideally, all these wizards and archers are users as well, right? So we have users, and these users can have multiple forms. They can be wizards, they can be archers, they can be ogres, all the characters in our game. But all of them, let's say, have to be signed in first. How can we make sure that all of these users or classes also have access to sign in? Well, we can use inheritance. And how do we do inheritance? Quite easily, actually. All we do is in the bracket pass the parent class that we want to inherit from. So let's say I do user here. Now let's click run here. No errors, everything is looking good. And by the way, you see the green line here? Tells me that indentation is not a multiple of 4 because indentation should be 4 in Python. So we can just do this, but I like keeping it smaller just so it's easier to read. Okay, so let's instantiate a class here. I'm going to create a wizard1 and then say wizard and run that wizard class. Now, if I do print here and I do, let's say, print wizard, if I click run, I see that the wizard object has been created. And what if I do dot sign in? I see that, yeah, it's actually there. If I do sign in and click run, hey, I'm logged in. How cool is that? I inherited from the user class this functionality. And this is really, really powerful because now I can extend my wizard, right? So let's say that this wizard has an init method, which will be run when the wizard is created, and we'll have a name and power that we get. And in here, we'll assign self name to equal name, and then self dot power to equal power. And let's also add another method, calling it attack. And this attack method will simply print an f string that will say attacking with power of, let's say, self.power. And then we're going to do the same for the archer. So I'm going to copy this code, paste it in here, and the archer will have name. And let's say instead of power, we'll say that it has, let's say, number of arrows. And number of arrows will be the new attribute that it gets. And then the attack will have, well, attacking with arrows. And then we'll have arrows left. And arrows left will just say number of arrows. And we can do something fun where the arrows decrease as every time you attack. Okay, so now that we have this, let's make this a little bit smaller just so you can see. There you go. Now that we have this, let's instantiate the first wizard with, let's say, Merlin with a power of 50. And then the archer will be instantiated as Robin with, let's say, 500 arrows. Or let's do 100 arrows. So now, the wizard and the archer are going to have, well, they'll have the sign-in, but they'll also have the attack, but unique to their individual classes. And they'll also have different properties. Let's have a look. If I was to do wizard dot, let's do wizard 1 dot, and then we'll say attack. And let me just turn back my code intelligence. We'll see that we have a few errors. Here, what's it say? Undefined name, self, and that's because I forgot self in the brackets. So you remember, we always have to give the first parameter self. If we scroll down, we go to wizard dot, we see that we have name, power, and attack. If I click attack here and I run, we see that I'm attacking with power of 50. If I do archer 1 dot attack. In that case, I'll get attacking with arrows. Arrows left, 100. But both of these have the sign in function at the same time. How cool is that? This is the power of inheritance. We're keeping our code dry, right? We're abstracting away the part of the code that they both share, but then changing things according to what each one needs. So for example, I could have different methods and properties on Wizard than the Archer, but also have shared user functionality that they have. And this way it keeps our code organized and clean. Now let's bring back the zoom in just so you can see it clearer. Now, this idea of inheritance is really, really powerful. And the key here is that we have a parent class and children classes. Now, sometimes these children classes are called subclasses or derived classes because they're subclasses of user or derived from the user class. Let's explore this topic a little bit more in the next video. Now, I'm going to minimize this a little bit just so we can see a little bit clearer. It's not as messy this way. And I'm going to remove some of the spacing in between here, even though it'll give us a warning, just so we can see everything. There we go. All right, so we have these classes. Now, Python gives us a useful tool to check if something is an instance of a class. And easily enough for us, it's called instance or isInstance. And isInstance is a built-in function in Python. We give it the instance and then the class that we want to check. So in our case, if we had wizard1 equals to wizard Merlin with power of 60, in that case, if I do wizard1 and then do class wizard, and I print this, what do you think we'll get? If I click run, I get true because wizard is an instance, or wizard1 is an instance of wizard. Let me ask you this. What if I do user? Is wizard1 an instance of user? Guess what's about to happen? It's true, right? Because wizard class is a subclass of user. So technically, yes, wizard1 is an instance of user because we've had to run this class to create wizard1. But here is the interesting part. If I do wizard1 dot, do you see how I have our methods and attributes that I've added, but also all these dunder methods that we haven't really talked about yet? Where do these come from, right? Well, in Python, remember how I said everything is an object? Well, everything in Python inherits from the base object class that Python comes with, and it's called object. You see how it got highlighted here? So if I do isInstance wizard1 of object, oh, and I have to remove the dot over here. Let's click run. It's true because wizard1 inherits or gets methods from the wizard class, from the user class, and even higher up from the object base class that Python comes with. And that's why we have these automatic methods attached for us. So that using object, every single method that is useful. For example, if I open up a list, if I do dot, and let's say we pick the repr method, which we don't really know what it does yet, but if I go to wizard1 and I do dot, you see that I have it as well because they both inherit from the object base class. And this way, we avoid repeating code. Any common functionality, I can just dish it out to all the objects that need it, which is very, very cool. So underneath the hood, when I do something like user, it's actually accepting object as the parent class in order to accept these properties that are built in and that we might need in the future. All right, that was a lot. One more pillar to go. I'll see you in the next video. Bye-bye. One final pillar of OOP to go. We talked about encapsulation, about abstraction, and about inheritance. And then there's this fourth one that has a pretty tough word, polymorphism. What does that mean? Well, poly means many, and morphism means form. So many forms. Now, we know that methods belong to objects, right? We use the self keyword to act upon the object that got instantiated. Now, in Python, this idea of polymorphism refers to the way in which object classes can share the same method name. But those method names can act differently based on what object calls them. Now, that sounds extremely confusing, so let's have a look at a code. We have our user, wizard, and archer classes. And as I mentioned, with polymorphism, different object classes can share method names. So we have attack here that is shared, but each one does something different based on the attribute. For example, when I do wizard1 attack, so let's do that, wizard1.attack. If I click run, I get attacking with power of 60. Because, well, wizard has a special meaning to its attack versus archer. They're different. So although they share the same method names, because of the object that's calling it, the output is going to be different. So we can actually do something quite interesting here. Let's say that I have wizard1, and then we'll also have archer1, and archer1 will be Robin, and Robin has 30 arrows now. What I can do here is actually call them in different ways. For example, I can create an entire new function called player attack. And this player attack takes a character, and in here we can say character.attack. And now, if I run this code and say player attack wizard1, and I run this, I'll get attacking with power of 1. If I do player attack, have archer in here, if I click run, you see that the same function gives me a different output, even though we're calling the same thing because of the object that we pass into it, polymorphism. Another way to demonstrate this is if we do a for loop. If I do for, let's say character in, and let's add wizard1 and archer1 into a list. And if I print here, or let's just run character.attack. If I click run here, once again, I have two different outputs, even though I'm calling the same method because of the different objects. And this is a really powerful concept, right? Because we're able to customize this according to our specific needs. Even if, let's say that the user had a attack method. And this default attack method is, let's say, print do nothing because it's just a user. Even if I run these, and let's say print wizard1, and let's say dot attack, if I click run, it's going to override whatever the original attack was because we already have that method in our wizard class. But let's say I wanted to have both user and wizard run the attack method. How can I do this? Now, this is something we'll explore a little bit more in the next video, but for now, I can say user.attack and give it self. Because I accept user as my parameter in here, and then I can run user.attack. So let's see what happens here. If I click run, I have do nothing and attacking with power of 60. So polymorphism allows us to have many forms. It is the ability to redefine methods for these derived classes, that is wizard and archer. And an object that gets instantiated can behave in different forms, in different ways based on polymorphism. And this is useful because we are able to modify our classes to our specific needs, but also not have to repeat ourselves in case we want to use something like attack from user inside of wizard. So there you have it, the 4 pillars of OOP. Encapsulation, abstraction, inheritance, and then finally polymorphism. Now, no amount of videos or books are going to teach you exactly when to use what. However, the idea here is to understand that these powers exist with OOP. You're never going to say, oh, I need to implement polymorphism. No, most of the time you're just coding along and it happens that you're coding in a way that emphasizes polymorphism. This is just the power of OOP. Although these are big words, at the end of the day, we've learned how to use them to structure our code in a way that is efficient and clean. And that's the whole point. It's all about organizing our code. Now, some of you may have been a little confused when I did this, user.attack self. In the next video, I want to explore this a little bit more. I'll see you in that one. Bye-bye. Welcome back. In the previous video, I showed you how to call a method from a subclass of the parent class. So in our case, we did user.attack in order to run the attack method in user. Now, I've removed the attack method from now because I want to try something different. I want to create a init function in here. And this init function will take self. And then let's say that the user will receive, let's say, email. Because all the users of our game need to have emails. And in here, we'll just say self.email will equal the email. Nice and simple. Now, in here, if I was to run this code, and let's remove user.attack for now. So we have the same wizard. We've just added this init. And we have our wizard 1. So if I run wizard here, and let's say we want to run wizard1.email. If I click run, I get wizard object has no attributes email. But I thought the user is going to be called when we create the wizard, right? When we instantiate wizard1. Well, the thing is, although we might inherit, let's say, for example, if I do dot, we might inherit the sign in from the user. And if I click run, we see that we inherit that. The wizard already has an init function, already a constructor, right? So how can we solve this? Well, one way is to just add email here, right? And just have the email attribute just right down here. But what's the problem with this? Well, it's inefficient, right? Because if I create an archer class, I'll have to do the same thing. And when we know that all these attributes are going to be the same on all of our subclasses, we want to do it here. So what's a more efficient way of doing this? Well, we want to call the init method of the user from inside here, right? Because every time we instantiate a new wizard, well, this init function is going to be called. So the way to do that is to say user dot underscore underscore init, and then give it the self, and then email. And then the email is something that we pass in. So that if I did go down here, I can say merlin@gmail.com is going to be the email. So that now, if I do, let's say, .email for wizard1, and I click run, I get Merlin's email. Once again, all we did was we called the init method of the user inside of the wizard. So when we instantiated a new wizard, we ran this function, and inside of this function, we ran the user.init and passed in the email that we passed in as an argument in here. Now, this is one way of doing it, and then there's another way, and it's called super. And it's a keyword, as you can see, it's being highlighted here. And all we do is run super. And super is referring to the super class, or the class above wizard, which is user. And this is actually a new addition as of Python 2.2. With super, we actually no longer need the self. So our code looks even cleaner. And all we pass is this. And if we click run, we still get the right answer. Super allows us to refer to user this way and not have to worry about passing self. Welcome back. I want to talk to you about this idea of introspection. And introspection in computer programming means the ability to determine the type of an object at runtime. What is runtime? That is, when the code is running, you can determine the type of an object. And it's actually one of Python's strengths. Because everything in Python is an object, we can examine, we can introspect an object and actually figure out what our code does as we're coding and then running. And Python allows us to do introspection and inspect these objects with some nice helper functions. This one function is called dir. And dir, well, if I run this, will give me all of the methods and attributes that the wizard instant has. So with a dir function, we give it an instance, and right away we get access to what it has access to. Well, we see that we have name, power, and sign in. Again, we have the sign in from the user, and then we have also attack from the wizard class. And this editor that I'm using, whenever I do dot, is actually using this ability of introspection to just list out these available methods for me, just like I have here. So this is really useful when you're trying to figure out what you have access to. But you may notice something here. We have a lot of these dunder or magic methods that we haven't really talked about. What are these and why are they so important? In the next video, we're going to tackle this question. I'll see you in that one. Bye-bye. You've waited a long time for this because I've avoided talking about these dunder magic methods for a long time. In this video, we're finally going to uncover what they do. Now we're able to see what our instance has as methods using the dir method. And we told you that these were inherited from our base object class. Now, these underscores are special methods. Remember how we have things like length, for example, that allows us to tell the length of an array. These are actually implemented using these dunder methods. They allow us to use Python-specific functions on objects created through our class. So let me show you what I mean. We're going to create a new class, and this is going to be a toy class. Now, in here, we'll define a toy and initialize it with self. Then we'll say that it has color and age. Now we'll say color equals to color. So these will be our attributes and age. Awesome. There's our class. Now, let's say we want to create an action figure. This action figure will be instantiated with toy, let's say color of red, and the age it's brand new, so it's 0. Now, if I use something like, let's say str that comes with this object, if I do str or action figure dot underscore underscore str, like so, and we print this, we see that we get this. It's the exact same thing as us doing str action figure like this. Look at that. These double underscore dunder methods are special methods that Python recognizes. For example, the dunder str, this special method, allows us to use action figure like this using the str built-in function. As a matter of fact, if you go to the Python documentation under the special method names section, you'll see that we can do basic customizations of these dunder methods. And it's a long list of all these dunder methods that we can use. Now, don't go and read every single one of them. There are a lot, and you're not going to use them that often. There's only specific few cases that you're going to use them, and the idea is to know how to modify them and how they work underneath the hood. So let's go over a few examples. For example, let's modify what the str does. I'm going to define my own str here. I'm going to call self. And then in here, I'm going to return something different. I'm going to return, let's say, an f string that is, let's say, self.color. If I run this, I get red. Remember how I said not to modify dunder methods? Well, sometimes you're allowed to. Maybe there are cases, special cases, where you want your class to behave a certain way. Just like dictionaries, lists, tuples, and all our objects in Python can behave in certain ways. How lists were accessed with an index number and a dictionary was accessed with a key. Those are all implemented using these dunder methods. And you see here that because we modified this, the str now returns red when being called on action figure. It doesn't change things other than within action figure. If I run this, you'll see that it still runs action figure like this because this is a string. The str is only modified when we use it on this specific object. Like so. What other neat things can we do? Well, we can change the meaning of the length as well. So length, I can say self. And in here, I can just return 5. Now, if I print length of action figure, and I click run, I get 5. Very cool. By the way, if this underline is getting a little annoying, which frankly, for me, it's getting a little bit annoying, I'm going to click on settings here and just remove the code intelligence. So it won't tell me when my code is wrong, but hopefully we can just debug it ourselves. All right. So there we go. We've just changed the length dunder to return 5. Let's keep experimenting. We can also do something like __ delete. And delete, well, lets us actually use the delete keyword, which we actually haven't seen before. Delete, we can just say return deleted. You have to go like this, and let's just do print here, print deleted. If I click run, I see that I returned deleted. Now, the delete keyword I haven't really taught you because it's not something that you'll see a lot of. Usually this can cause some funny bugs in our programs that I like to personally avoid. But the delete keyword deletes some sort of variable that we might have had in our program. All right, what else is there? Let's change this to use something called call. And call is an interesting one. Let's say that with call, we're going to return, and let's say yes, question mark. The neat thing about call is that now it gives our toy class some superpower. We can say action, figure, and then say, well, with call, we actually can now call the actual object with these brackets. So using call, I have this special way to call a function, which by the way, underneath the hood, the way we're able to call functions is using this dunder call. And if I click run, I get yes. How cool is that? All right, one last one because I think you're starting to get the idea of this. Like I said, these are all available in here. Usually you don't want to overwrite them, but you just want to know that you have the power to do so if you choose. The next one is called get item. So let's do define get item. Again, we're going to use self as the first parameter, and then let's say I for index. And in here, we'll return self dot, and let's add an attribute before we add that. I'm going to say self dot my dict for my dictionary, and then add name equals to yo-yo. And let's do has pets equal to false. Now, using this, I can say my dict and return the item based on the index that we give it. So let me show you what I mean. If I now do print action figure dot, and in here, instead of doing the dot, we do the square brackets, just like we would access perhaps getting a dictionary item. We can now, using the get item, say, what properties do we have? Name. So let's say name. And if I print this, forgot to add a comma in here. Let's try that again. And if I scroll down, you can see I'm really good at reading errors. Name error. Name action figure is not defined because it's action figure, not figure. That's better. Look at that. My name, Yo-Yo, was being able to access using this bracket notation, using the get item dunder. Very, very cool. So these special magic methods are really interesting because it allows us to do some custom modifying of our classes. And you can also understand how in Python, our built-in default types had access and abilities to have all these special syntaxes. We now have that power as well. Let's take a break and do a bit of an exercise. I have a fun little exercise for you. I want you to create a super list using the class super list. Now in here, I want you to add code that allows us to have, just like we have a list in Python, allow us to access through index, through, well, any way that a regular list allows us to use it. But the only difference is that the superlist is going to have a special dunder method. Let's say that when we do length, so when we define dunder length, we're going to modify it and we're going to have it return, no matter what, 1,000. Now, this may look easy because all we want to do is modify the length dunder here. But the question is, based on what you learned about inheritance, about object-oriented programming, instead of having to write every single dunder that we need to use on a list, how can we easily acquire the power that list already has and then just modify this length dunder? So remember, superlist is going to be a list that we can create, we can instantiate like this, superlist1. We're going to call superlist, and it's going to allow us to do things like length, superlist, and also access items in the superlist or use superlist one dot, let's say, append, and maybe append 5, and actually get superlist 1 5. All right, take it away from here, give it a go, pause the video because I'll give you the answer. So let's just implement this. We're going to have self in here, and we're only going to return, let's say, 1,000. So that when we call superlist 1, and let's comment this out, and I do length here, let's print it out, I should get 1,000. That's good. But I want the functionality of this. I want to be able to append to my superlist. So let's run this and see what happens. I get an attribute error. Superlist object has no attribute append. Let's think about this. How can we acquire the powers that lists in Python already have? Well, we learned about inheritance, right? And all we have to do is just simply type list here. And now list becomes our parent class of superclass. So let's give this a go now. If I click run, all right, that seems to work. What if we want to access superlist at index, well, not 5, at index of 0? If I click run, I get 1,000. Well, that's because we're not printing anything yet. So let's print here and click run. Check that out. We're able to have this superlist, and we just extended the functionality of list. How cool is that? Now, to double check, there's a fun little function that we have in Python, and it's called isSubclass. And here we say superlist and list. If I click run, I get true. Because is superlist a subclass of list? Yep, that's true. What about this? Is list a subclass of the base object? Yep, it's true. Remember, everything in Python is an object that inherits from the base object class. We then inherit some built-in list methods, and we're able to use all of that in our superlist just by inheriting like this. Very, very cool. Now, for some of you, this might have been a simple exercise and you got it right away. If you didn't, don't worry. Now you know. Pretty cool, eh? I'll see you in the next one. Bye-bye. Let's talk about multiple inheritance, which you're able to do in Python. Now, remember we have our user wizard and archer classes. We're trying to build that game, right? Now, let's clean up some of this code. We won't need the init function anymore. We'll just have user here. We have wizard that inherits from user, and also archer that inherits from user. But what happens if we want to create a new character? And this character is called a class, let's say it's called Hybrid Borg. A weird name, I know. But here's the thing. Hybrid Borg is a special type of character because it has the powers that wizards have, which is attack. It has the power that archers have, which is check arrows. And just for fun, let's also add run here. And we'll just say for run, ran really fast. All right. So we want this hybrid Borg to have all of these methods. Can we do that? Well, we can. All we need to do is say wizard and then archer. We can give it as many parameters as we want as multiple inheritances. We're inheriting from wizard and archer. So that in here, let's say I don't do anything and I'll just hit pass. If I instantiate, let's say hybrid Borg 1 is going to be hybrid Borg class instantiated, I can now use all of these things. Let's check them. Let's say print hp1.run. Can I do that? And again, a little spelling error. Let's make sure it's hybrid Borg, not hybrid board. I hope you're not bored of this video. All right, I get an error, missing 2 required positional arguments, name and power. All right, because, well, we have to pass these things in, right? It accepts these parameters. Okay, so let's say that we want name to be Borgy and the power to be 50. If I run this, all right, it looks like ran really fast. Run works. I was able to inherit from archer. What about check arrows? If I click run, oh, I get hybrid Borg object has no attribute arrows. Now, why is that? Because technically we inherited from wizard first, then archer. And wizard accepts name and power, but we never gave the arrows, name and arrows. So how can we solve that? Let's try something. Let's say we added arrows here, 100. Would this work? That doesn't work, does it? And this is a tricky thing with multiple inheritance, and why some programming languages actually don't even allow multiple inheritance. Things can get a little tricky because in your head, you have to make sure that you understand how these classes are implemented and make sure that we're not overriding anything. In our case, we can complicate our code a little bit. So what can we do here? Well, in here, I can perhaps do something like this. I can say define init. This receives self. It will receive a name, a power, and also arrows. And then finally in here, I can say that we're going to call also the archer dot init, and that's going to take self and then pass in the name and arrows, so that if I run this, well, let's add the arrows, 100 here, and I click run. There you go. Arrows is now working. Now, just to check that our attack on the wizard is working as well, if we do attack and click run, oh boy, now our hybrid object has no power. So once again, in order for us to have power, we'll have to copy this. And let's say this time, wizard, init, self, and then give it power. If I click run, all right, attack works. Let's go back to check arrow, make sure we haven't broken anything. If I click that, that works as well. And then finally, what about sign in? Will sign in work? Logged in. All right. Oh boy, that was a lot. And there are a few ways of actually solving this problem. What I wanted to show you though, is that when you do multiple inheritance, things can get complicated. And although we walk through it step by step, imagine if there was a coder that came along on your team at work and tried to understand this code. Well, we've added quite a bit of logic here and things are getting more and more complicated. And it's hard to keep track of everything in your head. And this is why multiple inheritance is one of those things where it's really, really powerful. But with great power comes great responsibility because we're creating more and more complexity. Again, part of the reason that some programming languages don't actually allow you to do multiple inheritance. And by the way, I'm going to confuse you even more. In the next video, we're going to talk about something called MRO. And it's going to be another great example of why you want to be cautious with multiple inheritances. I'll see you in that one. Bye-bye. Let's talk about something that sounds quite complicated. It's called MRO, or Method Resolution Order. What does it mean? Well, I have an example here for you. Let's say we have a class of A, class of B that inherits from class of A, does absolutely nothing. And then we also have class C that inherits again from A. And then finally a class D that inherits from B and C. So we have two classes that do absolutely nothing, and then a class A and class C that have the same class object attribute. And I've actually drawn out how this relationship looks like. You see that D has multiple inheritance from B and C C inherit from A. And MRO, or Method Resolution Order, is a rule that Python follows to determine when you run a method, which one to run. When you have such complicated inheritance structure, MRO is a rule that says, hey, do this, and then do that, and that's the method that you should run. Let me show you what I mean. Let's say I wanted to do print d.num. What do you think will happen here? Let me move this out of the way or comment this out. If I run this, can you guess what's going to happen? If I click run, I get 1. Is that what you expected? Let's look through this. D inherits from B and C, and then those inherit from A. So we get 1 because the MRO, the Method Resolution Order, is that it doesn't go D, B, A. Instead, it goes D, B, C, A. Let's think about this a little bit more. MRO is simply saying what's first in line. If things are common between classes, methods, or variables or attributes, what should I pick? And there's actually a good way for us to check this. If I do MRO and then run it like this, if I click run, look at that. This is the order or the MRO of this class. It says, hey, I'm going to check D first. If you call, let's say, d.name or d.num, I'm going to check main.d first. So I'm going to check this class. Then I'm going to check main.b. So I'm going to check B. And then I'm going to check C. And then I'm going to check A. And then finally, I'm going to check the base class object. Again, we've seen that before. It's the base class that all objects in Python inherit from. So that's the order that it checks for num. If we pass all of these, and I click run, I'll get an error. D has no attribute num because it went through all this path, even checked the base object, and never found num. If I did something like str, if I click run, this works because it goes all the way through the inheritance chain and then gets to the base object, and the base object actually has this. So it does an error out, and yep, you can use the dunder string. Now I found a great example here to show you why inheritances can be confusing and why things like MRO you might want to avoid, or at least be conscious of. So let's copy this code and let's just remove all of this. And we're going to play a little game. Now this syntax looks like this. So this is the inheritance model of what we just created. Looks pretty confusing, doesn't it? So if we do M here, and we check the MRO, or method resolution order of M, what do you think the order is going to be? Pause the video here and try to guess what the order will be. Ready? Let's do m.mro. And by the way, another way of doing this is to use the dunder MRO. And let's print this. All right, let's check this. So the first thing we have is M. All right, we check M. And then we check B. We check B. All right. And then we check A. So we check A here. And then we check X. X over here, then Y, then Z, then the class object. Is that what you guessed? Let's look at the code. Why this order? Well, the order is because of the way that we're passing in the parameters. You see, B is passed before A and Z. So that means the order of MRO is going to be B, then A. But hold on. After B and A, what was that? Well, after B and A, we have class X. Why did X come before Z? So instead of going to Z, let's make this a little bit bigger. Instead of going to what we would have thought would be Z, it goes to X, then Y, then Z, then the object. This is because of the algorithm that they use for doing MRO, which is called depth first search. Now, this is beyond the scope of the course. But as you can see, it's quite a bit confusing. And as a matter of fact, Python actually changed the MRO rules from what we had previously in younger versions of Python. So this is another one of those things that got updated. But the reason I'm showing you this is because you're never going to get tested on this stuff. If you're writing code where the inheritance looks like this, I argue that you're writing bad code because this is overly complicated. We haven't even written any code actually inside of these classes, and it's already confusing. So MRO is there as a way to define what order you're going to inherit in, and you can always use the MRO function or dunder to check this. But the reason I brought it here is not just trying to confuse you. The reason is that it exists, however, you should not structure your code in this way. This doesn't mean that this doesn't happen in the wild. Yes, it does, but at least you have a way of checking and maybe debugging your code when you see a problem like this. I'll leave a resource for you about MRO if you're really curious and you really want to understand how this algorithm works and how this order is actually determined. But the key takeaway is that this is the way that Python works to determine, hey, when you call a method or an attribute, this is how I'm going to look up the hierarchy of inheritances. All right, if your brain hurts, don't worry, so does mine. Take a break, and I'll see you in the next video. Bye-bye. Now, we learned that as programmers, we've started to write code that was just pure procedural code to something more organized, using something like object-oriented programming. And we talked about how we had languages like Smalltalk that had this concept of classes and objects to organize our code into these functional boxes. Now, around the same time, there was also this idea of another paradigm called functional programming. And languages like Scheme introduced this idea of functional programming. Now remember, a paradigm is a way for us to think about our code and organize our code. And up until this point, we learned about object-oriented programming. In the next couple of videos, I want to tackle this idea of functional programming. Now, some of the concepts are different than object-oriented programming, but that doesn't mean that you have to pick one or the other, or one is better than the other. Instead, we can use the concepts from both to think like programmers and understand that there's trade-offs, pros and cons to each. And we're going to try and explore that over the next couple of videos. So what is functional programming? Let's find out. So what is functional programming? Functional programming is all about separation of concerns, which object-oriented programming does as well, right? It's all about packaging our code into separate chunks so that everything's well organized in each part of our code. And each part is organized in a way that makes sense based on functionality. So when we say separation of concerns, we mean each part concerns itself with one thing that it's good at. We remember in our object-oriented programming section how we had classes to divide up attributes and methods of, let's say, a wizard class and an archer class. And functional programming has this idea as well of separating concerns, but they also separate data and functions. That's how a functional programmer views the world. Instead of combining methods and attributes, we separate them out because they're two separate things. There's data, and this data gets interacted and acted upon. But we're not going to combine both data and functions as one piece in an object like we saw with object-oriented programming. Now, there is no correct definition for what is and isn't functional, but generally, functional languages have an emphasis on simplicity where data and functions are concerned. Because in most functional programming paradigms, we don't have this idea of classes and objects. Instead, functions operate on well-defined data structures like lists and dictionaries that we saw, rather than belonging that data structure to an object. But at the end of the day, the goal of a functional programming paradigm is the same as object-oriented paradigm. It's the idea of making our code clean and understandable, easy to extend. That is, we can grow our code and make it better and better and have others come and extend our code. It's easier to maintain. It keeps our code dry so that we are not repeating ourselves, as well as keeping our code memory efficient because we're not storing information all over the place. Now, when we come to functional programming, we have a very important pillar. And unlike object-oriented programming, where we had those 4 pillars of encapsulation, abstraction, inheritance, and polymorphism, if you want to break things down in functional programming, it all comes down to this concept of pure functions. And this is something that we're going to explore over the next couple of videos. But the idea here is that there's a separation between data of a program and the behavior of a program. So let's find out more about pure functions. What do they mean? What are they? What is a pure function? Well, a pure function looks like this. We have a function. So instead of a box that we had before of objects of all these functionalities, instead think of this as just a simple function. And let's say we give it a list containing 1, 2, and 3. If we give this input into this function, what we would expect with a pure function is for something to happen to this input that every time results in the same thing. So let's say we multiply this by 2, we would receive 2, 4, and 6. Now, a pure function has two rules. One is that given the same input, it will always return the same output. That is, every time we give 1, 2, and 3 to this list, we give it to a function that we create, it should always return the same output. So if I run this function millions of times with the same input, it should result in the same output. And the second point is this idea of a function should not produce any side effects. What are side effects? Side effects are things that a function does that affect the outside world. For example, if I was to print something inside of this function, it affects the outside world, right? Because I'm printing something onto a screen. The screen is the outside world. Or for example, if this function was touching a variable that lived outside of a different scope, that's a side effect. Let's have a look at code to understand this concept a little bit more. Let's say we had a function, and then this function will multiply by 2 a list. So let's just say an li, which will be our list. And in here, what we want to do is loop over the item in the list. And then each item, we want to multiply and append to a new list. So let's create a new list. That will be an empty list. And in here, we'll say new list dot append and do item multiply by 2. And then finally, at the end of this function, we want to return the new list. Let's give this a go. If I say multiply by 2 and give it 1, 2, 3, and let's print out here the output. If I click run, I get 2, 4, 6. Is this a pure function? Let's think about this. The first rule, given the same input, that is 1, 2, and 3, it will always return the same output. No matter how many times I run this, it's always going to give me the same output. So, okay, we passed the first test. What about the second test? That it produces no side effects. Does this produce any side effects? Does this touch anything in the outside world? Think about it. No, it doesn't, right? Nothing in the outside world matters to this function because everything is contained in here. If, for example, instead of having print here, we simply have print in here. If I click run, we get the same output, but does this have side effects? Well, yes, it does. It interacts with the outside world, which is the print statement. The print statement tells me, hey, I'm going to print on whatever the display this machine has. In our case, it's going to print here, but we don't really know what print statement does because it interacts with the screen on this side. So this has side effects. We give control to print, but we don't know what print is going to do. Another example that I can give you is this. What if we have a new list here that we actually define outside, like so? So that we have new list like this. If I click run, I still get 2, 4, 6. But does this have side effects? Well, yes, it does. It interacts with the outside world. And what's outside of this world of a function, which remember is the scope? Well, it interacts with this new list. It appends to this new list. So if a programmer comes along and maybe before we run this function, we decide to say new list, we change it to an empty string. Well, when I run this function, I get an error because now this new list is a string object. So the new list that lives in the outside world of this function can be modified by another developer or by a program, and we wouldn't know about it. And when we run this function, it's going to give us an error. It has a side effect. So ideally, we contain our functions and make them pure. Because as you can see, we're never going to have a bug or an error in our code unless we wrote something wrong here. But because we don't care about the outside world, because everything that we give as an input is always going to produce a good output, it's going to be pure. Now, it's hard to really understand why this is such a powerful concept without having a bit of experience in the workplace. But let me just tell you this, that when you have pure functions, you have less buggy code. You're able to test your code better. It's easier to understand your code. And overall, you have these benefits of not having different parts of your code touching each other and affecting each other, which makes your life as a programmer so much easier. So this idea of pure functions is really important. But the one thing I want you to take away from this is that pure functions is more of a guideline than an absolute. It is impossible to have pure functions everywhere. Because if a function doesn't affect the outside world at all, well, we wouldn't have any programs. We wouldn't be able to display things. We wouldn't be able to save things, such as our game profile. So it's impossible to have pure functions everywhere. However, when you can, wherever you can, functional programming teaches us that pure functions are good. Try to create pure functions and only have few non-pure functions that maybe interact with the outside world that we can go back to whenever we have bugs in our code, because most likely those are the ones that are going to have bugs than pure functions like this. To finalize our concept of functional programming, if, for example, this was our wizard from the previous videos, with functional programming, we would have a wizard object or wizard dictionary that had name, let's say Merlin, and power of 50. And instead of containing these in a class, I would have different methods, such as attack. And this wouldn't be a method, it would be a function because it doesn't live inside of a class. In functional programming, they say, hey, we don't need to combine data with functions. Let's keep those separated. Let's just create pure functions that can be passed anything, like a character. And this way, we keep those two things separate so that we can focus on pure functions and we can focus on data. So that's where the difference is. At the end of the day, it's all about trying to keep our code clean and avoiding bugs in our code, a big problem that programmers have all the time. So it's just a different way of thinking. Let's learn some more in the next video. Welcome back. I want to talk to you about some useful functions that we get that actually allow us to think in a functional programming paradigm. The name of these functions are map, filter, zip, and reduce. And these are very, very useful, very common functions that you'll write a lot when you're a Python programmer. So let's explore them. First one, we're going to start with map. And map actually allows us to simplify the code that we have here of multiply by 2. You see, with map, I have it available as a function, as a built-in function. And we see here that we give the first parameter a function, and then the second parameter is an iterable. A good way to think about it is we want to take some sort of action here, so a function, and then the data that we want to take action upon. So let's say in our case, 1, 2, 3. So what action do we want to take on 1, 2, 3? Well, we want to multiply by 2. So let's say multiply by 2. Now I have to move this down because we have to define the function first and run it like this. So instead of printing this, let's do print like this. If I run it, I get a map object at this memory location. And map automatically gives us this object that it has created in this memory. So in order for us to actually view it, we have to turn it into a list like this. So if I run this, it says on line 4, int object is not iterable. Well, it's because with map, we no longer need to do this creation of a list, then appending to a list. You see, the neat thing about map is that I give it some data, and then this data gets acted upon by this. And all we need to do with the map function is to have a function that returns this part, item times 2. So instead of having all of this code, all we need to do is say return item times 2. So let's change this parameter to item and look at the code a little bit more in detail. So with the map, I say, hey, I want you to run the function multiply by 2. Notice here that I don't even have the brackets because I don't need to call it. Map does it for me. Map just says, hey, just give me the function, I'll take care of the rest. So I'm not calling the function here. The map is going to call the function for me. I'm just saying, hey, when I call map like this, I want you to use this function at this memory address and use this data. Remember our functional programming paradigm. We have data that gets acted upon. So we separate those two out. Now, this function is going to take each one of the items in our iterables. In our case, first time around, item will be 1, then 2, then 3. And then all we need to do is to return what effect we want to have on that item. In our case, it's 2. So by doing this, map automatically runs this function for us and loops through all the items in the iterable and returns for us a new map object that we're going to convert into a list. If I run this, I get 2, 4, 6. Now, here's the neat part. If I do, let's say, my list, and I say 1, 2, 3, and I change my list over here like this, and at the end also print my list. If I click run, you'll see that my list hasn't changed. Remember, a pure function is a function that doesn't affect the outside world. And this way, map allows us to create a whole new list that doesn't modify my list. So my list is immutable, right? We don't change it. And all it does is map function takes care of it and returns a new list for us. But we don't affect the outside world. There's no side effects in this function. We're simply just multiplying item by 2, but creating a new list out of this. And every time we give it the same input, it's going to result in the same output. Very, very cool. And map is extremely useful because anytime we have something that we can iterate over and we want to change, let's say we have emails or usernames, and we need to update the usernames to, let's say, be all capital letters. In that case, we can iterate and using the map function, change all the usernames in our list to, let's say, capital letters. Map is going to be one of those functions that you use a lot in your programming career. And I hope you can see here how clean and nice it is, again, using functional programming paradigms. Let's move on to the next one. Let's talk about filter next. Welcome back. Let's talk about filter. Now, based on the name, you should guess what it does. It filters things for us. So with map, we always got the same number of items back, right? We had 3 items and we got back 3 items. We just mapped over each item. With filter, we can sometimes receive less than what we gave it. We're filtering some of our results. So let's create a new function. Instead of multiply by 2, I want to create a function. And this function, what are we going to do to the items? Let's say if items are check if odd. So we're going to say, hey, are these numbers odd? And only return the odd numbers. So check odd is going to receive an item. And this item is going to be acted upon. And once again, we have to return something. What are we going to return? Well, the filter function is going to try and receive a true and false value or a Boolean value, whether it should be filtered or it should not. So if we want to check if a number is odd, well, we can say item modulo 2, because modulo 2 is going to divide the number by 2. And if it equals 0, then it's even, right? So I can say doesn't equal 0. So if the remainder doesn't equal 0, it's going to be odd. And we just simply return this. Again, this is going to evaluate into a Boolean expression. And based on the Boolean expression, filter is going to say, if it's true, I'm going to keep it in the list. If it's not, I'm going to remove it or not add it to the new list. So let's check this out. Instead of map, let's do filter. And here we'll do check odd. Or you know what? I don't like this name. Let's do only odd. Like that. If I run this, look at that. I've filtered and removed the 2 because that's an even number. Again, notice here how I'm not calling the function because filter accepts a function or what we call function signature. That is, hey, just tell me where I can find what memory space I should go to for what action to take. And it's going to say, hey, give me the data and I'm going to go and run this function on each item. So when we go to 1, it's going to run this function with 1 as the argument. 1 divided by 2, well, that definitely doesn't give us a remainder of 0. So that's going to return true, and that means I'm going to add it to the new list that we create. When we get to 2, though, because this is going to return false, it's not going to add it to the list. Again, if let's say we have a list of users, in that case, we might want to filter out based on users starting with the name A. We can use the filter function to filter through all the usernames and only have a new list with the usernames with letters starting with A. Another very useful function. And as you can see, we kept everything pure. It creates a new list for us. It doesn't modify the original list. So we're keeping that functional paradigm in mind. And once again, the beauty with both map and filter is look how simple the functions become. Everything is just nice and simple, and mind you, they can get a little bit more complicated, but all we need to know is, hey, what should I do to the item and what should I return? That's the only thing that they're concerned about, instead of having these massive functions that try to do everything. All right, let's talk about zip next. Let's talk about zip. How can we use zip? Well, let's create a new function. And the zip function works kind of like a zipper. We need 2 lists or 2 iterables, and we can zip them together. Let me show you what I mean. Let's say I have my list and then your list. And this your list will have 10, 20, and 30. Make sure that it's a list. There you go. And in here, with the zip function, I can simply run zip. And in here, I give it as many iterables as I want. In our case, 2 iterables. So I'm going to give it my list and your list. Let's close that out, add one more bracket. And if I click run, look at that. What just happened here? Zip, like a zipper, takes the 2 iterables and grabs the first item from each and zips them together like a zipper. So 1 and 10 get added to a tuple together. Then 2 and 20 get added to a tuple together. And then 3 and 30 get added to a tuple together. What if this was a tuple? Like this. And I click run. Doesn't matter. It's an iterable. It's going to zip the items together. Now, this may not seem that useful to you now. It's actually a very important function that, because it's so generic, can be used in so many different things. For example, if we had from a database, we collected all the usernames from one column in a database, and then maybe from another part of the database, we collect all of the phone numbers, and they were all in the same order. Well, we can combine these into a tuple using zip that has the username and the phone numbers attached to them and create a whole new data structure. And if I had another list here, let's say their list. And this one has 5, 4, and 3. I can add, again, their list as well. And if I click run, you see that I can keep zipping things together. So zip iterates over each one of these lists or data structures and zips them together. Once again, noticing that we don't modify any of our current data. Instead, we create a whole new one. Very, very nice. What about reduce? Let's find out more in the next video. Let's talk about the last one, reduce. And this is a bit advanced, and it might be a little bit difficult to grasp at first, but it's good to know that it exists and you can learn more about it by practicing it and reading some documentation on your own. Now, reduce doesn't come as part of the Python built-in function. In order for us to use reduce, we have to do something like this. Now, you've never seen this before, and this is something we're going to get to in the modules section of the course. But essentially what's happening here is when we downloaded Python interpreter and the Python package, in our case, this REPL already does it for us, we can import something from these functools. And functools are what we call a tool belt that we can use for functional tools that comes with the Python installation. And from there, there's a specific function that we can import. So I'm saying, hey, from functools, from this tool belt, I want you to import the reduce function so that we can use it in our code. Again, something that we'll cover later on in the course. So for now, just copy and paste this line. Next, let's remove some of our list and here use reduce. Now, with reduce, we're going to need a few things. First, we need the function, and then we need the sequence or the data. So what's the function going to be? First of all, our data will be our my list. So I'm going to say my list. And the reduce function allows us to do something interesting. I can give it, let's say, a function. And this function, we'll call it the accumulator. And the accumulator takes 2 parameters. And remember, this is going to be called by reduce. So reduce is going to be in charge of giving these 2 parameters from the data that we give it, which is my list. The first parameter is going to be what we call the accumulate, or in my case, the ACC. And then here is going to be the item. Now, where it gets really interesting is that when we first pass my list from the reduce, we'll get the first item. The first item will be in this parameter. However, what's this ACC initially? Well, if I just remove the brackets here and show you reduce, you see that we have the function, the sequence, which in our case will be our list, and then the initial. An initial is what the accumulator is going to be. So once again, let's say that we're going to have the accumulator function that we're not going to call yet. Reduce is going to do that for us. I'm going to give it the list or the data that we want to iterate over. And then I'm going to give it an initial value of 0. So we have 3 parameters here, or 3 arguments that we give it. Now let me close the brackets. There you go. Let's make this a little bit bigger here. And make sure that I can spell. Now in here, the first item will be whatever is the first item in my list. And then the accumulator is going to default to 0 if we don't give it anything, or in our case, we have said that the accumulator is going to be 0. So the first thing we're going to do is we're going to return accumulator plus item. Okay, so let's go through this one by one. I'm actually going to print here the accumulator and the item just so we can see, and then I'm going to run this code. Line 15, int object is not iterable. And this is a little tricky, but we actually don't need the list anymore because reduce is going to do something interesting for us. So let's just remove this for now and just return whatever reduce gives us in the print. If I click run, look at that. All right, so what just happened? Let's have a look. Reduce allows us to reduce something, some sort of value from the iterable that we give it. So let's go step by step. We have my list, and my list is going to be applied to accumulator through reduce. The accumulator is going to take my list, and the first thing it's going to do in the first pass through is going to say, hey, what's my accumulator going to be? I'm going to set it to 0. So the first pass through, accumulator is going to be 0, and item is going to be 1, which is what we see over here. And we're going to add it, 0 plus 1. So now we have returned 1. Now the second pass through, what's going to happen? The second pass through, the accumulator is going to be what this returned. So the next pass through, whatever this is returned is going to be filled into accumulator. So in our case, 0 plus 1 will be 1. An item will be 2. 1 plus 2 is going to be 3. So 1 plus 2 equals to 3. So the next time around, the accumulator is going to be 3. And what we pass through is going to be 3 as well, as you can see here. and 3 plus 3 is 6. We've just accumulated all these values and returned one single number, 6. We've reduced our list into some sort of data that we've manipulated using, in our case, accumulator, but I could have done anything I wanted here. So if, for example, I change this to now equal 10, what do you think will happen? If I click run, I get 16 because I started my initial accumulator with 10. So it was 10 plus 1, then so on and so forth. Now, reduce is really, really powerful because you can do a lot of things with it. It's really, really flexible. And actually, underneath the hood, functions like map, filter are actually using this reduce underneath the hood. So you can actually build your own map and filter function using reduce. Again, reduce is a little hard to understand at first, and it does take a bit of practice to really use it. But it's one of those things that advanced programmers really, really love, and you'll see more and more of throughout your career as you get better and better. I'll see you in the next one. Bye-bye. Welcome back. Let's talk about something that I really, really love, and it's called lambda expressions. And lambda is actually a computer science term that really is compatible with this idea of functional programming. You see, lambda expressions in Python are one-time anonymous functions that you don't need more than once. What does that mean? Well, lambda expressions are really, really useful when you're using them for functions that you only use once. Remember how we talked about functions are useful because we can define them and then use these functions over and over and thus save us from copy and pasting code? Well, lambda functions are for those occasions where we have a function, but we only need to use it once. And then the second part is that they're anonymous functions. That is, because we only use them once, we don't need to have a name for them because we don't really need to store them anywhere on our machines. I just want to use it once, just run it, and then I'm done with it. Just throw it away. So how does a lambda function look like? A lambda function looks like this. We say lambda in Python. Let me just add a bit of space here, just so we can see. We say lambda, and you can see that it's highlighted blue. And then I'm going to say a parameter that this function is going to get, and then a colon, and then some sort of a function here, and the parameter. Or instead of function, it'll be some sort of a manipulation that we do. So let's say action that we want to take on a parameter. All right, this still looks confusing, so let's actually try to implement it in our functions that we've created. So let's say multiply by 2 is one of those things that we're only going to use once. I only want to multiply by 2 this my list, and then I'm done with it. I don't need to save it to memory. It's just extra piece of code. I don't need this. How can we do it? Well, let's say we have the map function back here, and let's turn it into a list. And for now, I'm just going to minimize these, so we only focus on the multiply by 2. And here, let's go back to multiply by 2. Remember how we had it before. My list, and we don't need the third parameter, just like that. Now, with a lambda function, I can say, hey, I don't need to create a whole new function. I'm only going to use it once. Let's just remove this entirely. And instead of using multiply by 2, I'm going to say lambda. And here, I'm going to give it the parameter. What parameter am I going to receive? Well, I'm going to receive an item from my list. And then in here, what do we want to do to my list? Well, I want to multiply it by 2. All right, could this work? Let's give it a go. I'm going to run. Whoa, did you see that? I didn't even use multiply by 2. As a matter of fact, I can just delete it. And if I click run, everything still works. Now, why is this? Remember, lambda expressions are one-time anonymous functions. There's no name attached to this function. This is the function right here that you don't need to run more than once. So once the interpreter runs this line of code, it doesn't remember this. It just forgets about it, but it performs the action for us. In our case, we're saying, hey, I want to create a lambda expression. I'm going to take an item from my list, and then I'm going to multiply that item times 2, and this automatically returns it. Again, the order that we do is lambda, then we give it the param, colon, and then the action we want to take. In our case, it'll be param and whatever action we want to do, like so. In our case, item times 2, and this automatically returns. How cool is that? This is a really nice feature of Python to keep your code really nice and clean and not clutter with all these functions. And other languages might not have lambdas, but they are sometimes called anonymous functions. Again, something that we've discussed why they're anonymous. They're just like normal functions and even behave like them, but we only use them once and they don't have a name. But you can see here that it makes things a little bit cleaner. What if we try to do filter now with a lambda function? Well, if you want, you can pause the video and try yourself, but it should be fairly easy, right? If I do filter, I can do lambda, item, and then item. We'll just copy this. So the action that we want to take on the item is this. And if I run it, again, it works. How nice is that? No longer need this function either. Very, very nice. What about reduce? Can we use reduce with lambda? Sure, why not? Let's say here, we'll say reduce. We're going to remove the list from here because we're just producing a single value. I'm going to say lambda item. Remember, reduce accepts 2 parameters, the accumulator and then the item. So I can just give it 2 parameters like this and then say, what do we want to do? Well, I just want to add accumulator with the item. So if I do my list here like this, and I click run, check that out. That works as well. How cool is that? Again, we no longer need the accumulator, and now we just have one-line functions that I can just run and immediately reduce the list. Very, very cool. We're going to be exploring lambdas a little bit more, especially in the comprehensions part of the course. So if you're still not 100% on them, don't worry. We'll have more use cases and why they're useful later on in the course. But lambda expressions, I really, really like. They make your code really, really small. However, they do make the code a little bit less readable. So it is a trade-off where you can get really clever with lambda expressions, but make your code really confusing to others. So you do want to be careful. For now, we're done. I'll see you in the next video. Bye-bye. Let's do a fun exercise to test our understanding. And we're going to use lambda expressions. Now, I want you to create a lambda expression that is going to square our list. So let's say we have my list, and this my list will have 5, 4, 3. Now, I want you to create a one-line lambda expression that's going to print for us a squared list. So 5 to the power of 2 will be 25, 4 to the power of 2 will be 16, and 3 to the power of 2 will be 9. So a list that contains those values using lambda expressions. So that's your first challenge, is to square. The next challenge And this one's a little tough. We're going to do some list sorting. Let's do square here, just so you can see. And in this list sorting, I have a list. And this list, well, it's a tough one. We have a list that is a tuple of 0, 2, then a tuple, let's say 4, 3, and a tuple, let's say 9, 9, and then finally a tuple that is 10, negative 1. Now, what I want you to do is to sort this based on the second value. Ooh, make sure this is a comma. So that is, I want this to be sorted so that this tuple is first because -1 is the lowest. Then this tuple because 2 is the next highest. Then this tuple, then this tuple. So how can you do that using lambda expressions? Now, this is a tough one, so if you don't get it, don't worry. Pause the video here, take your time, see if you can solve this. Otherwise, I'm going to get going with the answers. This one should be fairly easy to you, right? We can just simply do a map function. Or you know what, let's just say new list is going to equal a list that we're going to map over. And in here, nothing we haven't seen before. I'm going to say lambda number is going to be number to the power of 2. And the list that I'm going to give it will be the my list. If I run this, there you go. Nice and easy. Nice, easy one-liner. What about this one, though? This one's a little tough, and you really have to think about it. We've learned that we have the dot sort method, right? And the sort, actually, well, let's see what happens if I just sort like this. If I do print a dot sort and I click run, I get none because it modifies the list in place. So let's just print A after we have sorted it. If I click run, all right, it looks like it's sorted with the first key. What if we move this in here in the middle and click run? All right, looks like it's sorting it for me, but it's sorting it based on this first item. But I want this second item, or what we call the second key, to be the sorting factor. And if you see here, if we do sort, I have to give it a key. And we want the key to be 2. So how can we do that? Well, we can do something like this. We can say key is going to equal each one of the second keys. And we can use a lambda expression here. We can say lambda, so the default parameter would be lambda of x, and then simply say x1. Let's go over this. What I'm saying is, hey, I want you to run the sort function. And the key for the sort function, when I'm sorting through everything, is I want it to iterate over each item that I'm going to get. That is, x is going to be this tuple. And I want you to use the value which we're going to return, which is the second one. So the key is always going to be by the second item. Now, if we run this, look at that. We're able to sort by the second item. Now, if you didn't get this, don't worry. This is quite tough. And it's hard for you to get used to the syntax or know that sort worked in this way. But the goal is to show you that this is a common thing that you can do with lambda functions, and a way to make sure that you can sort with different keys. For example, this would work with a dictionary or another list inside of a list. This is a common way to adjust your sorting, and it's a pattern that you just have to remember. But it shows you the power of Lambda, where we don't really have to write these complicated functions. If we really just needed a one-time function and just a function that returns something simple, Lambda is a great tool to use. But if you didn't get this, like I said, don't worry. This is one of those things that you'll just have to remember. Let's take a break, and I'll see you in the next one. Bye-bye. Let's talk about something that's quite unique to Python and makes things really, really nice as Python programmers. And it's called comprehensions. It's one of our key terms, comprehensions. What are they? Well, they're actually called list comprehensions or set comprehensions or dictionary comprehensions. And these are some of the data types that we have in Python. And we're able to use comprehensions with these three data types. By the way, as I'm recording, there are some birds chirping in the background. I thought it would be nice to just record with birds chirping in the background. I think it'll be peaceful for you. If you get annoyed, I'm sorry. But hey, the birds have to have fun as well. Okay, so what are these comprehensions? Well, they're a quick way for us to create lists or sets or dictionary in Python instead of perhaps looping or appending to a bunch of items to lists. So let me show you. Instead of doing something like my list equals an empty list, and from here I'll do something like for character in hello, my list dot append character, just so I can create this list finally. So let's say my list, and we'll print this out. If I click run, I created a list that contains the characters from hello. All right, but is there a faster, cleaner way of doing this? And yes, there is with list comprehensions in Python. Again, it is quite unique. You don't see it in a lot of programming languages, but people that use Python really love this feature. And I do too. So how can we do this using a list comprehension? Well, the format we're going to follow is like this. We're going to say param for param in iterable. So when I say param, I mean parameter, or in our case, it could be a variable. So we can name it whatever we want. So let's name this character, like we did in here, and then character, like we did in here. And then we want an iterable. In our case, we'll say hello. So that if I remove this and I click run, I get the same thing, just like that. So upon creation on line 3, I create a list that contains character in hello. I do a for loop in here, and I create the list. So the way that I like to think about it is, hey, create a variable. And then we're going to do a for loop saying, hey, for each variable in the iterable, added to the list. Okay, let's expand upon this. Let's say I wanted to do something else. Let's call it my list 2. And I want to create, let's say, a quick list with numbers ranging from 0 to 100 or 0 to 99. How would I go about doing this? Again, using list comprehension, I'll say number for number. And then what's the iterable I'm going to use? Well, I'm going to use a range and say 0 to 100. So that if I click run here, look at that. I get a nice long list pre-populated with all these numbers. How cool is that? Okay, but here's my challenge to you. What if I wanted this, but all the numbers should be multiplied by 2? So I want a list where this equals to 0, this is 2, this is 4, this is 6, this is 8, this is 10, so on and so forth. How can I do it? Well, we can actually expand upon this so that my list 3, this time around, will use the same for loop that we've seen before, like this, but instead of just the variable, this is now an expression of how we want to act upon each character, just like we saw in lambda expressions. So I can now say num times 2 for these items. So now if I do my list 3, hey, check that out. That's pretty nice, isn't it? Okay, let's make it even more challenging. Let's say my list 3, and let's make this a little bit bigger here. My list 4, I want to change it so that in my list, I still keep here what I have, the numbers, but I want to only keep the even numbers. In this case, all of them are even because they're multiplied by 2. But if, for example, we do to the power of 2, and let's comment this out for a second and click run, we see that some numbers aren't even. So I want to keep these numbers, but only the even ones. How would I go about doing it? Well, in this case, we have a new way of creating this list expression. We'll do the exact same thing that we've done here, so I'm just going to copy that. But at the end, remember, we now have an expression here, something that we're going to do to affect whatever the item in the iterable is. We're going to loop through things. And then finally, after this, we can say if, or we can do an if condition. So let's say in our case, I'll say if num modulo 2 is equal to 0, only then add it to the list. So if we click run, and make sure that it's list 4, click run. Look at that. All of these are even numbers. So let's look at this format. Remember, these are called list comprehensions. It's a way for us to quickly create lists with Python instead of looping and using append or things that we've seen before. So it's a shorthand form for us to do things unique like this. The way we're able to do this is to have an expression here of what we want to do with each item that we're iterating over. We loop using a for loop through an iterable. We give it a variable, which we're going to act upon. And then if we want, we also have an option to add a conditional and say, hey, only include it into the list based on this condition, based on a true or false. Very, very cool. Now, although list comprehensions are really nice because they're just simple one-liners, it can get pretty confusing. Looking at this code, you have to be really familiar with list comprehensions to really understand what's going on. So although this makes code shorter, maybe even cleaner, it does take away a bit of its readability. So it might be better to just create a descriptive function like generate list of even numbers or something along those lines, so it's more descriptive and another developer might have a better idea of what's going on. So it's always a trade-off. Let's take a break and talk about set and dictionary comprehensions in the next video. Bye-bye. Let's talk about set comprehensions and dictionary comprehensions. Now, this first one is actually quite easy. You see, because we can do the same thing that we've done with lists. We simply change these bracket notation to a set, which is a curly bracket like this. So that if I do my list, the first one, I get a set. Same with the second one. If I go like this, my list 2, just like that. And I think you get the idea. Let's do one more on the final one. So my list 4, again, you're able to do set comprehensions on sets as well, a quick way for us to generate sets. And remember, sets only allow numbers that are not duplicate, only unique items. What about dictionary comprehension? Well, let's do something like this. Using the same formula we've used, let's create a my.dict, and in here, we're going to create a key and a value, just like that. And this key value can be acted upon. So in our case, let's say we want to multiply the value by 2, or to the power of 2. So this is what we want to create, a key value pair, and the value gets acted upon. Now in here, I'm going to say another for loop, for, so let's say key value, and then in, well, in what? What are we going to iterate over? Well, let's think here. In order for us to create a dictionary, we need both a key and a value, right? So I need to pass it an iterable, but I need to pass it an iterable like a dictionary that has both key and value. So we can do something simple here. We can say simple dictionary that will have A as 1 and B as 2. And now all we do is pass simple